So I think in the paucity of time, we will start still very early for a city like Mumbai, where I'll take a couple of minutes to set the tone for the day, and then we'll get into action quickly, and then those who come later can join us. So good morning, everyone. Welcome to this 198th edition of the Zak World of Façades conference series. My name is Ahmed, part of the organizing team here at Zak. I'll just quickly take a couple of minutes to introduce the event. So we've been doing this event since 2012. We started on the 27th of June 2012 back in Bangalore. The event's grown phenomenally across the globe. A lot of people think it has to do with us, but I think it has to do with more complexities in the building envelope in the facade. Sustainability has become a big factor. Complex geometries, more complex buildings with complex facades were starting to be built, which meant that there was a lack of vacuum on facade design and engineering knowledge. So we were able to cash in on that at the right time, and we were able to take this event from India to different parts of the world. So if you see, this was our lineup for 25. We have events from Canada. Check the screen. Yeah, we have events from Canada till New Zealand, so they're spread all across the globe. We went to a lot of new countries which we never thought we will ever go. Georgia was one of them. Uzbekistan was one of them. Super fast growing construction markets. In fact, they're doing much better than majority of the European Union states in terms of construction and in terms of project sizes. So we went over there where they've never had a facade conference at all. So we went and executed events there, and we keep exploring new places. We're going to Tirana, which is the capital of Albania next year, which is again has, I think, around 70, 80, 200 meter plus towers approved over there. One of the fastest growing markets in Southern Europe, and we keep exploring. We just keep going to different places where we can have people sharing their knowledge on facade design and engineering. It's the same case here today. We've got different speakers from India, from overseas, who are talking about the way they design, engineer, install facades. And something which we are always very conscious about is we'd like them to talk about their work in India majorly, because in India is not with their own set of challenges, so we don't want them to show the complex projects which happen in China or other parts of the world, but something which is more buildable in this part of the region, which is being built or has already been built. So I think our speakers would be giving case studies and highlights from their work from India, and probably a couple of examples from across the region. To just give an idea of what they do in other parts of the world. These events are courtesy our event partners, so I'd like to thank all of them. I'll take a moment to mention all of them. So starts with our presenting partner, Shuko. So of course, when we started with Shuko 10 years ago, the aluminum door window facade system market was in a very nascent stage. It's developing now. Shuko is leading the way in that segment. So they are from Germany. They are world leaders in the aluminum door, window, and curtain wall system segment. And they have been a proud supporter of this conference series here in India and globally. Powered by partner Aluplex, again one of the leading facade engineering companies here based in India, out of Bombay, Hyderabad, doing projects nationally. So they are powered by partners. Alias, so Alias are debuting with us for the first time. They've got a photovoltaic product, BIPV, which is building integrated photovoltaic. Not yet very popular in India, but it's picking up momentum in other parts of the world where you can use photovoltaics on your facade to generate energy and make your building a net positive building. So BIPV is slow in India, but it will pick up. Alias have some nice solutions, and it's no more ugly BIPV. You've got different finishes. You've got now transparent BIPV is also coming. So there's a lot of innovation which has happened in the photovoltaic segment. Alpolic, whose partner are Diamond Engineering Corporation, are again global leaders in aluminum composite panel companies. In aluminum composite panel, Japanese company, one of the part of the Mitsubishi Group, one of the leaders in their segment. Aluform is from Germany, so they've got aluminum cladding shading solutions, again represented by their partner, Diamond Engineering Corporation. So we have a couple of Diamond Engineering partners here, so you'll hear this reference a lot. Aluminium Duffel are a solid aluminum manufacturer out of Duffel, formerly known as Alaris, and their coating partner is Coil out of Belgium, if I'm not mistaken, again represented by Diamond Engineering Corporation. Assa Abloy, again global leaders in several products. This is their automatic door division, the entrance doors which is exhibiting with us. Blick is from Poland, so they've got fixing systems for stone and other cladding materials, partnered up with Diamond Engineering Corporation. Cotswold is from Cotswold, from the UK. There's a lot of love between the India and UK over the past few days and months, and Cotswold have solutions for doors, windows, facades, the hardware mainly. They manufacture in the UK and in India. Dow, again global leaders in sealing and bonding solutions, formerly known as Dowsil, which is now rebranded back as Dow. EdgeTech, which is a subsidiary of Quanex, they've got warm edge spacer bars. So they have better U values than your conventional aluminum spacers. So warm edge spacers is being used to reduce the U values of the glass units. FG Glass, one of the leading value-added glass processors based out of Mumbai, operating nationally and internationally. FunderMax from Austria, one of the leaders in high-pressure laminate solutions. High-pressure laminate was an interior product which they were able to, laminates was an interior product which they were then able to make it as a high-pressure solution which can be used on the external facade for various applications, for cladding, for soffit areas and other places. GU is from Germany, so they've got hardware solutions for doors, windows, and facades. Innovators, again, one of the leading facade engineering companies based out of Mumbai, operating nationally with several references across the country. Kinlong from China, again, started off as a glass hardware tool fitting company, but then has a wide portfolio of product. They keep buying a company almost every month. They own more than 70, 80 companies now, so can't go with their product range. Curare is the mother company of the laminated glass, Interlayers, Throcifol, and Sentry glass. So all your laminated glass, majority of them would have an interlayer from Curare. Momentive, again, part of the GE group, again, global leaders in sealing and bonding solutions, represented by Diamond Engineering Corporation. So Qtone is an Indian company based out of Gujarat into ceramics. We know them as a tile and sanitary ware company. They've engineered their tile which can be used on the facade. So the ceramic facade revolution is just starting in India. I think that's going to pick up momentum with more sustainable options being asked by people, and people wanting to move away from metallic colors, going to natural earthy colors. So ceramics will pick up. Qtone is leading the way in the ceramic facade region, ceramic facade industry in India. Raina Industries does GRC cladding products. So glass reinforced concrete is an eternal cladding product. It's being used in various infrastructure projects, but also on the building facade, and they've got a lot of products regarding the same. Sika, again, a global leader in several construction chemical products. Their FFI division, which is the facade fenestration and insulating glass division, caters to our industry of doors, windows, and facades. Apart from that, they've got other value-added products for the building envelope. So one more global Swiss company with us today. Technorail from Gujarat, again, they are pioneers in modular aluminum railing systems, freestanding aluminum railing with laminated glass or toughened glass. So Technorail are also exporting across the globe, I'm being told. Terraco is a Swedish company, and they've got, again, an interesting solution, EIFS, External Insulated Facade System, which is, again, a different type of a facade cladding system, which is preferred by a lot of companies, and they are, again, represented with their local partners, Diamond Engineering Corporation. Vitro Architectural Glass, we know them as PPG Glass. They are now called Vitro Glass. SolarBan is their brand, one of the world leaders in coated glass solutions. Viva Composite Panel, again, a very proud Indian aluminum composite panel manufacturer who is exporting across the globe. They are known for their 300 plus finishes for the composite panel. And of course, now they have engineered into solid aluminum panels and a lot of other stuff. They started off as a retail ACP manufacturer and now are doing high-end projects, solid aluminum, non-combustible stuff, and going global. And of course, the basic pillars of these conferences were our exhibitions, which was started back in 2003 with a glass processing exhibition, which then evolved into a doors, windows show in 2006, and then the aluminum extrusion show in 2009. I think by that time, when we were there in 2009-10, we were getting a lot of requests for people wanting to come and present and have a different kind of audience. And that's when we decided to start this conference series a couple of years later in 2012. Quick glimpse of our next few events. So our outside India, or I would say probably in the series, our second largest event in the series is in New York. That's next week. We're close to 700 people attending that event. That's next week. Then our largest in the series is our London event, which is next month. We're close to 1,000 people at that event. London has a lot of audience from mainland Europe, which comes and attends. We have a gala awards dinner with the Society of Facade Engineering, whom I'm going to be talking about in a minute. And just a glimpse of our events for India next year. Of course, we repeat Mumbai every year. Mumbai is the hub of facade engineering in India. You will have several references of projects today which are designed in other parts of India from Mumbai. We return to Chennai, Ahmedabad, and Delhi. And of course, all these places have references of their own local projects. Couple of things for today. We have a launch of the Society of Facade Engineering today. This is at the end of this session, where it's a non-profit organization which is partnered up with SIPSI. SIPSI is the ASHRAE equivalent, for those who know ASHRAE, which is the American Society of Heating, Ventilation, and Fridge. So their equivalent is SIPSI, which is ISHRAE in India. ISHRAE is the ASHRAE equivalent. So SIPSI runs the Society of Facade Engineering, and the Society of Facade Engineering has several chapters across the globe. They're going to be launching their Indian chapter today. We will have Ashish Kapoor, who's a member of the SFE India, which is being formed, making a presentation on the same. Apart from that, we've got presentations from different people. We've got from architects. We've got from an architect who's designing a billionaire's home in Bombay. We've got an architect who's designing homes for HNI customers on the coastal road. We've got architects who is designing for all corporate companies in Bangalore, Hyderabad, Pune. And then, of course, we've got the architect for the most talked about project this week, which is the Navi Mumbai Airport, which would be presented after lunch. So that's the first talk after lunch. So we've got a wide range of speakers from Singapore, from the UK, from other parts of the world. And of course, we've got our Indian facade consultants talking, our product manufacturers, and we've got also a very unique talk, which I think probably is the first time we're doing it in India. We've done this in other countries, is between an architect and a facade engineer. Hyderabad's tallest residential building is being designed and engineered from Mumbai. So we have a joint presentation on that, on talking about an architect and facade engineer's collaboration. So we have a very interesting program. All of them is recorded, and those who have allowed us to share their presentation with you, you'll find their presentation on a YouTube link, which would reach you a week from when we complete this event, ideally by next Friday. We've got tea, coffee, lunch throughout the day. Networking is open throughout the day, but I would suggest that we do it in the breaks, because this beautiful venue, we couldn't partition the way we wanted to partition it. So there are gaps where the noise can come, which we can definitely hear the exhibitors now networking. And we've got also post the event, we've got tea, coffee, snacks being served. So we've got a long day for everyone to network and see the booths. So that's it from me. I went as slow as possible so that we can build some time for more people to come in. And I'd like to just call upon today's host and convener, Ms. Khushbu. From Studio Emergence. She's going to be taking you through until the end of the day. She's going to be introducing all our speakers, and all our sponsors are there. Please do meet with them in the networking breaks. Tea, coffee, and snacks are going to be served here. Most of the lunch is going to be served outside in the foyer area. So I hope you enjoy today's event, and I hope you enjoy this beautiful venue. It took us a lot of effort to get this venue. It's not the easiest to get. Mumbai is short on high quality convention centers. Probably it's the only one of a world-class stature. So that's it from me, and I look forward to meeting you guys in the break. Thank you.
Thank you. Thank you so much, Ahmed, for setting the tone of the day for us. Good morning, ladies and gentlemen. Welcome to Zak World of Façades 12th edition in Mumbai and 197th global edition for the conference. First of all, thank you very much for being here. It's great to see you all this morning. It's very early for you to be in place in Mumbai. It is my pleasure to be your host today. I am Khushbu Davda. I'm an architect, and I represent Studio Emergence. I'm one of the co-founders of the firm. We are based in Mumbai and London. If you can play the video, please. So we specialize in facade design and serve as parametric consultants, bringing together research, computation, and design innovation. At Studio Emergence, our design ethos revolves around parametric systems that respond intelligently to context, climate, and user needs. We integrate biomimicry and optimization-driven design to achieve balance between performance and buildability. Our portfolio has spanned diverse typologies and scales, from a planetarium to a bungee jumping arena, a lot of resorts to even high-rise residential and commercial developments in Mumbai. Our London office is led by my co-founder, Sija Sudhakaran. She anchors our expansion into the UK and the Middle East. Sija actively represents the studio through design discourse at the London Festival of Architecture, Material Matters, and through ongoing industry collaborations. Collaborations lies at the core of our practice. By partnering with architects, engineers, and consultants, we deliver structurally optimized, cost-effective solutions that address complex challenges through advanced computational design methodologies. But we always say at Studio Emergence, let the complexities end at the drawing table so we can all make buildings faster, better, and more sustainable. Thank you so much for having me here today. We have an exciting lineup of speakers along with an exciting and interesting panel discussions later today. I hope you all have a good time. We can start. So before I introduce to the speakers, may I inform you that we will not be taking questions for the speakers during or after the presentations, but the speakers will be around the networking area later, where you can have the opportunity to speak with them. I think we are now ready to welcome our first speaker. Please give a big round of applause to welcome to the stage José Cláudio Silva, who is the principal designer at 10 Design from Singapore.
Hello. Hello, everyone. Thank you very much. I'm José, design principal from 10 Design. And today, I'll have a couple of slides. Actually, I was a bit ambitious. I might have too many slides, so some will go a bit fast. an introduction of the company, what we do, and then we'll go through 3 study cases, which I thought they were quite important to show here today. So first of all, we are a front-end design company. We are only 15 years old. Actually, today is our 15th birthday. The 10 design comes from the 10 design, from 10th of the 10th of 2010. We grew very fast. We are almost from inception. We are among the top designers from World Architectural Festival. We do our expertise spans from architecture, master planning, interior design for retail, and then the sectors. We work in almost all the sectors, exception maybe to industrial sectors, from master planning to mixed-use developments, retail and interiors, residential, from high-rise to mid-rise, low-rise, hospitality, also from integrated resorts, low-rise, high-rise resorts in the islands and so forth. Office, also from high-rise, low-rise, biz parks and all that. Learning and sciences as well, to a certain extent, very similar to business parks. This is our geography. 5 years ago, when I set up the office in Singapore to cover Southeast Asia and India to a certain extent, it was the 4th office. Today we have 9 design offices throughout the world, so you can see how we have expanded. We were, a few years back, we were acquired by Aegis, and it's important to show, just to understand that we are part of a network of architects that also offer transportation architecture, also offer stadium architecture as well. So when we need that kind of expertise, we can tap into them, and we have a network of offices throughout the world. So I'll start by showing a couple of future projects that we have been involved. These projects are quite unique. This NEOM in Saudi Arabia has allowed us to do this kind of fantastic projects it's between almost like the academic project and the reality, but actually it's becoming reality. So these buildings are being built at the moment. We did a couple of projects that I brought today just to show very quickly. The Epicon, which is this one, hospitality project, and also Norlana, which is a master plan integrating a marina, but also very much focused in sports, in horse riding sports. And you can see, I mean, there's a aspirational in Saudi Arabia. Even the sun there looks a bit bigger than everywhere else in the world. But anyway, this is some things that we have been doing throughout that region. But it's not what we do in the first instance. We do reality projects. And I'll start by, I brought today 3 cases which I thought it was very important to bring. One is a residential tower in Mumbai, a very peculiar kind of context. Prince Bay Tower in Shenzhen, and I heard Ahmed mentioning about not bringing things from China. But I think this project is quite applicable to Mumbai to a certain extent. And then Aspira Tower, a project that we have been involved for a few years, and has been bringing me a lot of white hair, to be honest. But I'll show you later on. So I start with the Mumbai one. It's what we call the adaptive design or adoptive design. The reality is that we in this one, we are facade design consultant. There is a facade consultant. There is, of course, there are other consultants around. And the project is located in a very prominent area of Mumbai with fantastic views, but it's not a typical project that we do. This is a project where the client came to me and said, look, the structure is done, has been there for 10 years or 8 years, and we would like you to design the facade. We said, no, we don't do that. But actually, throughout conversations, I did enjoy talking to the client and the program, and also having the opportunity to work in Mumbai. And it's a 23-story tower for one family only. And we thought it was quite a challenging project. This is pictures of how we found the project, how we saw the views from the project out, and we were quite challenged. This is, again, not typical projects that we do, but we're quite challenged to how to bring something interesting to the project with so many pre-existing conditions that we had to deal with, understanding loadings in the slab edges condition, all the things that we could have to consider, and at the same time bring something unique. And we brought something that, I mean, I'm not going to elaborate too much in the concept. We went through different concepts with the client. This was eventually the one chosen. And we were really exploring things like bringing those double height spaces, bringing them out, having them in a very expressive way throughout the tower. It's elegant, it's different, it's Indian, you know. I mean, we thought that a lot of India, a lot of Mumbai into it, and it's quite dramatic as well. And we could only do that with a very close collaboration with a local contractor, which would, I mean, I don't hesitate to mention, Dural has been working with us from start to tailor to make these details possible and buildable and high quality and high finishing. And I was also lucky that the client wanted us involved throughout the project, also in construction supervision and the quality control. So we were, again, just going through relatively fast some of the documentation we did, some of the different parts of the project that we developed, and also conditions that we developed together with the contractor to control again the quality. There was a lot of small details. It was the first time that the contractor was doing, like curved panels, triple, quadruple laminated glass with the air gaps and all that to install. We brought also not only the facade, but also like a stainless steel pool top of the tower, so it was completely watertight and detached from the structure. We didn't know exactly what we could find in that concrete structure, if it was well waterproofed, if it was not, and so forth. So we wanted something independent, light, that we could work with. But this to show you as well how intense was the coordination and the testing and the will from the contractor also to work with us to achieve a high standard that we were looking at by doing 3D printing of the profiles, testing the integration of light, testing the integration of all the details, and then testing in mock-ups on site, with also the collaboration of the client to come over to us to check exactly situations that we had throughout the site. And you can see this is already like almost like a mock-up one-to-one, not the final one. This was not yet to acceptable level, as per the contractor would tell me. And so it has been a great pleasure. You can see, I mean, super high performance kind of glasses and details and so forth. And this is where we are today. So as mentioned before, I also wanted to bring the Prince Bay Tower. This is being built, actually. It opened already. This is in Shenzhen. I'll go very quickly because I wanted to focus in the third project a bit more in detail. But this one is really like, let's say, a condition where it's between the sea and the mountain. And it's a very prominent area of Shenzhen, a new area. It's a new location, let's say, where the client wanted really a very affirmative design. And we went, and the client is very aggressive in terms of efficiency of structure, the real estate value, how much he can get out of each apartment and so forth. And we ended up with a scheme that was a single point tower, which maximized the views, but also had efficiencies in terms of vertical transportation, structural, and so forth. And going a bit fast, this was the site as we had at that time. This is one of the testing with some modeling, and then our renders and modelings and studies all the way through the tower. What was the views that could be promoted and achieved within the tower? What was the visibility as we get from Shenzhen, as we get to that neighborhood? The programming. And the tower, the facade, really reflects exactly the programming. As you have the low zone, you have a certain level of units, and as we go to the high zone, as bigger units, and eventually in the top, those indents start to be. So the typology as a high zone only had 2 indents for the lobbies, and then eventually in the upper floors, again, with only the 2 indents, and that reflects. It's almost like designing the facade inside out, very, very efficient. It's a point block. It's not too expressive, but it's there. It's a competent, aggressive, efficient, high-performance facade and tower and luxury apartments. And I will not go too much in detail about the planning, but this is some of the concepts that we have progressed with, and what we brought to the facade, some kind of play within this point block tower, and what we could achieve at the end. And it's built. Today it's one of the icons of Shenzhen. I will not go too much in detail. Amenities, something that we also, of course, play the role in the expression of the tower. Finally, this one I wanted to bring is very complex tower. This is, and we decided to invite Cláudio because of the complexity of the geometry as well. We have been working with them from starting this project. And this is being built. I mean, we have been working on this for 4 years. It was a couple of 2 years of interval where the client was not too sure that they were going to build the tower. But this is where we are today. These renders were just came out from the oven last night, actually. And this is an island off an island, and we wanted to bring something nautical. The client wanted the tower to be iconic, to really to be a symbol of the development they are investing there. Right now, at the moment, the only way to get to this island is through a cable car. So you can see the investment from this client, how they wanted to really to bring something, really to invest, bring something special to the community, something special as a destination in Vietnam. And again, this is an island in Phuc Quoc. It's Tom Island, so it's in Phuc Quoc, right? So off Phuc Quoc. So as you get to Phuc Quoc, we still need to get a cable car to get to the island. This is the island. We did all the master plan, resort master plan. There's a couple of other programs going on in the island. And this was the master plan. You can see the tower on the right side, which is the north part of the place, so facing west. So it's really dramatic. The client wanted, it was part of the brief, that it had to be a nautical theme. So we did go through many options of kind of billowing sails and types of sails to give this impression of a boat, and the client finally accepted this one. Important, again, to be island off an island is how to build anything and how to build something with this geometric complexity. And so to have a full grip on the geometry and how we could optimize the geometry, having the expression that the client approved, that the client wanted to, that was fundamental for us. And that was fundamental to also to understand where it could be optimized or industrialized or built off-site and bring to site in a standard way and just plug into the facade. Of course, the structure was something really important, really peculiar, and we had to deal with very closely as well. It's basically 2 cores. There's a few transfer slabs, which they work as outriggers as well. And then there's this gable goes all around with these bracing trusses that hold the whole building together. And then there's fins and so forth. And I won't go into much detail about the planning, but it's quite sculptural. It's an island that there's no vehicles, only buggies and bicycles and so forth. So also the operation, all the scale of the operation, the drop-offs and all that are a bit different from usual. But here we are, so several details and studies of this tower to be as expressive as we could, and to have this effect of 2 billowing sails and kind of floating. We did have to invest in several different types of facades, and we were working together again with Cláudio and the client so that we could make them expressive, but relatively easy to build and not compromising the geometry of the building. And this, of course, there's other non-typical situations throughout the building to keep that expressiveness, let's say, that we wanted to keep, and the client was very happy to promote and to back us up. So these are some parts of our documentation that we have been doing, parts of how how we worked with Koltai and trying to optimize geometries, trying to have equal panels as much as we could, trying to minimize curved panels, trying to keep the expression again, but not having all the panels different or making it impossible or too expensive to build. And that was one of the issues we had from start. And the balconies were definitely, the balustrades was definitely one of the challenges, how we can group balustrades in segments with this geometry where in theory every panel is different because it curves in 3 directions. So we wanted to work with the facade consultant on that and could achieve some grouping of equal panels, so that is relatively easy to bring and just plug in the structure. And it has been, it has been a challenge, but has been also quite rewarding. At the moment, is under construction. Of course, we had to go through things of the BMU, how to integrate the BMU in this kind of, again, complex geometry, but also to hide it when it was not under operation. Quite difficult, as you can see, quite challenging how we could resolve that, and we did, and it's now under construction. And I'll put a quick film that just came out from the oven as well last night. So maybe gives a better understanding of the complexity. Can it have sound, please? Complexity of the tower. Wisdom. Quite a dramatic film. So hopefully we'll be able to work more in India and more in Mumbai, and hopefully you like the presentation. Thank you very much.
Thank you so much, José, for sharing all your wonderful projects with us. May I next welcome Ashwani Khanna from FunderMax.
Good morning, ladies and gentlemen. My name is Ashwani Khanna, and I represent FunderMax. Thank you, sir. It was really a wonderful presentation. Before I get into thick of things, my topic, I would request everyone to participate in Menti. Could you please take out your phones and open menti.com? I would like to have your views on facade, because we all are here to discuss about facades. The moment you open menti.com, you would be asked the code, and code is mentioned on the top of the screen. It's 26962348.
He's there.
5 people have logged in. I can see more than, let's say, 200 people in the room. So, requesting everyone to participate, please. Wow, 44, 45 people have logged in. So reflection, sustainable, MA, robust. Someone is saying Amit. Maybe they have mentioned their name. Sustainable is becoming bigger. Yeah, facade has to be sustainable in nature. It's the character of the building. It's the face of the building. It has to be fantastic. It has to be unique. Okay. Thank you for your participation here. I'll move to the next question. What is your expectation from the facade material while making the unique design? Durable, yeah. Again, sustainable is coming into picture here. It has to be climate responsive. Aesthetics, durable is becoming bigger. It means more people are saying it has to be durable. And sustainable is now becoming bigger, recyclable, cost effective. And there are many other points, easy maintenance, safety, long lasting. Thank you. I'm moving to the next question now. What are the key considerations for designing a facade system for high-rise buildings? Because, you know, we are in Mumbai and Mumbai is all high-rises. Same answer, durable. Wind load, yes, thank you for this. It should be safe. Someone is talking about fire safety. Thank God it is there in this Menti, because that's my topic as well. Wind load, structural stability, safety. Safety is becoming, bolder here. This is my last question for the Menti. What role does facade material play in ensuring the fire safety of the building? Because that's also one of my topic today.
Yes, starter. This should be.
Yeah, it's utmost. Really very, very important. It has to save lives. It plays a key role, most important.
Is it?
Yeah, it's a question of life actually.
Without that, is good.
Someone is saying material. Yes, material also plays a very important role when we talk about fire safety of a building. Compliances to the codes.
I like the paintings.
Fire safety, critical. Yeah, it's very critical. Thank you. Thank you for your participation. I really say thanks to everyone. Now I'm coming to my presentation. As I said, we are going to talk about double skin facade. We are going to talk about class A and class B material from FunderMax and what is the fire behavior.
Yeah, they're good. Yeah.
Thank you. Yeah, and we are going to talk, I'm going to show some references from high-rise buildings which we have executed from FunderMax. Why double skin facade? Actually, we are talking about energy efficiency when we talk about double skin facade. We are talking about thermal comfort for the occupants of the building and providing natural cross ventilation. So if you look at this project, this is actually a double skin facade in one sense. This is executed in Lucknow. It was a glass building and the whole purpose was to provide a shading to the building and thereby optimizing the shading coefficient. Another option is the horizontal louvers. This is the project in Raichur. This is a college project. Here the angle of louvers is decided based on the sun path analysis. Again, providing visual and thermal comfort to the occupants of the building. It can help in reducing the excess glare. It's a sun shading device actually. This could be manual as well as automated. And these are vertical louvers. If you really look at the building on your extreme right, this is basically project in Kerala, facing the tropical sun throughout the day. This is semicircular building. And again, the angle of louver is decided based on sun path analysis. Same concept, same principle. it helps in reducing the excess glare inside the building and giving thermal and visual comfort to the occupants. This is about double skin. Now I'm coming to the next topic, which is fire. Now, what is actually fire? Fire is the rapid oxidation of material in exothermic chemical process, thereby heat and light is produced. Now, based on the source of fire, you can classify fire into A, B, C, D, and K. We normally look for these kind of logos on the fire extinguishers when we have to extinguish the fire, depending on the source of fire. I give you example of A. It is the normal combustible material like wood, paper, rubber, and dry powder, or even water is sufficient to extinguish the fire, which is not true. So it is very important to identify the source of fire, because when it is B, coming out from flammable liquids, water is not sufficient, water is not good at all to extinguish the fire. You need dry powder or carbon dioxide to extinguish the fire. Similarly, C, D, and K has different properties and different extinguishing is required. Now, when we look at FunderMax as a product, we have class A2 and class B material. Now, the earlier classification was about the classification of fire. This is the classification of the material. Now, when we talk about class A2 material, this material will reach the ignition temperature and it will not cross it. So it is a non-combustible material. And when we talk about class B material will actually, reach the flashover point, but it will not cross the flashover point. This is very important for, building material when we are using it for fire protection, because it will not cross this point and it will not develop into a full-fledged fire. It will not reach the peak. So, our A2 class material is non-combustible. The entire classification is A2 S1 D0. S1 is smoke index. On scale of 1 to 5, it is very less. It is only 1. And D is droplets. So droplet is 0 in this particular material, and we call it as M-look. On the other side, max exterior panel, which is class B material, here the smoke index is 2. Instead of 1, it is 2, and droplet is 0. And it comes in different formats, different sizes. This can help in optimization as well. Whereas both the material also comes in similar decors. So if there are two tall buildings, this face and this face could be A2 class material, other faces could be class B material. This can help in optimizing the cost as well. So we comply to ASTM E84. As per that, we are class A. We also comply to British standards. We are class O or class 0 as per that. EN standards we have already discussed. We are BS2D0 and A2S1D0. And we also comply to NBC 2017. We also have NFPA report with us. I wanted to show this picture actually. This is really giving, I would say, the incomplete picture because we don't have permissions to show the full project. This was a residential project and the fire broke out inside the room, and the glass, the fire came out from the glass blasted. I don't know what was the quality of the glass which was being used. And that was the point where FunderMax came in touch with the fire. The intensity of fire was so high that even the plaster was ripped off. You can see the exposed brick over here. And here, the FunderMax panel, the entire system is, not collapsed. Even the rivets have not collapsed. And this panel retarded the fire over here at this line itself. Since there was a gap here, the fire did not come to this surface. This is intact. And when we reverse the panel, the other side decor was also intact. So this is how this panel helped in retarding the fire. So class B means the moment we remove the source of fire, it will stop burning. It will not propagate the fire. We all know the accident which happened in Grenfell Tower also, wherein the material was propagating the fire. Now, since we do all the installations in high-rise in the principle of rear ventilated facade system, so the question can come that fire can, go up through the cavity because there is a cavity between the wall and the cladding. There we recommend the fire stop. Fire stop, the moment it comes in touch with the fire, it will expand and create the barrier as well as compartmentalize it. So fire will get restricted to the compartment. So fire seals are available in the market, and we recommend fire seal in high-rise buildings along with the cladding material. Some of the projects which we have done, this is the project we have executed in Mumbai. This is where, FunderMax is installed on soffits. The one project is in Bangalore. This is high-rise again, and right side you see drill project in Chennai. This is also in Bangalore. This is one famous building on Western Express Highway. This is ONGC, and this is cladded with FunderMax. This is in Mumbai. This is also in Mumbai. The left one, this is Vasant Kunj. And on right side, again, this is a residential tower in Noida. This is very interesting project. Actually, I'm talking about Mahindra Luminaire. Here, the combination of two thicknesses is being used, and the cladding is done on MS frame. The use of different thicknesses basically to optimize the cost as well as to take care of the higher wind load at higher floors. On the right side, we know this project. Here, we worked on more than 2.7 kPa, and the entire soffit is cladded with FunderMax. That's it from my side. Thank you so much.
Thank you.
Thank you, Ashwani, for your information. May I next invite the fabulous speaker on stage, Timothy Soebroto from Meinhardt Technologies, Façade Technologies from Singapore. Thank you so much.
Thank you. Good morning, everyone. Thank you. Especially thank you to organizer who having me for this conference. Before I start the presentation, allow me to introduce myself. My name is Timothy Soebroto. I'm come from Meinhardt Façade, Singapore. And this morning we would like to highlight high-rise facade balancing aesthetic and structural integrity and functionality. Meinhardt Façade is part of Meinhardt Group. This is our global footprint. We are not only facade, but we are engineering company. And here's our footprint for the Meinhardt Façade. We are not only doing the high-rise, but we are doing a lot of low-rise as well. Something like a casino, hotel, a concert hall, airport, and so on. In India, we have been in here quite numbers of years. We have office in Chennai, but from our Singapore office, we do some project in Mumbai and Delhi. Some project we did Worley Towers, UNESCO project, Dahlia apartment, and so on. The unique part that we do involve in India is the Statue of Unity when we did couple years ago. I will be explaining this project a bit during my presentation. This is I'm sure that some of you very familiar with this one, Mumbai in India, and Mumbai hosts more than 5,000 high-rise building, which is the most high-rise building in India. So Mumbai is crown capital of high-rise building in India, and basically tall buildings are very close related to the growth of city, especially in Asia, due constraints of the land. And this one also having impact to our daily life and working life as well. What is a tall building? High-rise building does play very important role in our life, especially in the spatial structural composition and image of the city, because they are spatially dominant and landmarks. Basically, what is high-rise building? According to CityBUH, tall building is building more than 50 meters, while super tall is more than 300 meters, while mega tall building is more than 300 meters. So this morning, we are going to explain or discuss about the design evolution or facade design evolution and the facade design consideration. First, about the facade evolution. This image shows the evolution of the facade. I like this image very much. In the foreground, we can see 500 years old building that is very complex in detail, while at the back is probably quite simple, but actually it's very complex in terms of technology. Double skin Shanghai tower, which I explain a bit in the future later. So this is the one of the first high-rise building, home insurance building. In here, the facade is combination between structural and architectural, and you can see the structural, which is column, beam, while the infill material is dominated by stone and glass. While in here, we can see the combination between structure. Structure can be seen. While for the modern era, what we can see is a completely separation between the facade and the structure. After curtain wall was invented, is something like there is separation between structural and the facade. This provides a lot of liberty to the architect to do facade design. In this project, mainly the shape of the facade is rectangular, and but this one is evolved. Also, the evolvement, we can see this image almost everywhere in Asia city. This is some picture from India city, mainly low-rise building. While now, because of a restriction of land, people going up. Petronas Tower, many years ago, was crowned as one of the tallest building in the world, and now still very prominent. Not only until now, this is a lot of tourists come here, and so what we compare to many years ago, compared today, is there is height evolution. Not only height evolution, but also the shape evolution. In this building, the shape of the building is not anymore squarish, but you can see from the plan, it's very complex geometry. And at the end, the facade will be very complex as well, especially for this project which is built 30 years ago. Another example of sample is one project in Nagoya, Japan, Modogakuen Spiral Tower, that the facade become very intricate with twisted facade design in addition to the complexity. In here, the facade or the glass is no more rectangular. If you can see from the picture, the glass is either triangular or diamond shape. And in addition, glass is no longer dominant material in the facade. We can see there are a lot of numbers of material can be explored. One of it is terracotta. Terracotta become very popular, not only in Europe, but also in Asia, China, Singapore, certainly in India. We have one project in Mumbai that the client might adopt terracotta extensively as a column cladding. In here, the entire column was cladded by the terracotta. We provided the drawing, 3D drawing to the architect, but there is a limitation on the terracotta, which is on the length. That's the reason why we might have several joints. Another material that might be considered is GFRC. We involved in these two projects, and the left one is Eden Residence in Singapore, designed by Thomas Heatherwick, and the right one is very unique resort hotel in Dalat, Vietnam, designed by Kengo Kuma. And GFRC and precast is extensively used in the Eden Residence, while GFRC is extensively used in the Dalat, especially at the balcony area. Another material that might be explored is GFRP. GFRP is glass fiber reinforced polyester. We did this material in King Abdullah project in Riyadh, Saudi Arabia. One of the benefits of this material is very light. But we have to taking care of this one on the UV resistant and the fire resistant as well. FRP is very common material that we might use it almost every day. You can see on the chair, MRT chair, or even on the boat that this one now used extensively in the facade as well. I'm sure that you are commonly see this one, woven rattan. I just came from Bangladesh, and this one I can find a lot in Bangladesh, in Southeast Asia as well. And now this become interior material. And we have one project and use this one extensively. 2-story project, residential project, and use this material extensively. We involved in this unique project, which is Statue of Unity in India. The material used for this one is bronze panel. It's not building, but this one is get a recognition from CTBU8. And the material was produced in China, fabricated in China. And during the design process, we have to do a lot of mapping, parametric design, a lot of mock-up to ensure that the building or the shape of the statue is in accordance with the reality. So this one we have to ensure. And the material was fabrication in China. And during the fabrication process, we heavily involved, and we have to send someone from Singapore to station full-time in China, in Guangzhou. And the material, we did a lot of dry lay process as well in India to ensure that the material can be assembling well. And after that, delivery from the assembling plant to site using a truck, and lift up every single panel by subframe and fix it to the main frame. And finally, this project is completed. Very challenging project, but a very rewarding project as well. We did a lot of arrangement, how to track every single panel. Facade innovation. There are a lot of facade innovation recently, but the most one that we have is a photovoltaic tech, which is now getting more popular, not only in the factory, not only on the roof, but also on the facade. Before you can find, actually the photovoltaic is affecting the aesthetic of the building negatively. You can see dot, dot, dot. But thanks to the major research, the industry have made huge progress, improved a lot, while the price is getting lower and lower. We have one project in South Korea, and it's compulsory to have a BIPV on the facade over there. And now the BIPV technology is improved, not only ugly dot dot pattern, but you can find different kind of color, different kind of pattern. And for this kind of project, where is the BIPV? You can find the BIPV on the 8th number of signage at the roof, the top floor. And this one is 2019 and contribute around 20.2 kilowatt power, which is 13.2 watt power per square meter. The last thing that we would like to discuss is design consideration from architectural, structural integrity, and user comfort. Certainly, the primary consideration for the architect to design is architect. They are our lead consultant. They design about shape, modulation, color, material, texture, and everything. But we should not forget about the structural issue as well. I'm sure that everyone aware on this one with the Mangkhut tropical typhoon in Hong Kong 2018, and the speed reached 70 meters per second. Couple years back, also another typhoon happened in Hanoi. There are a couple similar conditions happen. So, and this one is John Hancock Tower. It's very interesting for us to study. Built 1971 to 1975. And during the construction, the cost jacked up from 75 million to 175 million. And during that time, when the surrounding street need to be closed, when the wind reached 45 miles per hour or 72 kilometers meter per hour, and 10,000 more glass have to be replaced. And the cost of glass replacement is more than 7 million. And during the glass replacement, the facade have to be closed by plywood, and people cynically call this one is plywood range or plywood place. So these two projects are the sample of the facade which was not designed properly. So we have to understand the load on the facade. There are a lot of load on the facade where we have to discuss with our structural engineer, including the seismic as well. And the first one, the important one, is wind load, which is highlighted by our previous speaker. Wind load can be derived from calculation, wind tunnel test, and so on. Based on the study, India and Indian subcontinent has higher wind load, which is fall under zone 2, and northern India fall under zone 3, which is quite high. And wind load is not consistent throughout the building. Some area will be having higher wind load, especially on the crown, corner, everything. That's the understanding wind load is very important. Ahmed was in Singapore end of last week to watch Singapore Formula One. And I was questioned by Strada, did I watch it? Yes, I like Formula One very much. And to those who like it, certainly know this guy, Max Verstappen. What happened in the car industry, wind engineering is understand very carefully. So they study the wind. So if you can see, the shape of the car is following the aerodynamic shape. You never see there is boxy car become a sport car. So what happened in the building? We should be able to understand the winds as well. There are few steps how to reduce the wind load. One, soften the corner, tapering, setback, frying, cross-section, spoiler, porosity, opening, and so on. RWDI, Wind Engineering, did study on this very deeply. We're working a lot with them. Shanghai Financial Tower, what they did to reduce the wind load. They did tapering, spoiler at the corner, and opening. For this 600-meter building, reducing the wind load will significantly contribute a lot on the cost. Shanghai Tower, what they did, spiraling the shape. During the early design, the architect, facade consultant, wind engineering, and structural engineering did study many degrees of shape. And they found there are 5 options, and the extreme one contribute more. But after discussion between architect and everyone, they choose option 4. And 5% wind load reduction can contribute 10 million USD. And this is much more than the fee of facade engineering, structural engineering, architect probably. That's the reason why studying the wind is very important. Another load, live load, point load, surface load, everything I will not discuss in detail. So basically the facade should be able to take the building movement due to live load, wind load, seismic, and interstory drifts on the other direction, slab deflection, thermal expansion, column shortening. It's happened on the long or the large cantilever. What I'm trying to do, basically the facade should be able to take the building movement. And this one is reflected on the vertical and horizontal joint, which is some architect hate it, but we have to have it. So this is the calculation, horizontal, vertical, yeah. Then this is how we accommodate the building movement in detail. The last is user comfort. Now become very important. Thermal, daylight, visual, acoustic, air quality. And based on the American study, 80%, 90% of adults, 90% of kids stay indoor more often. And this one is getting more and more after pandemic era. So that's what happened. That's the reason why the indoor study become very important and the human comfort getting more and more critical. While on the other side, the external factor is getting worse because of global warming, pollution, and everything. That's the reason why facade getting harder to work hard, and the facade engineer have to think harder. Another thing, design consideration. I'm sure that this is commonly done. I saw a couple times not only in Mumbai, but everywhere. Fading color, leaking of the building, bad fire, hopefully not. So we are talking about durability and facade work quality. It's about correct design, correct material selection, installation quality, bad quality installation will happen, corrosion, and this one will affect the integrity of the facade, structural integrity of the facade, and also aesthetical as well. So poor of maintenance. That's the reason why as a facade engineering, we demand a lot of tests to be done, not only as a material test, system test, on-site, in factory, and so on. This one example on the right side is Petronas Tower. I took it a couple of weeks ago. 30 years building, but until now still looks very nice. That's because the facade designed carefully and maintained properly. So if last time I always tag that facade is about the fashion, but I believe facade is more than the fashion. Facade is more on the human skin, which is have a protection and protect us from the weather. So as a human skin need to be maintained, actually the facade have to be maintained as well. In Singapore, we have a regulation that the facade have to be maintained or audit every 7 years, and after that, every 5 years. Because certainly as a client, we don't want to see this kind of problems. So if you have a problem on the facade, it's something like doing a surgery. It will be very, very painful for the operational. So we need to think again how to balance between aesthetic, structural integrity, functionality, and cost. Thank you.
Thank you so much, Timothy. That was an insightful session indeed. I'm really looking forward to your terracotta facade building completing in Mumbai soon. Before we break for the networking session, we have one presentation from Rohan Keswani from Aluplex. Please welcome him.
So good morning, ladies and gentlemen. So today I'm talking to you about glazed facades for high-end residentials. And before I start, I'll just give you a quick introduction about us at Aluplex. We've done more than 500 projects over the past 40 plus years that we've been around. Today, BKC, we've done projects all across the country, right from the north, in the north of India, to the south of India, to the east in Calcutta, to where we are in Mumbai today. Talking about Bandra Kurla complex, where we are, so I just thought I'll just touch upon that. In Bandra Kurla complex over here, as you can see, this is the aerial view. We've done more than 15 projects. Some of the landmark projects as you came into here to this particular location, this marvelous venue we are over here. Some of them is, Timothy spoke about durability and Petronas lasting for 30 plus years. We've also done such kind of projects. The ILFS building. ILFS, unfortunately, doesn't quite exist anymore as a company, but the building has lasted, and it's been more than 20 years, and the durability has lasted over these years. The National Stock Exchange building is also 20 years. We have the Platina Tower, which is a building done in 2007. Very interesting facade. It had, we indigenously designed a particular secondary skin on the facade, which had a particular louver mechanism. These were automated and connected to the building maintenance system, where we were, basically we had these particular secondary skin of louvers, aerofoil louvers, that using an actuator were able to open and close based on the daylight that it was being imposed upon it. For the first time, we used curved glass at that particular time. Over here, we have the Bank of India building, also in Bandra Kurla complex. The SEBI building, which is also a landmark. The Citibank office. And most recently, the Apple store, which we installed over here with very, very large glasses, 10 meters in height, 2.5 meters in width, very large glasses. All the materials had to be imported, and we carried out the installation for Apple. But now coming back to my presentation, which is glazed facades for high-rise residentials. So as the buildings grow taller, basically it's important that there is a need for facade windows to have easier installation techniques, and therefore the preferred methodology is unitized curtain walling. Some of the projects that I'm going to talk about today are up here. One of them is Omkar 1973. There's the Lodha Park Towers in Lower Parel, the Rustamji Crown Towers, the Trump Tower in Calcutta, and lastly, the Voyage to the Stars project in Pune. So Omkar 1973 is a building designed by Foster and Partners that we have executed. This is what the facade looks like. Every element on the external skin of the facade is, as you can see, is whether it's the columns or whether it's the railings or every single part that you can see in plan. There's no visible paint that is done on the residential building. Every element of it is either glazed or cladded to give a feel of a building which is able to be durable and not have any weathering over a period of time. So we designed the balustrade system in a unitized system. The system involved a male and female mullion. Very interesting process to actually have these particular profiles that needed to be bent. We incorporated, there are different methods of bending. The typical method followed for bending is a 3-roller methodology, where you put in a profile and then you have 3 rollers that bend the profile. However, there are limitations to the radius that you can achieve and the depth of the profile. Over here, we're talking about a 260-meter building. So in order to achieve the bending, we needed a 200-millimeter deep profile that had to be bent. The other method that can be used is push bending. But what we adopted here was something known as stretch forming, where we had a standardized mold for the radius that needed to be bent and pulled the profiles from each side in order to bend the profile. That's how we got it done. I got it clamped, and the profile was accordingly bent. It was very important to achieve the tolerances. We did some mock-ups earlier, and we were not able to achieve either the glass tolerances or not able to achieve the aluminum tolerances. And we had issues where either when you place the glass on top of the aluminum, either you had the ends of the glass touch the aluminum, and in the center there would be a larger gap, or in the center, the glass would touch the aluminum, and then you'd have a larger gap at the ends. So what would happen is you wouldn't have a uniform structural silicon bite. So we had to be very careful in achieving the right tolerances. In order to do that, we had several mock-ups done. We had Dow Corning, who we worked with. Ravi sitting in the first over here is over there on the left, you can see. And we were able to then afterwards work with the suppliers to ensure, we had a 1:1 scale drawing. Each profile was checked prior to dispatch from the vendor's factory to actually see the bending was done correctly. We had the glass for this project was procured from China Southern Glass. And we had a stencil, or as we call it, a template, that was put through each glass, because sometimes you'd have the radius at the top being perfect, but then as you would go further along in the middle of the glass, you wouldn't have the right radius. So it's very important to have that. We had a stencil that was put all the way through and through the glass prior to dispatch of every single glass. Then we installed these particular panels, these curved panels, which were balustrade panels, and that's how it was installed. Today they are installed, and there's a video about it outside that people can have a look at. The other project I talked to you about is Lodha Park. Worked very closely with BES on this project. Over here we had a unitized system for the particular for pockets of the building. Something different we did at the time. Now we're using it more commonly is using a concealed sash. The idea being is that since the panel widths were quite low, around 800 millimeters, it was very important that we didn't have a plant-on outer frame. So then when you look at it from the inside, you don't realize that this is an openable sash and this one is a fixed sash. It looks, besides this just little hairline that we have over here, it's all that you know that it's an openable sash. So that's how the detail is over there. As you can see, that's the particular point where the openable hairline is visible over here. There's no plant-on operable to make the vision area less. We also worked with BES on the design of a passive ventilator system, and this passive ventilator was incorporated within the unitized panels to allow for ventilation without actually opening the windows. This is the whole passive ventilator design where there was fixed between the transoms. So this is how the whole detail worked out. There's a flap that would allow the passive ventilator, which is installed between the two transoms. There was a sunshade in the front, and air would ventilate from below the sunshade through the passive ventilator on the inside over here. That's what the building looks like now. It's completed. The next project I talk about is Trump Tower, Calcutta. This is a 42-story residential tower in Calcutta. So this is part of the plan, and initially the building had typical windows and the structure was meant to be painted. We worked with the architect, and the Trump team wanted to have an all-glass look. So we worked very closely with them and were able to develop a system where we had on the particular shear walls a glass rain screen cladded system, and the rest of the areas was a unitized curtain wall with a sliding window incorporated into the unitized curtain wall. However, for this unitized curtain wall, it was for the sliding system. Normally, you can see the frame of the sliding system. It was very important to the architect and the team to not see any aluminium on the outside. So we developed a detail where you had the fixed shutter and the sliding shutter, such as the sliding shutter was structurally glazed. So we had a step glass detail that was developed. And through the transom detail, we had the drainage go through the transom detail over here and drain out through the transom. So when you see it on the outside, you have an all glazed look. You don't see a big profile, a vent profile, which one would normally see. So that's under execution and should be handing over soon. The other project is Voyage to the Stars in Pune, which is another project associated with the Tribeca Group. And over there we had a railing which was adopted, was installed on the inside, on the stack joint profile, on the head profile. It was a very interesting design where we had a particular sleeve that was ensured that the rollers could slide over from one unitized panel to the next unitized panel. So we had a particular fitting that was developed to ensure that there's a continuous rail, even though that these transoms were separate from one unitized panel to the next. On the outside, we had a particular glass railing over here, rather than the railing on the inside. So that's the plan detail. As you can see, there's a separate unitized panel here, and a separate unitized panel here, a separate unitized panel here. And the sliding shutter was able to roll from one unitized panel across to the other because of the fitting across that particular fitting that connected the two rails. Another project we're currently working on is where we spoke about passive ventilation techniques. This is 25 South in Mumbai, where we have a system window which is over here, but we've incorporated a particular vertical ventilation system of 200 millimeters. So without opening the window, one can get fresh air just across the sea. Without having very, very high wind loads, one can have this particular ventilation technique. Similarly, how we saw it horizontally at the park, we have it vertically over here. last Zak exhibition, we had a panel discussion about this particular project. Very interesting project, done for the first time. And now more and more developers are looking at adopting this system, is where we had a system where we had very, very large sliding doors that were incorporated within a unitized curtain wall system for a 260-meter tower. So the way we had it done is we had particular spandrel panels that were first installed. We had 2 stack joints per tower. So we had 1 stack joint on the top of the slab, which is here, and another stack joint on the underside of the slab. So that double bracketing system, as you can see, we had bracketing on the underside of the slab and also bracketing on the top of the slab. This allowed us to reduce the size of the panels because we have a very, very large widths. So we needed to have a double stack joint so that we reduce the height of the panels. Once the spandrel panels were installed, we had these particular large 6-meter to 7-meter wide unitized panels that came in and went into the particular structure. And then you had the sliding shutters that went in, and then we had an internal glass rail that was installed after that. So this is how the whole detail worked out, where we had a particular, a separate spandrel panel with a lesser transom depth. That was important because there was a limitation on the level of the glass from how far it could go from, how far the glass could be from the edge of the slab, based on the FSI or GRA regulations as they have it over here. And then we had a sliding system with a fixed glass system that was incorporated above that. We had an internal railing over here behind the sliding shutters where that was aligned with this particular sill rim. So a quick short video about this project. While we wait for this, we have Ashish waiting up over here. If the sound doesn't work out, he can come up right ahead to launch the Society of Facade Engineering, where a team of 7 or 8 of us have been working very closely together. Look forward to that happening. If this is not working out, then we can, because that's how I was ending my presentation. So,
all your support over the years. With the advent of urbanization and the scarcity of land, we at Aluplex are happy to share with all of you that we've completed over 10 towers, 250-meter high. In fact, at this moment, we are working the facade project of the Rustomjee Crown.
So Rustomjee Crown is one of the most premium projects in Mumbai. It's a super high-rise project. The most unique feature of this project is the facade. In the West, the high-rise facade system have greater reliance on artificial ventilation and limited natural ventilation. It was Mr. Irani's idea to give a continuous facade which is openable to give that feeling of openness like a deck or an open terrace. This is something that has not been done in India.
This was made possible by innovation in design, engineering, and construction by incorporating large sliding doors without compromising on the high performance of the unitized glazing facade. This has never been done before and posed a unique challenge. This bespoke design facade system was tested in a performance testing laboratory rigorously.
The largest panel on site was 6.5 meters wide and 3 meters in height, and that was a logistical challenge. Aluplex organized the production, the dispatch, the unloading, the vertical movement, and subsequent installation to work all in sync to ensure there was a continuous flow of throughput. In case a bottleneck was identified, we ensured they were eliminated by adding additional resources of manpower and machinery to them. We had more than 350 labor working at various locations for the project.
I'm glad that we were able to finish this facade in a record-breaking time. With the teamwork between the Rustomjee team and the Aluplex team, we worked together to ensure that we were able to deliver a superlative product.
And that's the completed picture. Thank you very much. Over to you, Ashish.
Hello. Good morning, ladies and gentlemen. My name is Ashish Kapoor, and I have the pleasure today to introduce you to the Society of Facade Engineering, and I'm delighted to announce the launch of the India Hub of the SFE, as it is called. Sorry about that. So, why India? As you can see from the image, our country has produced some of the best facades in the last few years.
the facade industry is really coming of age in India, and which is why the SFE thought now is the right time to have an India chapter of the Society of Facade Engineering. It all started in 2022, so you can see it's taken almost 3 years to bring an idea into execution. And it started with Russell Cole of Arup, who's a member of the SFE in the UK. And we collaborated together to finally launch the new chapter in India, which is happening today, like I said. What is the SFE? It's a professional body of facade individuals, facade professionals from the industry who get together, exchange information, network, and talk about how to take the industry further. It's a society for individuals. It's not a corporate membership. It's an individual membership for which individuals have to apply to the SFE, and there's a process that I will talk about shortly. It started in 2004, so as you know, it's, you can see it's an association which is over 20 years old, founded in the UK. It started in the UK. The majority of the members are today in the UK, but we are growing globally very, very quickly. And it's part of an organization like Ahmed mentioned in his introduction note called CIPSE, which is the Chartered Institution of Building Service Engineers, which has several societies under it, and SFE is one of them. These are the honored members of the UK board for the latest, for the coming year, 25-26. These are all UK facade professionals. And as I mentioned, because the body was started in the UK, all these members are from the UK. I did talk about how quickly the hub is growing, or the association is growing all across the world. We have 10 existing hubs marked by the red on the map that you see, and 4 new potential hubs in India, Spain and Portugal, Greece and Ireland coming up. India launched today, and the others coming up very, very shortly. So we are growing very, very rapidly. I spoke about the memberships. So the types of memberships are on your screen. The detail is all there on our website. You can apply to any of these depending on what your qualifications are and where you fit. I, at the moment, am an affiliate member of the SFE in UK and now the SFE in India. We have over 2,000 members worldwide, majority being in the UK, but I said rapidly growing all over the world. And soon, of course, in India. And we are here today to announce the hub opening, to invite memberships, and I'll tell you how we do that. Before I do that, what are the main pillars of the SFE? What do we do? And we have 2 main pillars. We share knowledge among facade professionals. We network, we get together. We have committees. We speak about technical documents. We have technical presentations. And of course, we connect people in the industry through memberships and networking events. These happen regularly in the hubs all across the world. And we'll be announcing the first event in India shortly, which I will also tell you about. This is the founding and organizing committee of India, and I'm going to invite these gentlemen one by one on stage so you can see who we are. Ritesh, Jindal. Can you please give a round of applause to the committee, please? Gautam Bhasin, Rohan, Keswani, Lorenzo, Lily, and Mr. Rajan, Govind, please. Unfortunately, Russell couldn't be with us today. He was to make the presentation, and he's one of the active members in SFE UK, and Anthony John couldn't be with us, but the 6 of us are. We're going to be around. We have the details of the membership with us. We are here till the end of the day, so please feel free to come to talk to us, ask us how to become members, and we are here for you till the evening. Yeah. Ritesh, anything to add?
Yeah, hi. So, like we said, you know, this whole organization is being formed to uplift our own industry. It's to mainly share technical information and get all the expertise in one line. In the past few years, we have kind of grown quite significantly, as you have seen some of the projects. And with the launch of Navi Mumbai Airport, we are crossing boundaries in terms of how we are developing in India. And it needs a proper growth and proper plan for us, so we can be more technically there with the world, and come together and form the right standards, build the right benchmark in the industry, so we can keep making these world-class buildings. So please join us. We do have a QR code where basically you can scan and register yourself as an interest. Apart from that, we have an event planned very soon. Yeah.
Yeah, well, before that,
Sorry.
Ritesh, carry on.
Thank you. So, what will be part of this SFE India chapter? So, we have kind of, formulated or kind of come up with a few ideas that have been adopted across the globe, of which includes some of the awards for the projects. There's going to be technical talks, discussion between us, and we might also do some kind of project walks and case studies, actually going on site and learning and see how we can grow from there. So watch out for the space, please register. And our first event is going to happen very soon. Yeah. So we'll keep all this information via the LinkedIn page and via the interest that you have shared with us. It's going to happen either early December or end of November 2025. We are getting Russell finally for that, and he's going to be talking about what curtain wall is used for. So we'd like to invite all of you for that event. Please register. Please visit us for this event.
So here is the QR code. We all have it with us on our phones, the 6 of us. It's on the screen. I would request the AV team to leave that for 5 minutes during the break, so people can come up and scan, and it takes you to a form. It's a simple form that you need to fill out, and we get the data, and then we will come back to you and follow up for memberships. Thank you.
Everyone.
Thank you so much, gentlemen, and congratulations on the launch of SFE India. Yes. May I please request the speakers for the last session to stay here, and may I please invite Mr. Naveen Keswani from Aluplex to give the mementos to the speaker. And the rest of you all, please feel free to grab some coffee and be ready for the next session in about 20 minutes. And Mr. Rajan Govind from BES Consultants. I hope you all had a nice networking session and are back with caffeine for the next session.
Good morning, all. Nice to see all of you here, and thanks for being part of this session, which myself, Vrinda Shetty from Bentel Associate, and Rajan from BES Consultant will be presenting. So what we are presenting is one of the iconic development which we as Bentel we have designed, and BES has engineered it, and it's the project work has just begun, and what we are emphasizing here, how from the vision to reality we are bringing it in. So this project is in Hyderabad. 1 minute, yeah. Just to quick on us, I think we have a quite introduction. I'll go fast. This is Brigade Gateway at Neapolis. It's part of extension of, in fact, of the high-tech city Hyderabad. So well-known locality for one who knows Hyderabad very well. So the purpose of this presentation is to just to understand how from we are bridging what we as architects were visualized, and how engineering has contributed for us to take it further to reality. That's the whole intent of this presentation is. Just giving a small intro of the project, because for us to know the next level of how the project goes further is important in what context project is sitting and what is the purpose of the project. So this is whole part of the high-tech city development, which comes on the other side there, and that is a outer ring road. From there where the arrival to the Neopolis. Neopolis is a new development which has come up, extension to the high-tech city, which has heavy on the residential and some commercial developments as well. And what marked in red is what is the property we have. It is just a 9.7 acre land parcel where we are having a 4 million square feet development. Super built, I'm telling. Not, I mean, the basement all goes below as a 5 basements. What is above ground is, it's 4 million. So it's a very high density. So it asks for the tallness what we, as a designer, we designed it as. Directly getting into the plan, generally to explain the context of the project. So this is a land parcel, what I spoke about. It is L-shaped, a lot more challenges in terms of the levels in the main road itself. There is some 7 to 8 meter level variation in the main road itself. And we have 4 entities in this project, what is given as a need, as a brief by the client. One is a complete residential, second one is a commercial, which comprises 3 asset class. So it is a high density development with serving 4 asset class. So definitely almost 4 acre goes into the residential, which are standing as twin towers, and other 5.5 acres gets into the commercial. My focus will be largely on the commercial, while residential is part of the development, but the more interesting will be to speak about commercial more. So one is the circulation, what we play, because even in the commercial, we have to address the circulation of 3 asset class. There is no concept here, which has a rule in Hyderabad. They wouldn't allow us to go up and down on the surface, So all has to be at the same level. So with all these challenges, we have planned and we have designed, and we have given entry point for all 3 asset classes, combining at the ground level and the basement level. That again gets the direct access from the ground. Okay. And now for us to come into an exact subject, how these 3 asset classes into the commercial, how we are able to accommodate. Like, each thing has its need, right? Let us understand the purpose before that. This is as a vertical massing, like, how it stands, a commercial building. There are 5 basements. There is 1 asset class, the shopping center. Like, it's all 3 asset class with the equal importance. There is nothing undermining factor here. It's a 6 lakh square feet of shopping mall. And then there is a World Trade Center of 1 million square feet and around 330 keys hotel. So these are the 3 asset class, probably one of the kind in India, where 3 asset class with the equal status standing as one structure. So that's what we have here, towering up to almost 219 meter tall. So first 30 meter goes into the shopping center. The retail needs your interaction with the surface. So that's where it is. Your World Trade Center on the top, which can go up, compiling of offices. And at most 2, which needs highest visibility, is the hotel. Visibility for the user as well as for the outsider. So hotel goes on the top. So the massing extent itself is giving us a certain brief about the project, how it is staggered and how it is positioned. So while designing, we created our own purpose and objective as a designer, what we'd look for. First thing is the project context. It's located in Hyderabad. Hyderabad has its own elegance and certain characters, regional heritage, everything comes as a brief to us from the project as its regional context. The location of the project, it is part of the new development of Hyderabad, and location is almost to approach to that new development. So it is called as gateway to Neopolis, from where the name, the Brigade Group, who are the developer for the project, they're already having this gateway developments in various cities. They already have in Bangalore. The similar development was the intent here to bring up in Hyderabad. Then knowing, even in the Neopolis area, we have many residential which are going 200 tall. There may be some commercials. But this kind of asset class combination is unique. So that uniqueness has to be transformed into some iconic feature as a development. And with all these, considering the regional heritage and the local context, what we as designers, we keep in mind is we need to give it the whole a contemporary approach and the contemporary look to the building. So this is the whole purpose and our the objective when developing the facade and the developments. So in the whole process, like, this is an evolving market. The market is aspirational for this kind of a development. So we took up few factors apart from the local context, how the origin of life, like, how something is rising, sprouting from the root to its fullest form. That was our initial thinking. When we were brainstorming in studio, some of the words came up this was one the unique one. You rise from the root to the full form. So that was one of the key concepts which allowed us to come to a form what we gave a complete picture to this project. Another is Hyderabad, that is what we call as the sprout to a full form. And another Hyderabad known for it's as a city for pearls it is. So how that character of pearl we can bring in as a feature element in the project, may not be the holistic. We may decide to take it as part of the interior development, but for the first visual, how do you see that some part of the building as a jewelry form? That was the intent. As a form, it is stacked up in three forms. You see even the base being the shopping center, occupies the maximum coverage. It is the widest base. Then comes the office, which again, it's almost like a 40,000 square feet of floor plate for each office. Though that's what is a requirement for all the IT developments. So that slightly condenses. Then comes the hotel. Hotel comes with its own three sizes. It's a 40 square meter room size. So knowing the number of rooms we have, that again condenses. So this staggered, the stepped entities which are going and their footprint being minimized as they go higher. That also was one of the key by which we evolved into the form what we have as for the project. It's the same thing on the other direction. I don't want to elaborate further on this. So to understand how that form evolved, so there is that shopping center, what they are calling as the Orion Mall by the Brigade Group. Then we have office. Then we have hotel. So footprint from the lowest to the tallest. Intermediate is the office. So we created the gradual transition from the lower asset class to the topmost asset class by reading the form with the softening flow from bottom to top. So that's what I was telling, the rising of the form from root to the top. And the purpose allowed us to do, our vision allowed us to do that. So that is the whole thing. Now here, every asset class, there's a transition when it happens. There is a highly active zone comes in naturally. Like, when the hotel starts, you have the hotel public area spaces which has its own glow. It asks for footprint. Again, the office will have its own amenity space apart from the typical office. So all these junctions allowed us to celebrate at these every transition space as well. So another key thing, like, when you have a mixed-use development, we have so many vertical circulation, right? There are so many lifts, something 18 to 20 lifts for office. Then again, some 4 to 5 passenger lifts itself for the hotel. And this hotel comes with a full-fledged, almost 15 to 1,500 packs capacity banquets, including all types of banquets, So with all those things, what we saw is how we can make use of that and the factor of climatic conditions and the orientation of the building to derive the whole form. So what we saw is, this is a south side and that is the north side what we have. Okay, so we aligned all our vertical codes towards the south so that maximum the right light form we receive on the north side, which can be actually used for the purpose, for the whole functional aspect. So this is what I would actually call as our derivation from the function, the form is derived. And from the function, actually, the whole purpose is served. So that's what we have. A lot of south facade in our design, you will see comes with the opacity. And the glass goes on the northern side. And there is an iconic corner what we have, which gets a visibility of whole high-tech city, and it's a free, uninterrupted visibility that we always celebrated, where we could give them a good vista, or even the functions what allocated. Like for example, in hotel, we have put all the suite rooms in those corners, so they get the best view. So there is always the written on the purpose for which the building is built for. So similarly, these are just to understand the light and the shade conditions of what I explained about. So just first intro to the building, when somebody arrives, is this entrance feature where we have our shopping center arrival, and the rest of the drop-offs for the other asset class goes. So your opulence of what I was speaking about, the language of a pearl or the heritage context, what this project lives with, that opulence or that a grandeur starts from here. It's the base of the building which rises up as iconic as we see it in the full form. So this is what is the full form it is derived. You know, the project's mouth, what we have is only 90 meters. So in the passage of that road, and what 90 meters, what the first glimpse the person will see from the nearest, and from what he'll see from the distance is this radiating, or I would say the evolving skyline, which is going from top to the bottom, from bottom to the top. And next to that is even the residential. See, again, just to give a quick thing on the residential. Residential is, again, we ensure that it is less maintenance, because it is something, sale property, where the maintenance then goes to the society, the federation of the residential units. So their minimum cladding, all plaster painted, but we are ensuring that the form is not changing. And this is what you see. This is what the project will be visible from the high-tech city or the other part of the Hyderabad is like this. So this is what we see as a commercial block, all cladded. There is no need to bring in any light inside the shopping center except through the atrium, which we are doing through the skylight. Then we have an office which requires at most light coming in there. So the technical detail Rajan will be taking up further, and the hotel on the top. So this is a more focus on that. And the top we have a sky lounge. There is a helipad which is going to be functionally used. We are going to have a heliport, the complete lobby set up for the commercial use of the helipad as well. So there is a sky lounge there before the hotel starts, where you see before the last two masses, where the office terminates is all the public amenities of the hotel. So that's where we were able to create these staggers. Now, wherever we had a vertical circulation, the solid walls or the lifts, we had this kind of, it's a terracotta color, but what actually material, knowing the height of it, what we prefer to use is the aluminum cladding, but giving that touch of that color as a contrast to the glass. What important feature is that element of white rising from the bottom and terminating as part of the canopy above. So it's all giving it a monolithic run from bottom to top. So when we start celebrating, from one asset class to another asset class, you have to celebrate. And that's where we thought you'll bring a language of a jewelry, or that this is what a brief even to the lighting designer, it should look like a pearl for me. Okay, they are working on it. And so that's where we are having that Intercontinental Hotel, their public area, reception pieces sitting. It's quite a cantilever which is coming out of a building at almost 130 meter. This is 200 and 16 meter tall, right? Almost my 30 meter is a shopping center, then 120 meter is an office, and then about 60 to 70 meter what goes into the hotel. So that's what the massing distribution is. So general night visioning, we are working with the lighting designer to have a little dynamic flow of, like, you know, the media on the corner to create more impact. So this is what emits your next to your residential, this commercial is standing as. Yeah, I think I'll now, while we spoke about the facade, I would want to Rajan to take over into some of the technical aspect of it. Rajan, here for you. Thanks.
Good afternoon to all of you. Thank you for Zak and all the sponsors. So Vrinda has given a nice introduction from architectural and various different aspects. I'll just go a little bit detail on facade costing and how do we get this aspiration. So we got the brief from the architect and we also get a brief from the client, what is the investment they want to do, everything fits in the budget. So then we go on detail. So various ways we can do detailing is, the project has a lot of detailing is involved. The commercial project, which what Vrinda has shown, they were exploring a lot of reveal features on the typical spandrel area. So what you can see, it is not just a glass box building. It has some features, fins, horizontal, there are lines going on. So we were just exploring what is the most optimized way we can do it. Essentially, architecturally, they want to have a spandrel with a recessed. So then, if you're doing this detail, there's complex involved in the fabrications. So we were just checking, can we do without changing the system or compromising on the detailing of the system. So finally, we have recommended the one which you do on the right side is better because your fabrication, you're not doing a lot of compromise on the detailing. The spandrel zone is very narrow. So the left side is difficult to fabricate, difficult to work with that. So we have suggested the detail on the right side. So sometimes without compromising the design, without making the design more challenging, difficult to work, is always you do little bit compromise on aesthetics or visual, but is more user-friendly in terms of executions. So the other detail, like such as materials. So the architect was proposing initially with the terracotta. And then there was also a debate with can we do a similar alternate material using a different material. So then we have proposed with aluminum cladding. So it's a time-tested, lighter, so any fabricator can do it. The only thing is it doesn't give the same texture. It's not going to just duplicate the terracotta. It's two different materials. But the client has took a call, so it's a lighter material, and we are getting about 10% cost savings. So the client took a call. We can go with the aluminum cladding. So when we do the aluminum cladding, then another detail that we were discussing, all the bands can we do with a concrete? It's just a punched window, or do we do with a curtain wall? So there's two different schemes we were discussing with the client. There is a cost involved on both schemes where we do the punch window. Of course, the facade is cheaper. And then you are putting a lot of concrete on outside the building. So the client also has evaluated. And this is what the client has decided. So it's not cost reduction or value engineering, I would say. So in fact, this facade with the curtain wall is what you see the client has chosen is more expensive than the punched window. But the client took a call is save a lot of time. And then, of course, the facade can give much better quality of finishing rather than concrete, and they have to do plaster paint. So sometimes cost is not just a driving factor. Sometimes a little bit more expensive, but it gives a little bit benefit of better control on quality, less maintenance, easy to fabricate. These are all the factors we take here. And other details like how do we treat there is a lot of vertical fin showing on the shopping mall at the corner of the facade, where we were checking, can we do with a cladding or a fins? The cladding, if you can do if the fin projection is extremely bigger. Otherwise, preferably the easiest way to do with the extrusion finishing, so it will get a better finishing and less of fabrication. So this, we have suggested to reduce the fin depth. It was like, if I remember, 600 or 700. So then the more practical way of doing is just reduce the fin, something we can do in extrusions. So that's given some 6.9 CR cost savings. So then looking on the commercial building facade, different ways we can do a fins. So the fin is started with the 300, 250, 150. So everything comes with a cost. So then this all exercise happening during the concept. So it's good to have this during the concept, not after completing the detailed design, client is talking about the costing. So we found out there is ultimately the view on the right side is they have checked architecturally it is okay to have every alternate fin, and that has given 2 CR cost saving. So it is not really a high tech or something, a great ideas, but it is good to have this process in your concept stage. So you don't think this after you have done with the DD stage or tender stage, then we start thinking about cost. Yeah. So just finishing a couple of slides about essence of costing is understanding the client budget from the day one. So we don't talk about costing after done with the detailed design or getting the contractor price, then we discuss the costing. So it's better you start with the client from the initial stages and manage the aspiration of the client as well as with the architects. Keep costing as always part of the process. So of course we are not cost consultant, but as a designer we have a responsibility to make sure everything is working within the budget. Value engineering or redesign. So we like value engineering, nobody like the redesigning. So it's better we do value engineering from the initial stage, which can extensively avoid a lot of redesign once you're done with the DD stage. Impact of the costing, as everyone knows very well, so we don't have to explain. The facade cost is getting much higher. So it's about 25% of the total facade cost. So it's one of the expensive elements on the facades. So the timely completion is critical, as a lot of developers here understand facade is giving a lot of hard time because it gives challenges. They cannot finish on the project. So facade is always very challenging. And facade contractor face a lot of problem with efficient planning and time frame. So we can't just change something, one detail sitting in the construction phase. It has a huge impact on the timeline. So the challenges, as I mentioned, clear budget, ambitious designs we can do with a reasonable cost, repeated design. So once you do the too many design iterations, the team is lost interest. So we are designer, we want to do design. We can't just sitting talking the costing for months and months. So the avoid design on the side phase, the design always done is before it's going to executions. So it reduces the commercial impact. You can manage the contract better. Design once, you can avoid redesigns. And if you do this, ultimately they will get a functional, long-lasting facades within the cost without taking too much of redesign or time is running out. Thank you. I'll give it to Vrinda.
Thank you all. Thank you all. So it is, I think he gave a good introduction on that. So just some glimpse on the final output of the project is how, I mean, each and everything is quite coordinated and taken care of. Yeah, I think that's it. Thank you. Thank you.
Thank you. Thank you so much, Vrinda and Mr. Rajan, for this wonderful presentation and a detailed discussion on the project. Next up is Mr. Harsharaj Shetty from Shuko for the presentation. Please welcome him.
Yeah. Hello, everyone. So today I'll be presenting a different type of topic. It is basically on how innovative facade solutions are evolving and growing, and how Shuko as a system supplier, as a company, is also gearing up to address these issues, right? So as part of my presentation, I have 3 very different topics, but they are also very critical to the future of facades that we see. So they are majorly integration, safety, and sustainability. So can you switch? No. Yeah, in today's world, the building facade is no longer just an envelope, right? We all know that it's evolving day by day, and there are new things, new interests, new emotions that are being added to every building that we see. There is design, there is performance, there is safety, everything that has to be considered when we talk about facades or when we talk about building envelopes. Today's facades must have a balance between aesthetic vision with structural integrity, with all the concern for safety as well. So what it demands is a facade that can have integration across disciplines. This might be other systems, materials, and so on, which I'll be presenting further, along with very careful consideration for sustainability, and also now nevertheless leaving out safety for this. So to begin with, I'll start for the first topic, that is integration. Integration is, I would say, is the next step in facade innovation, where it is not just metal, glass, or cladding. It's much beyond that. There are systems, there are technology, there is new materials that are being added into the entire facade innovation idea. And with that, what we see as the market pulse today when we say facade, there is fenestration. So there is a lot of interest, and I think we had very good presentations in the first session where we saw a lot of integration of sliding systems, integration of green facades, integration of new materials, new material panels that are going into the facade that we just consider as a glass. So there is fenestration that might be sliding systems, it might be insert units, it might be your doors that we can talk about. And then we have smart and dynamic facades, which are basically facades that are interactive, facades that can respond to the requirement of the people who stay in the building, right? It can be the incorporation of sensors, actuators, shading systems, lightings, and everything that goes into one building, right? And also it also connects with how you can manage the system through building management systems, through digital tools and softwares. After that, there is the consideration for hybrid materials. So it's not just glass, metal now. There are multiple composites, lightweight materials, novel materials that are going into the construction part, and how do you take it as part of your facade design, right? And above all, beyond that, there is sustainability that is always there in the part of what we design for the industry, right? There can be green buildings, there can be biomimicking designs where you have breathable designs in the facade. And also there is a chance for you to make your facade or building generate electricity. So it basically helps you in overall getting down the carbon emissions to zero, right? So this is majorly as part of what we see as a market trend, what Shuko addresses also, that this is what needs to be considered when we talk about facades. So with that, I'll just move on to what is the Shuko's approach to each of these four main trends that we are seeing. So when we talk about fenestration, Shuko is already offering tested high performance insert units, which can be top hung ton and tilt options, and also even the parallel pop-outs, which are already been like, we have been doing projects, we have been doing like large panels, which are really like bringing out the essence of this performance oriented facades. And we have glazed doors, which can be blended with the facade systems seamlessly. It helps you, give you those entrance allowance for the facade. And yeah, we can also do larger entrance doors panels also. We have glazed doors which can blend with the external full glass feel of the facade. And we have seamless sliding systems, right? We have ready systems which can be easily aligned with the existing facade that Shuko is already proposing, right? And this can be panoramic design, this can be high performance systems also. And above and beyond that, there is something that Shuko is known for, is for the engineering part. So every project that we get into, every facade or every residential, whatever we get into, we do the standard custom engineering, where we hear the customers or the consultants' thoughts. We try to understand what the architect is intending, and we try to create solutions. So it's not that just we are restricting ourselves to standard offers. We are also trying to create something new based on the project requirements as well. So this is about fenestration. So let's move on to smart and dynamic facades. So when we say smart and dynamic facades, Shuko is already having its natural smoke and heat exhaust ventilation systems, which is a perfect combination of tested systems. So this can be used for smoke extraction, this can be used for heat exhaust ventilation, and also on a regular basis for normal ventilation also. So the key benefits that we get into this is these are like tested systems. They help you in keeping the building cooling or the temperature, right? And then sustainable control units for every application that can be used. You can use it for skylights, you can use it for your top hung windows, which gives you a holistic approach, and it is highly modular also, which can be customized to your individual requirements. After that, we have something called the Ventotherm concept, where Shuko along with Renson is offering systems that can help you to breathe through the facade or through the windows without opening it. So what it offers is ventilation with an advantage to keep the hot air out, keep the temperature within your interiors cool. And also there are features where we offer acoustic options also to keep your interiors quieter, all the way with the ventilation happening throughout the day, right? So this is about Ventotherm. And then we have Integral Master. So Integral Master is basically Shuko's offering for blinds that are already integrated within your systems seamlessly. So you don't have those bulky cassettes, or you don't have bulky profiles that is visible from the interior, or probably from the outside also. It is pretty much flush with your design. So we have offerings where we provide blinds. We have textile blinds, zipline blinds also, which can be completely automated and in sync with your building management systems also, right? And moving on, there is Shuko IOF ID, which is a unique proposition from Shuko, which helps you to tag every system, every unit that you're building that Shuko has provided. So what it does is it creates a network of all the units that you have in your building connected through an app, and it can be used through our Shuko software also. What it gives the customer is access to every unit, what is throughout its life. It helps you maintain the systems, it helps you maintain the building, and probably look it up on how you have to continue or how you have to address issues also. So Shuko is giving the digital touch to every unit that we are doing, and it is as simple as a small tag that we can just put it on this with the QR or a NFC based scanning technology. So with that, I'll move on to hybrid materials. So hybrid materials, as I said, it's not just metal and glass. It's much more beyond that. Like we have aesthetic, we have thermal requirements, we have then multiple sustainable related requirements also nowadays. So how do we, as Shuko, offer that? So green facade is something that Shuko is offering. And it is a unique, unitized system-based offering that helps you to integrate multiple green facade panels along with your standard unitized system. So if you can closely observe here, these are like standard panels that are already, and you have the green facade panels, which are basically the same modular based construction. So what the advantage what we have here is these are all fleece based panels, which helps you to grow plants of whatever you desire. So, and they have an integrated watering technique also with the panel, and you don't need to have a separate watering technology for the plants to grow. So green facade gives you a realistic living biopanel, and it helps you to keep those overall heat generation, or what we call as heat island effect to all the concretes that are coming up in major cities. So after that, we have something called as wood design, where this wood design is pretty much towards an aesthetic look. I know we have a lot of interest towards having wood interiors in India. And this is something that Shuko is offering to most of its windows and probably and insert windows that go into the facade. So what it does, it gives you a very clean wood look from the interior, and it's all the around it's a standard aluminum system, but still with an aesthetic touch of wood in when you install it. And then we have Shuko Façade, which is a textile-based system from a, just a second. Yeah, so so Shuko Façade is a textile-based system with the aluminum skeleton. So here we don't need to have any steel-based substructure to have the facade installed. So what Façade brings in is a lot of different textures, different options to have display-based or illuminated-based facade envelope. And this can be majorly for commercials where you can do a lot of variations within the facade texture. So this, since it is based on a very aluminum-based substructure, we don't have the issues of corrosions, and the technology that this has as a easy to install way for the facade also. Just a second. So this along with there are a few more options that Shuko also has as part of the hybrid materials, but I would like to keep this for today, and probably we develop on this on the next presentations. So moving on to the last part, that is basically sustainability. So sustainability for Shuko is a very important aspect. So the group Shuko as a group are aligned with this. They are dedicated to how we can make the future more sustainable through what we give to the industry. So to begin with, there is Shuko Carbon Control, which I have been presenting it in my previous presentations also. But what I want to put it here is Shuko Carbon Control is a comprehensive framework that Shuko has developed in order to reduce the overall carbon emissions that facades or our fenestration systems are generating, right? And this carbon control framework goes through the entire life cycle of the building's envelope, right from raw material to the end of the destruction or demolition. That is basically the cradle-to-cradle approach that Shuko is following through this. So I'll be taking another example of carbon control in the next few slides. So I'll just move on to the next part, that is Shuko AOC Timber. So Shuko AOC Timber is an add-on construction with the timber option. So what timber gives you is a natural look, and it is you have lesser issues with damages and logistically, and it is a very seamless way of constructing. So there is very less, or I would say zero difference from what you do with the standard aluminum transom and emulsion and a timber construction. After that, we have the Shuko minimal wall. I'll just give you a quick glimpse on this because I have a separate set of slides for this down the line. So Shuko minimal wall is a new innovative method of glazing facades, which is part of the overall sustainability and Shuko carbon control concept that we are working, that we will talk about in the next slides. And then we have Shuko building integrated photovoltaic option, which we provide it as a standard, I would say as a standard offering, and it is more like a unitized system, and we have the required construction and required design so that it doesn't need a separate engineering part to integrate into your buildings. So this is more about how we are considering the integration topics. So I'll just quickly move on to the few projects. So this is Shuko 1 Bielefeld. So this is our headquarters. So this was finished in 2022. So here we have multiple systems integrated. There is window, door, facade, fire protection systems, and even smart buildings, right? And then we have this is one more projects which I just wanted to highlight for the facade construction that has been done. So this is one of a unique the buildings in Bielefeld that has involved Façade as part of their construction. And then we have our work in progress project with Waterstone. I think when my colleague will be explaining more on this in his next panel discussion, where we have integrated multiple opening types with side hung, fireman access, and top hung, along with the standard unitized construction. So with that, I'll just skip to the next topic, that is on safety. So as I said, integration is one topic, and then there is safety, which is critical for every construction or every building that we talk about. Nonetheless, facade, fenestration, and so on. So safety as a real world scenario, how do we see this? So I'll be talking more on towards how we are addressing the safety issue with insert units in high-rise facades. So in high-rise buildings, there is always a provision for top hung and side hung, or even the projected panels. So how under high-rise there are a lot of high dynamic wind, vortex having its effects on it, and we always see that there is this slamming happening of the top hung when you are keeping it open, and you cannot control every time the opening and closing of this, and this really takes a toll on the window, and it can damage the hinges or the friction hinges, whatever you are using, and it can even fall off. So this would be the worst case scenario where the window falls off, and then it can cause harm to humans or damage to the environment also. So how do we address this? So there are two concepts that Shuka has considered. One is how do we address the slamming effect, because when the window slams, there is a lot of load, there is a lot of pressure that falls on the hinges or the connecting part, and this is something that can be avoided. So we have come up with something called engagement catch, which is basically a small fitting that goes into your outer frame and the wind frame, and this is completely controlled or opened or closed through your handle. So what it does is when the window slams under open condition, it automatically locks the window so that it doesn't do the to and fro motion, and it can be disengaged through your handle operations. So this actually helps in avoiding all the anti-slam issues that we are facing, and it has been tested widely, and it is also part of our global offering also. So this is one part, and then there is the second part, that is the safety catch. So in the worst case, where your window has completely failed or you are not able to provide your engagement catch, there is a mandatory device that Shuko is suggesting, that is for the safety catch, which we are giving for both top hung and side hung windows, which basically is a redundant safety feature. It absorbs all the failure load that falls when the hinges fail or when your barrel hinges fail, and it basically keeps your vent hanging to your building. Yes, it has got damaged, but it's still not causing a damage to other to the environment. So how do we ensure? So this particular topic doesn't have a actual written standard or something that has a protocol that can be followed. So how did we follow? How do we test it? How do we prove that this works? So we considered extreme wind events where the window will slam against the outer frame, window swinging under the light wind breeze, and once the window falls, it might be cases where it will not be addressed for a few days, right? And the window is just lying there. How do you address what would be the failure modes? So there we have considered three variations, that is impact load, and then there is dynamic wind load, and then there is sustained loading. That is basically the creep when it is hanging. So in line with this, there was a proper set of testing that was done for this particular safety catch, because this becoming the final savior for your windows. We had to make sure that it goes, the safety catch, the wire that we use is completely tested with UTM, right? It was tested for approximately 1 ton loading to understand how the crimping is going to fail. And then we had a drop test being done, which was, I think it was tested for around 300 kgs, the vents that you see here. And this was observed and how it can sustain. So we had gone up to 300 kgs of weight on the panel. And then there was a pressure blast open out testing that was done at a third-party system. This was, I think we had done a suction of around 4.5 kPa to understand the sudden impact of the wind. And this is basically what would be when it fails. So it hangs there. So once it hangs, so how do we understand what would be the condition when there is still a cyclone or an effect happening on this? So we have done a dynamic wind load testing on the hanging vent also to understand how it takes the overall weight and the absorb. So this is how we had tested the safety catch. So this is what Shuko is offering as part of the safety requirement for insert units in facades. Then also there is an additional layer of safety, that is limiting stay, which most of the systems have. But what we have understood is this is not enough. This can fail, and this can create a lot of problem in your functioning of your windows. And also there is vent retaining catch, which are like which can keep the systems at open or closed in certain locations. Above and beyond that, we also follow a standard set of planning guidelines for all the top-hung windows, and right now we have it for side-hung windows also, where we give guidelines on how the system has to be designed or how the system has to be referred. So I'll just come to the last topic for carbon control, and since I've just already explained it. So we have, as part of the framework, we have 4 major topics in carbon control, that is design to decarb, where the design design is made in such a way that we reduce the carbon emission. Then there is build to decarb, where we make sure the planned building is, the carbon footprint is at the lowest. Then there is operate to decarb, where we enable builders or developers, architects to involve systems that will reduce the overall carbon emission once the building is operational. And then there is recycle to decarb also, where we help our customers and partners to recycle materials at the end of their useful life. So just a last part on this is, since I just have 1 minute, I will just take you through Shuko minimal wall, which is part of our design to decarb topic. So Shuko minimal wall is basically a topic that we are addressing to address the ever increasing growth of aluminium consumptions in this industry. Right? So this is what we have in our statistics for the aluminium consumption in the construction industry, which is increasing by 5 to 10% year on year, and it occupies around 13% of the overall aluminium consumption in the industry. So what is minimal wall? Minimal wall is an innovative structural glazing method, where we have collaborated with the suppliers, adhesive suppliers, and we have created a extensively tested and engineered system, which will take the benefit of the glass to absorb the overall loading or the bending that it will be stressed to. So with this, we are able to reduce the overall aluminium consumption to 36%, and the overall reduction of the facade zone by up to 40%. So this has been completely worked out by Shuko internally with the proper calculation. There will be a proper proof submission that will be provided. And with this, we are saving up to 40% of conventional, from conventional unitized facades to Shuko minimal unitized facade. So this, along with our Shuko's offering of low carbon and ultra low carbon, we are able to have a substantial reduction of up to 35% embodied carbon in fully unitized units. So just as a next level upgrade, this was initially planned for the unitized facade system, SG facade system, which now Shuko is trying to innovate and move towards other fenestration systems also, which will benefit majorly in the sliding systems, stick facades, windows, and pivot doors. So this is majorly what minimal wall is targeting for in the next coming future. So with this, I close my presentation. I just want to re-emphasize, at Shuko, we strive to define the future of facades, so where architecture meets performance and innovation. Thank you.
Thank you so much, Harsharaj, for a wonderful presentation. I think thank you for being one of the only research-driven facade company speaking about biomimicry and sustainability. I think I know who to reach out to for our smart projects in facades. Next, I welcome on stage Mr. Andy Fisher from Andy Fisher Workshop, Singapore.
Hi, good afternoon. Thank you to Zak and all the sponsors for the opportunity today. Metros and beyond. A little bit about us. We are a multidisciplinary studio based out of Singapore. Architecture, interiors, and landscape. We've been working in Southeast Asia now for over 20 years, and we span all the way across the globe, from East Africa, but largely in South Asia and Southeast Asia. We undertake an awful lot of work in India. India's always been one of my, or has been my main market for a long, long time. I first started working in India on projects 30 years ago. So when I started my business, it was an obvious. I could see the potential, and it's lovely to see it realized now, especially over the last 5-10 years. The way that the markets are changing is phenomenal. We've been able to adapt and move and work around the country. We've worked in over 20 cities in India now. I think it's 27. This is actually in Bangalore. Our typologies and our work range from residential like this, high-rise, low-rise, commercial, hospitality, and mixed use. So we see a lot of what's going on, but we love to understand our context. We love to work with the site, the locations, the materials that we have available, especially now. There's so much good product coming out of India, being produced here in India, instead of looking to import and bring it elsewhere. This one, for instance, this development in Bangalore is 170 villas. The use of gabion walls. There are quarries 2 kilometers from the site. Sustainable, simple, cheaper than concrete. So that also gives it a sense of place and a rooting in its location, something that people are familiar with. But a nice engineering technique as well, and a nice aesthetic addition to the properties, because it's on a sloping site. So we have 170 homes spread over this location. Again, India, residential. This is in Bangalore. Vietnam, hospitality. So this is just some of a little bit about us. East Africa, we're currently working on this project on a beautiful small country that I have to unfortunately say I'd never heard of before we started the project. Small island nation east of Tanzania on a volcanic site. Very challenging, very interesting. What's cool about it though, mostly, it's about the people. All the consultants have never met each other directly, face to face, and construction has started. So we have people working on it from 7 countries. So it just shows how we've adapted, how the industry has moved on as well, how we can work together successfully and collaborate on all of the work we do. Every single material on this project will be brought from overseas as well. So, looking at those things, looking at how we have to change and respond not only to our place, but the people we're working with and the locations, the needs of the clients as well. So as I said, across India, that's sort of some of the places we're working or have been working. I personally travel to India about twice a month, have done for 20 years. So it's second home. Big metro, where is it going? What do we see? So this isn't all about facades today. It's sort of some anecdotal information and stories about what we see and where the industry is going, and also some of the, some of the technology, some of the material aspects, the design aspects that we see that are coming in as well. I'll sample a few projects, some in the metros and then some others as well. This is for Bagmani. This is in Bangalore. It was the last property on a 110-acre campus, and it's about 1.5 million square feet of offices. And what was interesting in this is really it's 2 parcels. It's those 2 parcels there. They came together. So we wanted to integrate. A lot of the other buildings didn't integrate with their surroundings particularly well. And I did say that to the client. They understood and they acknowledged that, and that's why they asked us to see what we could do. As a typology for an office, how can we change that? So it was connecting to the landscape, connecting to it again to its environment around it as well. And really, our concept was to really treat it as one block at first, which we then split and cut in 2. So instead of treating 2 similar buildings, because they're 25 meters apart, these buildings, we started to look at orientation, how we treat the facades, how we use those buildings, and how the 2 work as a pair, brother and sister, identical twins in some ways. and then how we can then create an opportunity to bring in the landscape and the amenities into the lower levels and bring the people in. We know what it's like, how difficult it is working 8 hours a day, particularly behind a screen. We all need our downtime, and bringing that in, encouraging people to use the surroundings and the landscape and the facilities that are provided as much as we possibly can. The facade as well, just touching on, as I am in a facade conference, it's sort of good to talk on these things. You know, it's almost a square building in its proportion. It's not vertical, it's not horizontal. So this, the way we treated the facade was we wanted to look for a way to use something that was a non-directional. And this is actually taken from a fabric pattern, which is a twill weave, which gives this rather random sort of look and non-vertical, non-horizontal look. But how do we achieve that, and why did we achieve this as well? When we look at sustainability, our approach is, I honestly believe that we really need to take more responsibility as individuals, as designers. Not look at checklists, not look at LEED, not look at WELL. We should fundamentally approach our job responsibly. And sometimes we can only do as much sustainably as the clients will allow, as their clients will pay for, actually. But if we design this from the start and build in the principles that the client likes, and then tell them, hey, by the way, this is also pretty good sustainably. So this treatment of this facade actually gave us a 60-40 split in terms of spandrel and vision panel, which if you look, it sort of follows a LEED rating platinum in that sense, and the performance of the materials also performed to that. Now, what materials did we use? This is terracotta. Seems a popular material today, but what's beautiful about terracotta is you can use almost as many colors or any color range you want. So we got this beautiful aquamarine color to it, which actually is glazed and polished. It gets lovely crackle to the material as well. So when you get closer, it gives out a little more. Also shines nicely as well in the light. And what I really like about it is when you look at it, people don't know what it is. That's kind of cool. It's kind of fun. So you can see the way the building's sort of ripped apart and welcoming in the landscape and the surrounding areas as well, and integrating a lot of spaces for people. It's important. This is another complex project we completed some years ago in Bangalore. It's actually 2 hotels, dual brand hotels, over 600 keys, 637 keys, I think, plus 2 office buildings as well. Building height 50 meters, so that was an enormous challenge for us. The density was very different. Normally we have these, you know, we have to set buildings apart, and but this was a 9-acre site, and it's over 2 million square feet in 50 meters. And that excludes car parking. You know, it doesn't count the 40% of parking below in the 3 basements we have below. We were able to connect the hotels and one of the office buildings, so in terms of our fire egress and access and things like that, we were able to manage that, but really have an opportunity to create some lovely density between the buildings in a public realm as well, keeping the traffic to the periphery and allowing the public space in the center of the site. Contrasting the 2 brands as well. So the Hilton on the left, the more luxury, it was a cube. It was by choice, by design, but it was also because of space and height that was available to us. We wanted to express that cube in that form. Very slick, very simple, beautiful curtain wall system. On the left-hand side, we wanted to express again the slightly lower range of hotel in a very traditional double-loaded corridor plan, and express the grid, but have a bit of fun with the solid material as well. This is actually a brick slip mechanical fix system. We took 5 colors of the bricks instead of using 1, and we got a random mix. So again, people look at this material and they're kind of not quite sure what it is until they get close. And it adds a lovely vibrancy to an otherwise very standard, very normal form to a building. As I said, we also do the interiors as well, just to soften the mood a little bit. Some nice artwork and things. And again, contrast, using those colors as well that we have on parts of the public areas of the building. Give it a little bit of life. Other materials, this is GRC. This is the office one of the office buildings in the same development, where we've taken this sort of fluted GRC panels to express the 12-meter high sort of public areas that we have around the lobby areas. This is an interesting project, again, going up now to Delhi, so I thought I'd get out of Bangalore and take us north. Lovely different set of issues and problems that we have to deal with on this one. It's residential, it's high-rise. Delhi a few years ago has sort of released some of the planning norms and allowed us to build taller in Delhi itself. So this is 160 meter tall, 5 towers, sort of luxury residential development. Originally a shopping mall. One of the big things, it has the metro running by. A lot of the sites that we see now in India as well, the connection to transport and how people move around. We all see the traffic's a nightmare. It is everywhere in the world. But more and more and more, I think as public transportation systems improve, then hopefully that's going to alleviate some of the problem. But it also means that we have to start connecting our buildings and architecture and language to the transport systems that are there. And thinking about that as well from the beginning. It sounds obvious, but we see more opportunities to do that on projects that we see across India. We have another project, which is a very large-scale office. It's over 3 million square feet. And what we propose to do there is to, instead of bringing the vehicles in at ground level, we're going to take them all underground, even the drop-offs underground, because the whole area around it is pedestrianized. And so we have a bus depot in the basement. We can bring the feeder buses, the small buses, down into the basement, and actually then bring the people up into the public realm, into the pedestrian areas. And the clients are they're delighted, absolutely delighted that we're able to just sort of take that advantage that we have and start to look at those things. This guy here, this one was, as I said, it's just an elevated metro line in front, but again, it's something that we have to respond well to when we're looking at placement and towers and things like this. This journey out through this with the client hadn't actually done too much luxury residential before. And when we started, they had an eye that the units would actually be quite small, relatively small, more premium than luxury. As we began to go through the process of evolving what this could be, they began to realize actually they probably had a better product than they thought they would have in the end. So we actually did this one big circle around to define and work with the client as to what that would be. Especially at a high-rise level as well. It offers us something completely different. Obviously, Vastu is hugely important as well. You're not going to sell these unless they're Vastu compliant. And so we went through numerous iterations before we arrived at this. The architectural language of the towers as well. It came about because when you look at a lot of high-rise residential, there's really a couple of profiles that come out in that language. Apartments that have cantilevered balconies and terraces is the main sort of language that you see. Now, when you look at the skyline and see that profile, all you see are these sort of serrated edge of a profile. And everyone looks the same. They don't have a really strong profile on the horizon in the skyline, adding to the form and the language and the identity of the project that we're looking at. Because Delhi as well has its rather extreme climate as well, the idea of having a cantilevered balcony doesn't necessarily make it a very usable space all year round. So we looked at a very simple gridded framed language like this, which pushed the balconies apparently inside the building, but it's not actually, because the language and the framework doesn't actually come all the way to ground. They're still cantilevered balconies, but we're sort of disguising them behind this grid, this framework, which helps give a sense of enclosure to the outdoor spaces, and also provides a little bit more protection to the elements as well, particularly in the summer, sort of April, May, June times when it's extremely hot. And then in the winter time as well, when it gets cooler, it also means they're still somewhat protected. So it's a very simple language, and we took this all of the way through the buildings. And then when we look at amenities, amenities sell apartments, let's be very honest. Once you've chosen your location, you look for the amenities, you look at the facilities that are there. So what we do, or like to do in this situation, is to scatter the amenities around the property. Amenities create a sense of community. They create opportunity for people to meet. Living in apartments isolates people. I get in my car, I get out of my car, I get in a lift, I go up a lift, I open my door, and then I'm in my apartment. I don't often get to meet so many people. This way, by spreading things out across the site, it makes me cross from one tower to another and create those opportunities, not planned, where I can start to meet people and gather a sense of community, hopefully. It also architecturally just helps sort of connect and define. Instead of just dropping the tower straight down onto the ground, it starts to link the architecture at different levels as well, and create more places and more moments of interest. So it's also about spreading facilities which relate to each other. If I'm having my kid's birthday party, I don't want to have it next to somebody who's, quietly reading a book or, doing some yoga or something. So we have to look at how we place facilities around there to give them the best opportunities. And the architecture can give us that. Whether it's terraces midway up the building, whether it's rooftop terraces, whether it's this sort of thing, lower down, we can use the building and the form itself to really help create some additional opportunity that perhaps we wouldn't otherwise get to see. So the way all the buildings are linked, I can get around the building undercover safely in the dry, out of the heat, out of the cold, and get to use my my property, not just my apartment, my property, the whole thing, as much as I possibly can. You'll see on this point here, when I mentioned the metro before and the transportation link, the metro is just here. I can't change that. I can't avoid it. I can't hide from it. But what I can do, I can make sure that all the apartments get a good view. So we've elevated, all of the apartments are lifted up from the ground level and open up the space of the ground floor. So the outdoor space and the amenities feel so much bigger than they otherwise would be. So the apartments only start on this side at this level, which is about, I think it's about 15 meters, and then a little lower down on the other side of the tower. The striking sort of orange terracotta thing is a little bit of signature in terms of adding to the brand and the identity of the architecture, which is, it's actually the fire escapes, which we're just cladding in GRC, choosing a nice bright color to contrast against the otherwise fairly simple tones, and just give a little bit of a stronger identity. And this again comes down into the lobby as well. So we're using that, giving people a nice sense of orientation and understanding of the language that we have around. Some of the internal spaces, again, this is the library. This is on the link bridge that you saw going through between the towers. We have a little gas fire in the corner there. Comes on in the winter, nice cozy space when it's cold. Again, it's a small thing, but it's actually kind of nice because we're understanding the surroundings. Show units and things, this is all interior stuff. But you'll see, it's all, there's too often we can isolate facades, we can isolate the architecture, we can isolate things. We have to consider the whole. One last one here. This is also Bangalore. It's a kind of cute little building. I say cute. It's little. It's about 450,000 square feet, so not so small. It's a very prime location. It's one of those once in a lifetime sites for a developer, and we first looked at doing residential there, and then the client changed their mind and said do commercial. But when we approach this as well, it has to maximize the area completely. It's such an expensive site. You'll know that in Bombay. It's even worse, right? In terms of always trying to squeeze out as much potential as we can. And the site, whilst it looks rectangular on this, is not. It's actually a slightly odd shape. And when we looked at that, these sort of rather harsh corners that a rectilinear form gives us, in this case slightly pointed as well, it's very hard to transition facades around. And we felt that this location, whilst the building is not very tall, it's only about 60 meters tall, it's quite visible from around the neighborhood. And we felt that it's super important that it has a singular identity, not a front, a back, and a side. Why? Because of its address, its location. It's very prominent, it's very well known, and also because the client thought that they had a really good chance to lease this to one tenant, the whole building. So it's not like you have multi-tenants, lots of floors and lots of things. So that identity we felt would be attractive to a singular tenant. So we started to look to see how we can mold and shape and use the corners and really maximize the potential of the floor area. It's a side core. We have an adjacent apartment building. Floor plate's not that big, 25,000 square feet. But it allowed us then to utilize and express the views. The views to the city are this way, there's a golf course this way, and then there's a nice view down here as well. So it allowed us to sort of start to address the form and how we can treat the facades. So right at this stage, this is where the solution for the facade came. As early as this, we didn't scratch our heads later and think, what we're going to do. This gave us the answer. It's really straightforward, really simple. So we start to elevate the building, start to carve the building, look at where we can bring a little bit of outdoor space in whilst managing the areas and maximizing the areas as well. We have to understand our tenants, the people who are going to buy, the people who are going to occupy. And we don't often do that. We don't often get to meet them. But what we do know through a lot of interest and work and working across this field is that, you know, lifestyle and people's well-being is priority now, especially to high-end tenants, high-end companies. So the opportunity to have great views, to see daylight, to make sure that core-to-wall distances are not too much. If you look at Europe, in Germany, certainly there's a maximum distance I'm allowed to sit away from the window. I have to see daylight in an office when you're designing an office. You know, these are all good things. It helps us. I don't just want to be sitting at my screen. It's nice to see the daylight. So looking at floor plate sizes, looking at core-to-wall depths, looking at windows, floor to ceiling heights, what can we see? What qualities can we give to the occupants, even though we've never met them? We're all the same. We all like to feel good. Also some outdoor spaces, the opportunity at the top of the building and address some good views out, and also on the corners. So we started to pull and push the form of the building so that we can actually get some terraces there as well and allow people the opportunity to be able to go outside and get a breath of fresh air during their day. So it's a very simple form, very simple building. In terms of facade, another interesting thing on this, 98% of the panels are the same size for the entire building. We tried to get to 100, but we couldn't. We had a couple of tricky areas in the corners. Of course, that helps my job when I give that number to the client. It helps my job because I can tell the client we've tried our best, we've reduced the cost of these panels. We don't have a lot of variation of section sizes and glass sizes and anything else. And because it's not always common for the entire building to be clad in a unitized curtain wall system, then it makes my job easier as well, because I've thought about the client's issues, which is always coming down to cost. And so they were super excited by that idea. They like to use that number, actually. So it shows the level of thought that's gone into just creating this form. All the radii on the corner, even though they're faceted, the panels are all the same. Even coming down the long runs here, the panels are the same. Now, we can do that because of this. So it's a very simple building. So when I said before the form of the building gives you the facade, in this case it did. It made it really easy. So this is it, finished now. And one of the cool things as well that we heard recently is that Apple have leased the whole building. So the client won. The client got what they wanted. They got a great tenant who's taken the whole building, I believe for the highest rent that's been paid in Bangalore as well, so they did even better. But, you know, what was nicest for me was that obviously with a company like Apple, who have an eye on design and the look, that somehow the aesthetic appealed to what they aspire to be a need as well. In that sense, the language, the singular identity was something that worked for them as well. So that was kind of nice. The vertical mullions as well, they look very sort of regular, simple, but they also had a lot of thought put into them as well. They're actually, we got a die made, and they're actually tapered. They actually start and they taper out towards a point. Now, why did we do that? We wanted, when you actually walk by and you see it, depending on the time of day, you get a slightly different light cast on the side of the mullion. So across the curve of the slight curve of the mullion, it does change during the day and as the light changes as well. So again, it just adds a little bit of subtlety to the building. And at the base where we have the side core, there's always a problem. There's always a problem when we look at the cores when they come down. What do we treat them in? If it's not glass, it's often stone. That's where we always go. This is actually GRC. The panels all relate to the mullions above. You can't see them there. You can't see the joints on the curve. But the panels and the modules are all the same size as the curtain wall panels as well. And then we've got this sort of scalloped, almost fish scale embossed profile on the cast GRC panels as well. That actually comes from a fabric design as well. I think I like taking reference from some of the geometric fabrics. But it gives us something a bit subconscious as well, that there's a story there for the clients, for the owners as well. If people ask about the building, there's a nice narrative behind the design and the materials and the choices that we made as well. One last bit as well is the top of the building. Much maligned in architecture. Clients often don't want to pay for that bit at the top. And I'm sorry if there are MEP consultants here, but we don't want to see MEP either at the top. So we were able in this case to bring the facade up. The BMU is also at that level, so it's a cantilevered track that runs around the back, and the BMU runs from that high level. So we went to that extra level, but it's something that everybody notices. It's just a simple gesture. The fact the top of the building matches the rest of it in a very simple line as we run down. Now, last little subject as well, where do we go next? This is just some anecdotal stuff from us. Where do we see? We work in a lot of the metros we have done, but we're seeing some fabulous opportunities outside of the metros now, which is very cool. We get to go to some really interesting places. This is Mangalore, and outside of Mangalore, you have a beautiful coastline down there, and there's nothing there. It's wonderful. We're doing another hotel on this side, on the right-hand side as well, which is another 30 kilometers inland. It's in the center of one of the sort of pilgrimage triangles. So, and there's no good hotels there. So again, it's really cool the way these opportunities are opening up across the country. It allows us as well we got to do some learning again. We've got to understand all of these places. One on the in Mangalore, it's a 110-acre development that we master planned with the client, and we're starting the first block, which is just down here, which is sort of retail and some offices. So again, it's very, very cool that there's all of these opportunities that are opening up in different cities. The one on the right is something we've just started. I actually asked the client if I could just show something sketchy on this first. He said, okay. This is in Raipur. Fantastic. There's so many, we have 2 or 3 clients there. They are really ambitious. There's a lot of opportunity to do new things, but we also see a lot of mixed use. There are 4 typologies in that 3.5-acre site. We've got high-end residential, we've got service apartments, we've got commercial, and we've got retail. So it's a complex little project, actually. But the client's looking for good quality. They're looking for ambitious designs as well, ambitious projects. So These are just some of the slides. I better go. I've got 5 seconds. But I'm putting this here because I think that, there's a lot of focus on the metros, on the big stuff that we do and the big stuff that's happening. But for us, we love the opportunities that are coming up as we grow further outside of the big cities as well. And the last thing as well is that's why we're all here. I think we always forget, I mentioned earlier, we design for people, whether that's clients who trust us to spend our money or spend their money wisely, or whether it's consultants, contractors, and everything else. We won't be here if it's not for everybody else. We're visitors, we're lucky to be here, but we're only part of the team. And so we're very, very blessed for that. So thank you.
Thank you. Thank you so much, Andy. It was a lovely presentation. I think we need to see more such projects coming up in tier 2 cities of India as well. I think that is where the future is heading. Meanwhile, let's call upon our next panel. And may I please invite my dear friend and also my go-to facade engineer, K.R. Suresh.
Thank you. Good afternoon. Yeah. Thank you, Khushbu. So today, I know it's just before lunch, and there's a lot of time for us. Actually, we got a lot of time. We got 40 minutes. And what we are going to talk of is about a project which, Mr. Shekhar Patki is here. He's going to present the project. But what we want to do is we want to run you through the whole sequence, how it was conceptualized, what was the client's brief, and what precautions as a system provider and as a consultant and as a contractor, how we have ensured that the building has come up. And now it's almost complete. It's almost 90% complete. And, so what we want to do is we want to have a presentation where Shekhar talks about the project. And then we have a panel discussion where we are going to look at key points. What we need to consider to ensure that a building is, it comes with high quality.
Hello. Hi. Hi, guys. So I'm Shekhar Patki. We were actually delayed a bit to come and present this project to you. We were supposed to, I have Suresh and Pratik with me who are also partners in this project that we did for the Brookfield, which is developing its first building in Bombay. It's called the Waterstones. This is somewhere near the airport, at Santa Cruz. And the project actually is a mixed-use development, which I'll take you through. Actually, I was hoping that I'll have the video on over here, but I think we'll start with the slides. So it is approximately 1.5 million square feet of development, where we have a office building, a hotel, and a clubhouse connected with the hotel on a 10-acre spread of land. And the idea here, of course, is not to speak so much about the development of the property, but how we have sort of married the facades of this building to the various users that we have in this property. So, of course, what you see on the screen just now is the facade of the main office building, which is about 1.2 million square feet. It goes. This is a night view of the same. What we are going to talk about in the panel discussion is to do with the facade design philosophy, the material selection, and of course sustainability, which is very, very important in all of the aspects today. This is a platinum LEED rated building, so we will have all of that conversation to go on with. This is really the location of the property where we are, where you can see the location connected to the airport on the right-hand side, the Leelas on the bottom, which you can't see, and it has the metro. So we have the very large plinth of the office building with a hotel and 2 clubhouses next to it. It'll also, what these slides will describe actually is the expression of elegance that we've tried to pick up here, along with the sustainable elements that we will describe to you as we go along. Some of these renders that we are showing you, some of these are photographs, some are renders. This is the Waterstones building that you have. This is the main facade of the Waterstone. We have, I think, approximately 3.5 lakh square feet of facade treatments in the form of glazing, metal, and natural stone. So we've used a lot of natural stone here in the form of Italian limestone and Albanian limestone. The glazing, of course, is in two different hues. As you can see, this is the site which is facing the Andheri Kurla Road. And this is a frontal view of the building where you can see the club, the hotel, and the office building as we are expressing it. And of course, the material selection, of course, is all of that I spoke to you about. It's really a integration of high performance glass with metal. We've tried to avoid we've tried to use as much of extruded aluminum as we can, and we didn't want to use too much of the converted boards that we are using otherwise. And of course, all of the natural stone is either in African granite and or in natural Albanian and Italian limestone. Some of these material sampling selections that you can see here, which we will talk about in greater detail. So we've also actually managed to get this stone cut and skewed to the sizes of these columns that you see. You saw the columns in one of the earlier renderings that I have, which I will, this one. So these columns actually rise up to about 50 feet in height, and we've tried to, they are cut out of one slab of stone and integrated into this, so it gives you a very stellar sort of expression. And of course, some of the sustainability aspects over here in terms of the glazing, in terms of how it merges with the landscape. And these are again some slide shots of the hotel building as it expresses itself to the club. And the sustainability aspects, as we have already expressed to you, that we will talk about as we sit on the panel. Some of this also, this is again an integration of the landscape with the buildings, and this is the granite that we are using. So really what we wanted to talk to you about is that along with these two partners of ours, Shuko and Avantgarde, we've tried to sort of bring about the best in terms of material selection as well as finishes on this building, which is meant to express itself in 3 different ways. And these are the columns that we spoke of, which once finished would actually lend themselves very, very well to the sort of scale and size of this development. All of the metal that we are using here, we've gone away from the aluco bond treatments, and we are using extruded aluminum, or in some cases different metals that we have tried to experiment with, especially on all of the undersides of the canopies, the trims, the treatments on the vertical fins that we have. These are some internal shots of just highlighting how the glazing is allowing you to sort of use the internal spaces. As you can see that we have a lot of biophilia within the main confines of the office, and the glazing has been treated such that these trees will be able to deal with the heat load that will be cut off by this glass. And this, of course, is how the building expresses it. This is the hotel building, but how it expresses itself with the same use of materials, but in a very different sort of tangible manner to the swimming pool and the glazing that is around it that we see here. Come. Thank you, and I think we can take this matter further once you have the.
Now I'd like to call upon stage Shekhar. You can have a seat. Prashant.
So for those of you who were interested, actually this was developed a year ago. So there has been some changes in the materials, but this was really just to give you guys some idea as to what is the project that we are talking about. And I think I'll give this to Suresh so we can take this forward.
Shekhar, I would like you to take a seat. Pratik from Shuko, one of the panelists. Prashant Pant from Avant Façades. Please have a seat. We just start the panel discussion where, we're talking about the project itself. And we want, basically what we are trying to do is, we are trying to not talk about the facade details and all that. We are just trying to ensure that, we have a good takeaway for the audience. And for you, basically being in the facade fraternity. So I would like to get into architecture first. How Shekhar has conceptualized the whole facade building envelope from a 9-acre property, 9-acre land mass, and also how Shuko as a system provider, they have come up with ideas, and there were constraints, definitely, and there were design consideration which happened, and how as a facade consultant, how Prashant has catered to the requirement. So I would like to start with Shekhar, where, it's obviously the first question. What did the client brief you about the project? What was your initial brief by the client for this property?
Hello. Is this working?
Yeah, it is.
So, this project was actually, for those of you from Bombay, this was the old Waterstone's hotel on this land near the airport. And then once it was taken over by the clients, they were wanting to develop this as a mixed-use complex which would house a commercial office building, a luxury hotel, and of course there was a club that existed there. So obviously try and take this club, so many notches higher than what it is. So it's basically intended to have a luxury lifestyle within this entire gated community or gated commune of about 10 to 11 acres of land. Actually, it's not 9, it's more than that. So the challenges here were actually, obviously, one is that it sits very close to the slum. It has restricted entries from roads which are yet not exposed or opened out. And there is the height restriction because this is next to the airport. So I won't dwell into the architectural nuances of how we sort of structured the cores and stuff like that, because that's not the purpose of this conversation today. But actually, in terms of how the building expresses itself to the outside, in terms of where you would take the sight lines, where you would take the positions of the arrivals and stuff like that. And obviously, being in the world that we are in today, we want to ensure that sustainability is the high point of everything that we do. Whether it expresses itself in terms of architectural fenestration, or it expresses itself in terms of the shadow lines of surrounding spaces and stuff like that. So all of that is actually taken care of in this building. And so with the restrictions of entries, we had to make sure that you had separate traffic movements for the office, which as I was telling you, is about, I think on a sale area, about 1.5 million square feet. We have a 100-room Leela serviced residence over there. So it doubles up as a high-end luxury offering for residences, as well as, I think, about 35,000-40,000 square feet of a high-end club, which would sort of rival the Bayside clubs and the Belvederes of India. And all of this obviously sits on this 10 acres of land, so there's a lot of landscape that's happening here. And the building had to sort of express itself and integrate itself with the landscape. So on the lower ends of these properties, especially the club and the hotel, which I couldn't show you on these slides, we have a lot of use of stone. And the direction of the client was that they don't want to use artificial materials in terms of tiles or any other stuff. So all of this is natural stone that we're using, whether in the form of granite, whether in the form of Italian marble or in the form of limestone. And of course, all of the trims, all of the accents to the buildings are in metal. We've tried to avoid what's that material? ACP. We've tried to avoid ACP as much as possible, and we have veered towards using pewter sheets. We've veered towards using extruded aluminum sheets in treatments that are done on the undersides, on the canopies, on some of the columns. And most of the very big columns that we have, I mean, this property has, architecturally, it has the USP of it stands on 6 very large columns that I was trying to highlight to you on the presentation. They're about 8 feet in diameter. And they are all intended to sort of be clad in Italian limestone. Originally, we were looking at metal on this, but you know, since the natural choice was stone, and Suresh has been of great help to us in terms of how we have sort of technically put all of this together in terms of achieving it, in terms of the quality, in terms of the alignments. And of course, with Pratik, Shuko is the best in their business, so they know what they're doing. So, yes, I think, Suresh, I hope that answers your question. That was the intent of the plan.
At least it gives the audience a perspective of how the project was evolved.
Yeah, that's right.
So, Pratik, as Shuko, when did you get involved in this project?
We actually got involved actually through a tender. Okay, we were aware about the project, and we got in touch with Brookfield team earlier. Maybe 2-3 projects earlier, we were in touch, and we got the tender inquiry, and the tender didn't specify even Shuko. So we had several meetings, but this time the client was clear about, through his past experiences, they were very clear what are they looking for. And actually we liked it, because whatever they were pushing hard for, it didn't seem like that they are going to budge for.
Right.
So we followed what the client was saying, the design the client was saying, and we just kept on doing whatever the clients require and the end building require. And somehow it took 8 months. It was an 8 months long process from what we offer, and we got awarded. Yes, that was a journey. We came to know this. Right.
So I think the specifications were right and everything was right, and you had basically gone ahead with the tender.
Yes.
And then we had Prashant come in, and you had the contractor on board.
Yes.
So we reviewed the shop drawings and everything.
Yes.
So what is the first step after that? As a Shuko and as Prashant, what do you feel is the first step after the contractor is appointed, other than shop drawing review, after the shop drawing is reviewed?
I think the first and the foremost thing which is important on a project once the facade is awarded is...
Shraddha, can you have the slide?
We start with the design and engineering. There were a lot of close collaboration. We have been hearing about synergy today. So there was a lot of synergy between Shuko, architect team, client's team, and our team in evolving the whole system design. A lot of iterations, workshops which took place in the background. Yeah, this was followed by a visual mock-up. Yeah, which I think is a milestone. If we can see something here. Yeah. So we started with a visual mock-up on site. So we tried to get everything in order as per architect's specifications and intent. The finishes, the glass, the interior floor closures, everything we tried to get in place. So once this was done, so we had a lot of die developments at Shuko's end also. So there were some new developments which took place in terms of dies. But I think the end product was good when we saw as a visual mock-up.
So what did you learn from the visual mock-up as a Shuko?
We saw that the client requirement and the FOC, the fire department's requirement were actually pushing us hard to develop new profiles. So as usual, we try to offer first what we have available, but we agreed with the client and consultant that somehow we need to develop a window. So what you see in the visual mock-up, there is a double panel side hung window. And this was something like, the fireman department wanted, but the architects wanted the minimum groove. They didn't want it to look like an aluminum piece from outside. Right. That we bridged that challenge. We developed an openable, and that openable was developed out of a German product. We converted it and made some changes, and we developed the window, and it is available with us. I will say thanks to the team at Brookfield who let us develop this, and we just made new profiles as per the consular requirement, 5 barriers. Shuko normally says that with our design, even 3 barriers are okay till 3.5 kPa. But as I said, that we followed the client's requirement.
So Suresh, actually, you and me should take royalty from Shuko for this. Everybody else is going to use that.
Right. Yes.
Because unfortunately, your fire department actually doesn't allow you to have all this clean glass that you see in Europe and America, and you have all of this rubbish that you're seeing on these joints and stuff like that, and it's just impossible. We can't avoid it, but I think Pratik has done his best in terms of reducing it for us.
We tried to reduce the lines, but he didn't reduce it.
Yeah, because we wanted 90-degree opening, and the royalty is already due because the same openable which we developed, we already offered at 2 products and we got awarded. So people are liking it. People are liking it, and it's a good product with all the safety arrangements, maybe the engagement catch and the safety catches, which are the 2 more safety arrangements which we are giving on the openable, so that even in torrential rains and storms, the window won't affect. It won't fall for sure. That is what we've taken care of.
Right. So, Prashant, how did you ensure that you must definitely be having a performance test for this project?
Yeah, I think your next question was about performance. Yeah, this performance test was a very, very stringent performance test. Yeah, and we had close monitoring right from the day one, after the development of the dies. We had a full-time engagement at the factory where the mock-up was under production, and we minutely followed it to the like Shekhar sir would agree that great designs can be measured up to millimeters. So to the best possible tolerances, we could get the panels fabricated, and installed on the rig. Now here it is also very important to note that specifically for this project, the performance mock-up was as good as a VMU.
So you had to do the whole thing?
Yeah. We did everything as new, and it passed beautifully. So the performance of the mock-up is not only a subject of testing, which is at the last you have to do a test, but the whole process which follows behind it, in the factory, controlling the tolerances of the extrusion, the tolerances in fabrication, that was very key to evolving into a mock-up which performed.
But then how do you ensure that the fabricator, this is just a performance test where you do a mock. How do you ensure it is done on site?
So there has been throughout the project cycle in the factory, there was close monitoring on the production processes. There was no shortcut from anyone. Even Shuko, I think, had a representative full-time in the factory, right, monitoring the production. So was our involvement in the production. This was followed up right from production to logistics, the way the panels were stacked, delivered to site, unloading on site, and then erecting. So frequent field audits gave us an insight as to how the work is progressing. So whatever feedbacks the consulting team was giving to the contractor, they were diligently followed. So we have a product which is good, I should say.
Right. So as Shuko, what have you done in terms of ensuring quality is maintained?
Usually what we do, just other than supplying systems, usually in all the projects we do is, we train at the fabricator's place, and then we do the audits at the site. Here, as I said, the client was very clear due to the past experiences. They asked us to put a quality officer or a QC engineer at the site and the factory both. At first, we were resisting it because it actually occupies my two resources at just one project completely throughout for a year, but it actually worked. So we had one engineer placed at the fabricator's factory, Angel's factory, only for Waterstones. And we followed a plan like, whatever material incoming used to come from powder coating or from the extruders to the fabricator's place. Everything was QC checked by the Shuko person over there and the Angel team, obviously. And whatever fabricated from there was cleared by the Shuko engineer. And I'll just see, we denoted every panel, every openable, we gave a distinctive code.
Okay.
Full codings for everything. And every code, we had stickers. So the moment, if you see over here, the moment any profile was fabricated, the way it used to have a white sticker and moves on. The moment it is assembled and quality checked, then an orange sticker, and it leaves from the factory a green sticker. Then the moment it comes at the site, the Shuko person at the site, he again okays it. So what happened over here is we made you can say a flawless site, and we had no audit. We didn't have to do any audit because Shuko is doing the quality checks and putting the QC stickers, and then the consultants and Mace were inspecting above us. So there are very less chances of something falling.
So a lot of cross checks, basically.
A lot of cross checks. We just added just because of just in Waterstones. This model was not applied anywhere else, but we find that this worked, and we are now planning that in some bigger projects we can implement this because we have the now capacity to train people at this level who can handle such kind of QC.
Right. So you ensure that it is all up to the mark.
Yes.
Suresh, I would also want to emphasize here is that from the day one, everybody was on same boat that we don't dispatch panels to site without the operables. So this was a mandatory requirement. Before the panel shipped out, it was QC checked, and all the operables were in place because operables are things which conk off on site. Yeah,
so there was a collaboration, basically.
There was a collaboration and understanding that we cannot compromise on quality.
Right. Yeah. So you had some method statements.
We had method statements for every stage, like fabrication, assembly, installation, and every method statement were followed with a checklist. Okay. So every fabrication, assembly, and installation, every panel had a checklist. So I can clearly say that 100% panels over here, every openable were QC checked at all three stages, cleared by Shuko, and 100% pond test done at every level. This was followed religiously at the project because no one can move beyond that. It took time to do this, but the site is flawless because of the same.
As a policy, like you have all these records. So is it going to be for historic? It will be a historic data, where you'll give it to the client and say, okay, you can keep this as an operation manual?
Yes, we are submitting this data and everything they can have, because we are going to give warranty for the project. Right. So warranty along with these documents are a document and are a history for them. And obviously this knowledge which we earned while doing Waterstones by working with all the parties, right, it has helped Shuko to evolve to handle even bigger projects than this.
Great. So what are the other considerations which, like I think in a project, generally you have, your windows, openable windows, which is like what Shekhar said, you'll have all horizontal lines coming in.
Yeah.
That is one thing which happens. As an architect's intent, you'll have an extra horizontal line on the elevation. Yes. The second is, your, what do you say, in terms of signages, in terms of lighting, all those things have to be incorporated in the facade.
Yes.
So as Shuko, I think it was a good collaboration, right, for ensuring it is done properly.
Yeah, the intent about the signages was very clear.
I think, yeah. I think you want to start with the openable.
Sorry, one second.
Yeah, okay.
1 second. Okay. Okay.
No, it's...
Sorry. Yeah, now I'm here.
Sorry. You got all the images. Well prepared.
Yeah. Sorry, yes. So I will just talk about the openable. As I said that the architect required the narrowest groove but the requirement of fireman was that you need to open it to 90 degree. So we had to achieve a balance that the openable is glazed completely from outside. Now, the moment it opens 90 degree, the glass will hit. So if I listen to the architect first, then I will have to get it rejected from the consultant. So there was a huge understanding done, what do we do? And that's why we said that we took a product from Germany and we just modified it and we showed and it was approved. So this is the openable. If you see on the left side, the groove is minimal as possible because you have a fin also at a lot of locations. And at the center, it is glazed. You have a 7 mm groove, and secondly, a fireman operation switch, fireman operation Allen key operating thing.
So from inside and outside.
Yeah. So inside you can actually open with a handle, and you have a openable which is opening out, and inside you can open with a handle, and outside you can open with an Allen key. And usually we have received this kind of reservation from clients that when you have this slot on the outside for fireman's key, that becomes a problem of condensation in glass as well as water leakage. So we spoke to the consultant himself that you give us a solution, what do we do? And the solution came out right, and Shuko developed a cap above it. So we are closing that with a cap and helping it that firemen can easily open it, and the water also doesn't go. This is how we solved it, and it actually came out well.
Right. Just one slide.
Sorry, Pratik, I have a question for you.
Yeah.
So according to you, what you're seeing on the screen today is the best that Shuko can do?
Is the best that we can do with 90
in Bombay City?
Yeah, in Bombay
City because of the CFO constraints.
Yes. 90 degree opening.
Yeah, I mean what you're seeing here.
Yeah.
We couldn't have done better than this.
Not better than this.
Now I have a question for Prashant. Why do you see a top hung and a side hung? Why do you require it?
Yeah, this was deliberated in the design stage itself. Ideally, we would prefer only one type of operable. Either it's a single shutter, complete 90 degree opening, or two shutter operable like it's shown here. Yeah, but since the panel size is large, 1.5 meter, yeah, so we had to split it into two. But to answer your question, there was a lot of discussion with the CFO team also regarding the provision of operables. And it was insisted upon that we have both types of operables, side hung as well as top hung.
No, but in the circular you have 15 meters. Every 15 meters you need. You don't require small opening.
But at the end of the day, we had to go with the circular.
What is in the... Okay.
There was a circular where we had to cater to this requirement.
You could have reduced one line.
No, I think it was more to do with the CFO, right?
Yeah.
He was not willing to.
Yeah. Okay. The other point is the signage. I think you had incorporated the signage bracket.
Yeah.
As Shekhar, I think how did you come up with the signage? The location of the signage, the position.
Fortunately, this building doesn't have like, some other clients of mine where you have one building and 100 signages coming down. It just has one.
So you have only on the top.
It just has one name on the top, so that's a relief. And of course we have, like I said, the surrounding is so banal that you want to sort of highlight your building from everywhere. So it gets seen by the metros on Andheri Kurla Road. It gets seen from the airport. So there are 2 or 3 very very strong vantage points where the signage of the building itself is highlighted. And along with signage, of course, I think your next question would be to do with lighting. So I think the biggest nightmare for any architect is to light up a glass building. It doesn't light up. You can't light glass. So fortunately, the fins and what Shuko developed for us in terms of the integration in the fins. So we have light elements which are sort of allowing the fins to be diffused light, which is going away from the glass. And then you have a lot of lighting on the undersides of the canopies and uplighting those spaces that sort of pick up accents on this. And fortunately, we have a lot of natural stone which sort of breaks the rhythm of this glass. And so all of those panels are lit up very strongly with different light treatments. We've not tried to do too much of Tom and Jerry and make 6 different colors on the light. It's just a very plain elegant lighting which will strike it at night time. Because this building actually gets seen from your drive to the airport. So both the hotel and the office building is very, very prominently seen from there. So we wanted to ensure that that gets highlighted.
I think that is a good thing, because otherwise you'll see every vertical lit, generally in projects. So I think this is a good thing to do. What about signage? The position you said it's basically just the top.
Yeah, you just position is on the top. I mean, it's really on the. Of course, you have signages on the lower ends, but that's not the context of this conversation. You're
I think the biggest challenge was to fix the signage onto the.
If you saw the video, there was a signage there. We are doing a very large central arrival with the fountain and all that. So we have a signage which sort of takes you on the curve of that big roundabout, and one signage also is expressing itself on the. Across the main arrival porch.
Right.
Which I don't think those renders are here, but yeah.
For the building envelope, I think it's more to do with the vertical fin, because the signage is in front of the vertical fin.
Yes. That's right.
So I think you had to give provisions. I think Shuko had to give some more extra plates which could hold that.
Yeah, and the support was through the mullions. So we need not have any supporting structure behind the mullion at the terrace level.
Right.
Yeah. So we
but for the Leela Hotel, the signage is on that dead wall. So you have that.
Yes. And the last point, I think it was to do with the aviation height, the challenge which we had in the aviation height, where, the main concern was the BMU, the building maintenance unit, and the strategies which we needed to do. So I think what is your solution to that?
When we started working on the BMU options, aviation height was definitely a challenge with 63.4 meters and the terrace going up to 50 odd meters. So we had very limited height to cater to, in which we could squeeze in a BMU system. And also on the terrace, we wanted to optimize the use of terrace to a minimum for the BMU. In 750 odd millimeters, we could manage traversing David system. Yeah. So it optimizes the use of the terrace for other activities also. And we had gone through multiple iterations about what are the various options in which we could do it. Yeah. So from the terrace point of view, this was a solution. And at the lower heights, we could use tucker pole and conventional methods.
So it was a whole maintenance strategy. Which
that was a strategy.
I think in the end of the day, I think you got the traversing divot, which has been installed right now on the site.
Yes.
Yeah. Next. Next. This is the tieback. And what about the tieback?
Yeah.
Like how did Shuko come up with a solution for the tieback button?
Yeah,
that was a challenge initially.
Yeah, firstly, for the restraint pins, obviously tieback. We had many discussions regarding the load, where it would take, which level it will come, will at the bracket level or so on, because the mullion design completely depends onto it. The structural team was stuck because they wanted a proper reply, and the projects team was also giving us a lot of revert backs on that what they want to do. Ultimately, the tieback problem was resolved by the consultant itself, that how do we do it and what kind of BMU system we are going for, and what seemed to have stuck, they moved very fast. So for Shuko point of view, we didn't have to face much design issue for the restraint pins, because it was resolved very well with the kind of BMU system and the kind of restraining pins used.
Right. So was it tested in the PMU?
Yeah, it was tested. And see, it works well to have it tested at the PMU, because this is fixed on transoms.
Right.
Yeah, so you can have a lot of water ingress from this location. So the detail was worked out. The transoms were stiffened sufficiently. Yeah, so
and I think the next slide is the equipment which is. I think this is the equipment which has been installed. Considering the height and considering the loading and all that stuff, I think this is the best in terms of the space. Yeah. Now we'll leave it to the audience to, if you have any questions for the panelist, not to me, for the panelist. Yeah.
I think so. That's it.
Hello. Good afternoon. It was a nice panel discussion. My name is Ishwar. I'm coming from LIT Realty. The question is that going towards the building maintenance unit, See, I'm seeing a lot of facade which is coming, a lot of features, starting from glass, fins, and a lot of aluminum metals, stone metals, etc. Now, the building management units, how you will be looking for each and every cases to maintain it. Okay, it is not only the system which we are placing on the top of the terrace.
Right.
Not only hook. If there is a facade system or cladding goes below the structure canopy, and there are some intricate member there where it is coming to the curve.
Right.
How you will be placing these sort of maintenance unit at the position, and in case if it is placed on the ground, how you will be housing the system in the which is not used condition, how you place it, how you will retrieve it,
right.
How you will be using, because in nowadays it's not a simple facade, it's a lot of other facilities are there.
Right.
Maintenance aspect of you and how it can be done, can you elaborate on that?
So what we do generally is in our project, sorry, I'm answering the question. So what we do is we take up the whole facade. Building envelope includes everything. It includes even the podium and includes everything in the building and what you need to maintain, and depends on the periodicity of it. When do you want to maintain it? How many times you have to maintain? So what we do is we map the whole thing, and whatever is accessible from the terrace, we use equipment which can clean the building or replace the glass or whatever from the terrace. Some equipments in the ground, it could be an aerial platform, it could be a scaffolding, it could be a tucker pole, depending on what you require, depending on the height of your, it is a triple height. So you may require an aerial platform or a scissor lift. So we include everything in the facade BMU. It's called a maintenance strategy. Right now we have also considered bird menace. That is another mitigation, which is in some projects we have a problem. So that is a maintenance strategy which we follow. It's not only the BMU. So in this project also we have done the same. We have around 4 equipments. But we didn't put everything here because it's just for the discussion.
Yeah.
That's the best world.
Yeah, you giving a mic. I guess, yeah. Stone being a very porous material, what precautions do you take so that there's no fungus in the future? And how do you enhance the life of stone and so that it doesn't decay, doesn't spoil, doesn't decolor?
So it depends on the stone, first of all, on the water absorption capability. Plus you go for a rain screen, which is basically an open joint. So you allow the stone to breathe. Plus you have a hydrophobic sealer, which is basically taking care of your stone so it doesn't absorb the water.
So this limestone which you have used is not water absorbent? Because limestone
it's a percentage. It's always a percentage. So some limestones it doesn't absorb a lot of water. Some of them.
So this limestone is from Italy or from Albania?
It's, I think, from Middle East. It's from Middle East, I suppose.
Okay.
But we have done the test results of the stone. Any more questions? I think we got 56 seconds.
Yeah, I think.
One last question.
Someone can just go for lunch. Yeah.
Huh? Yes, it's right. Hello. Hi. Sudhir here. I'd just like to know, since this project is close to the airport, has there been some challenges due to the acoustic constraints due to the noises? If there were, how was it?
So what is happening? We've already done a test. Generally what they do is they do a 24-hour test and they check the frequencies. So we have come to, I think, the outside dB levels around 75 to 80. And inside we required around 40 to 45 based on the codes. So we use a laminated insulated glass with a acoustic PVB to take care of that.
So even the systems to ensure
overall,
the
overall system
has that been. Yeah.
So the system was capable to handle that glass, and over and above we had the edge guards made up of thermal break material.
Correct.
So not only sound, we actually worked on the thermal insulation as well, because we using fins and big mullions that will actually convect a lot of heat inside. So we tried to use thermal break edge guards so that we could actually reduce the U value to an extent. Obviously, by using so much of aluminum,
you can just avoid some of the heat by using thermal breakage guards. So that is about sound insulation, what you said, and thermal insulation as well.
So I'm assuming was it a special approach, or that's the conventional approach for all?
So generally for all projects we do the
Acoustics
same.
as a
Because especially it's an airport. So it's close to the airport. So you generally have to look at it. And especially hotels we do it more.
Of course, even more. So it's...
Any more questions?
Yeah.
Here it says time up. Thank you.
Thank you. Thank you, everyone.
Thank you. Thank you so much for a wonderful panel discussion. May I please invite Mr. Keswani again on stage to share the mementos with the panelists? It's going to be on my favorite topic, advanced tools and automation in Façade. Let's please welcome Mr. Ritesh Jindal from Arup and Associates.
Good afternoon, everyone. Wonderful session after lunch. I'll try to keep it interesting as much as possible. Thank you. Firstly, I'll thank Ashwin for switching the slot. I have something urgent for which I have to leave, and he's kindly agreed to switch the slots with me. Thank you again, everyone, and thank you, Zak, for having me again to showcase some of the works and some of the things that we are doing. So my name is Ritesh. I'm basically the Mumbai office leader for Arup. I'm an associate there and also lead the Façade team and Façade business for Arup in India. Just a bit about the company before we start. So this company was founded in 1946 by our founder, Sir Ove Nyquist Arup. And he spoke about the principles of total architecture back then, and we try to still live by the principles of those in our work, in our day-to-day life. One of his key notes that he said was, when architects talk about cranes and engineers talk about how a window should be placed in a building, that's when total architecture is a success. Quickly about the firm, we are 18,000 people spread across in 94 offices across 34 countries. In India, we are present in 4 different cities, headquartered in Mumbai. We have people in Delhi, Bangalore, and Hyderabad as well. In India, we have presence for more than 50 years, although we got ourselves established in India as Arup India Private Limited in 2005, and our first office in Mumbai was up in 2008. And I'm proud to say that we have finished more than 250 projects in India by now. And one of the key things that we do, or one of the key strengths that Arup has, is multidisciplinary teams sitting under one roof. So we have structures, MEP, geotech, facade, acoustics, lighting, you name it in terms of engineering, and we are there to support our clients. And I'm just going to show a few of the projects that we have done as part of this cohort of multidisciplinary team that helps us deliver some excellent projects in India. And this is also in continuation to what we were talking about, the formation of SFE a while back, where we as a team, we as a country are already delivering some of these excellent projects. I would like to start something that has been recently launched 2 days back, inaugurated, the Navi Mumbai Airport, where Arup was part of the team in the earlier phases of concept and scheme, along with the Zahas, to kind of come up with the concept and how to make it possible. We have went on to deliver a lot other airports as well across India, and Terminal 1 and Terminal 2 of Bangalore is something where, again, we have done multiple disciplinary services, includes structures, MEP, baggage handling, facades, and all of that. Statue of Unity. Yeah, so we were part of the cohort where L&T was appointed as the contractor, and we were appointed under L&T to make this marvelous piece possible, the world's tallest statue. And again, the kind of services that we can offer ranges from facade to MEP to structure, wind engineering, vertical transport, fire, you name it, and we were there to kind of support and see the success of this building. Another project that we are doing, and is almost about on completion, is the Hindu Heritage Experience Center, which is coming up in UP Mangarh. One of the projects where we have also supported JKP Foundation to actually do the architecture on the job. Again, we were part of the initial phase of the project where the design and concept was done. We have offered multiple disciplines even on this job. And then our favorite project, Geo World Center, where we are all based right now. So we have done complete facade engineering for this project, from the day of inception till the completion, we were part of the job. Mumbai's first drive-in theatre, Geo World Drive Mall, again, one of our projects where we offered facade design consultancy services. And Brook White Lotus School, an award-winning project, part of Arup's CSR activity. So if you have seen the movie called 3 Idiots, the school that is shown at the end of the movie is actually the school. And we have won multiple awards for this. We still keep continuing to support this school in terms of expansion. Just last year, we had 2 of our engineers sitting in Ladakh actually planning the expansion of the school, adding a few more blocks to the whole campus. So just like I said, the strength that Arup has is a facade engineer sitting in our office is actually surrounded by all the other engineers. What it does is it gives us that freedom to go and understand, okay, let's say I have a problem in terms of structure, how it's going to work. I can just hop onto the next desk and tell the guy, hey, is it going to work? And that's how we become quite a team that can actually offer all of this together to create all of these masterpieces. In terms of facade, we are about 300 plus people across the globe, and we are connected via a network called Skills Network. This is an Arup internal network where we are all connected. And our team includes architects, it includes engineers, building physicists, material specialists, geometry experts, all of them coming together and responding to the problem that we have. The project on the right was my first project in Arup, and I've spent more than a decade now with Arup now. This is Jewel at the Changi Airport. So the whole roof optimization, and people who have been have definitely must have seen this. It's a masterpiece, and how the geometry was optimized, which I had presented in the previous Zak. So I'm going to skip this project this time, but you can obviously see the recordings on the YouTube. So Arup also is a private company till today. Yeah, we invest in our own people. We call it as an employee-owned company. So whatever profits we earn, whatever we do, basically we try to invest it into ourselves, which is where we kind of do innovations, we kind of do a lot of PhDs, research, all of that, all funded within us. So we do use our own profits to expand ourselves, to expand our skills, to expand our innovation. And which is where my topic also continues, where I'm going to be talking about digital tools in this session. Okay, why digital tools and why I chose this topic is because we are in the age of AI, where advancement is happening at a very fast pace. If we don't pick this up now, I think we'll lose kind of the battle to go ahead. So that's where I would like to start my presentation. The presentation is basically split into 2 parts. The first one is about rationalization of panels and how automation can actually help you create more and more better structures. I've heard the previous presentations where cost became an important factor, but we're trying to create a world where we still want to see those innovations coming into place. So cost could be one of the factors, but we don't want to kill the architect's vision because we want to be more optimized in that sense. So with that, the project that I have is a roof cloud, which is sitting on top of a 125-meter tall building. And the whole complexity was the architect came to us and said, we have to make this work. And then we started scratching our heads. I mean, what is the shape? What is the geometry? And he said, it's purely organic. It's purely defined in such a way so that, it feels like it's a forest. Yeah. I said, okay. So we started dividing all the panels. And now one of the important things about automations and rationalization is you need to not just think about how the design looks, but you need to also think about fabrication and how it's going to be installed. Yeah. So when we divided all these panels and we kept them into these squares, we kind of found out that there are more than 3,000 unique panels. Now imagine a contractor on site is going to be a nightmare doing 3,000 unique panels, where to install, which position. It's going to be crazy. So what we did is we finally went down to start optimizing these panels into triangulation shapes. In automation or in scripting, the most important thing is to set up your initial parameters, or you set up your KPIs in advance. So you know which parameters you're going to deal with, and then the automation, and we let basically the automation play around its own game to come up with the most optimized solution. In this case, we had area, height, and width. We took each one of these square boxes and tried to create most optimized panels so that they could fit in within these 3 classifications. And with that, we created a whole grasshopper script. And this script basically talks between each of these panels and tried to come up with the most optimized shape. We kind of divided them into 3 different zones. And then eventually we reduced the number of panel sizes, because once the script was ready, once the whole geometry was ready, it was just a few clicks for us. Okay, let's say 1200 is not working. We make it 1250 and see what happens. Yeah. So with that, we created various options. Okay, and you can see in the 3 geometries, if you see the bulging. Never mind. If you see the bulge keeps on changing because now we are trying to optimize the geometry. And the architect was pretty happy. He said, wow, it works well. It is optimized. It's easy to construct. And that's where we kind of finally resolved the geometry, gave a few options to the client as well. These are the options. This is where the number of panels is going to change. This is where your cost is going to be worked around. So that's how automation can help us quite a lot. But with this automation, we kind of realized that we have lots of data. And in Arup, like I said, we invest a lot in our own people. So we believe that, if we try to optimize all of this data, we can basically create a lot of use cases or make informed decisions or help the client to reach to the best possible solution. Now, before I go into that, I would like to just present this triangle, and I try to do this because we are in a world where data is everywhere. It's just discrete facts lying around, and only when the data is more structured, it becomes information. And with a lot of information, you gain knowledge, and to use the knowledge is basically wisdom. Now, I know these words are like very subtle, but if you just talk about knowledge that we have learned from so many different projects, so many different learnings, that's when you can apply them into the next project. So it is so applicable, not just here to even your daily aspects that you do in day-to-day life. So we created more than 2,250 plus tools within, and then we have a nice dashboard within our internal network where you can shortlist each of these tools depending upon which discipline it is, what does it do, and where the tool is and which software does it support into. So, for example, you're looking after a CFD simulation that you want to do in case there is a fire that happens. Where does the people run? What is the running path? You can just basically select fire engineering. You will see all the options which tool can be used. You can pick that tool and actually apply that into the system or into the software that you're working. And it'll basically just create those automation quick scripts for you so you can come up with a few quick solutions. With that, out of these 2,200 plus tools, I'll be talking about just 3 today, just 3. The first one is called Arup Inform. Now, this is a tool that is, I think, one of its own class. I'm really sorry, some glitch. I can't seem to change the slides. Thank you. So Arup Inform. What Arup Inform does is basically it's a data-driven design platform, and it can help you do all the permutations, combinations, and actually eventually reach to a point where you can actually make the most optimized or compromised design that fits all the parameters, whether it's the architect or the client or the engineer. Now, in this whole process, how this whole process works, so you have a design challenge. Basically, you have a problem. What do? Like I said earlier, we set the KPIs first. What are your KPIs? Is it you want to be optimizing maximum area? You want to be optimizing the cost, or the direction, or the wind, or the cooling load? You define all those parameters, which sets your parametric start point from where you can develop your script. And then those KPIs, those parameters runs into options and options and options and does iterations for you, after which you can come up to a solution, a final proposal that you can submit to your client and then make a decision. Like I said, the client wants function, he wants cost, he wants optimization. Engineer wants performance, and architect has his own inspiration, his own creativity. And we don't want to kill any of that, yeah? We want to do all of them together. So we created a basic framework where you have your ambitions, you have your boundary conditions, you create script, you generate solution, analyze them. It's all cloud-based, so we can sit together in one meeting room and actually resolve everything at once. So one of the projects that we did, we had GFA, sunlight, daylight, settlements, noise, structural wind, all as our KPIs. We went through various options. Once we had set all these parameters, the software just keeps running all of these permutations. We kind of formulate all of these into a spider web diagram, if you want to put it that way. And in a meeting, we were sitting with the client, and we were deciding which key parameters are most important to which person. The client said, okay, why don't we see which are the most optimized options? And then we said, okay, this one, we liked it. So it comes into your favorite. There are 11,000 options in just this one slide that you can actually visualize, take a decision, in one meeting. That's the power of this tool. And then once you have all these three options, you sit together. You decide which is the final one. And that final options becomes your parameters, and then all of your values come on the right. So this is the prototype that we had done, but we have actually applied this on a project which is coming up in Pune. Unfortunately, I couldn't show that because of the confidentiality reasons, but that's on Arup Inform. Let's go to the next one, Canvas. What Canvas means? Canvas is just basically a blank sheet for any artist. You can draw anything you want, yeah? So we thought, why don't we create Facade Canvas? Why don't we create infinite possible of solutions that we can actually present to the client or come up with options? So people who have come to my previous Zak presentation, they know we had developed this a few years back. But this is already outdated. We have a much advanced version of the same tool, which I'm going to show you now. So what this tool does is basically it can create all the conceptual options. You have all the parameters that are on the left where you can basically keep editing them, be it your mullion depth, be it your angle of the whole facade, be it your distance between the panels, the panel width. No matter what you want a different offset, you can change it. Yeah? With all of that changes, we created basically a C# script that tells you the behavior when the slab deflects, how the panels are going to deflect. So this was used on a project in Mumbai where we were sitting with the client, with the architect, with the structural engineer, and trying to come up with that deflection value of L by distance between the columns that's required. So the structural engineer can immediately start working on his scripts, and we can start working on our profiles. Not just that, I'm going to show you the prototype. So when we had all of this information, we said, why don't we create something where we can actually do structural calculations within the same platform? So people who know Arup, we are also a software development company. We develop our own softwares, and one of them is called GSA. It is a structural software. And we have basically integrated GSA with all the key options that you see on the top. So you can input any of your load parameters to any of the systems, and you can immediately, just by a click, you can tell whether this concept is working or not. Yeah, so that's now a prototype which is soon going to be into the whole facade canvas concept. So you can create those concepts and do structural analysis on the spot, and you can tell whether this system is working or not. The last one, a lot of people spoke about maintenance in today's session. So how do we do the maintenance strategy? A lot of times we just get drawings and SketchUp models from the client, from the architect. We start sketching them, okay, this area, that area, okay, we create a few drawings. And what happens when the architect changes the file? You have to go back to your drawing board again. You have to make those exercises again. So we said, it's becoming a repetitive practice. Plus, every time we have to extract all of the plans, all the sections, and keep creating these elevations. We said, why don't we go digital way? Why do we still have to go traditional way? Then we created a digital BMU whole strategy. Now, this building is how we resolved all the systems. You can see the various colors on the screen where basically each system defines how it's getting cleaned and maintained in its life cycle. So what it does is basically, once you have all these libraries and you have plotted everything, again, we have some smaller automation tools that basically helps you create sheets, sections, elevations by its own. So once you do a few clicks, basically all your sheets get generated. And you can also export them into a bigger documentation package. So by the time you just do a few clicks, you go get a coffee. By the time you're back, you have your documentation ready. And the best part about this is, in case there's an update in the model tomorrow, you just have to run a clash detection and see which system is actually clashing with the facade. And you can change the system. And then immediately run the analysis, and then you know you're ready with the new strategy. So what we have changed, we have increased the productivity, we have increased the efficiency. Change has become much easier for us. The time spending has reduced. Yeah, the manual calculations have reduced, so we spend lesser time now, and we can document anything. You want any area, you just cut a section from the Revit model. It's there. You know which system is going to work. Yeah? So that's the power. That's the power of automation. That's the power of creating all of these worlds into 3D. I love 3D, by the way. I started my career as a computation designer, eventually reached to becoming a facade consultant. Yeah? And we said, you know, we have lots of data now. We know each system. We know where it's functioning. So we said, why don't we use this? Why don't we use this data, again, to make a tool that can help the client make informed decision? So a lot of times clients tell us, you know, why do we have to buy these heavy machines? Can we just rent them? I said, okay, we can. But what is the ROI? How do we do that? So all of the area that you have for each of the system, you can basically calculate how much time it takes to clean the system. You can basically calculate a cost. And we said, okay, we have cost, we have area. Okay, let's come up with quick strategies. So we created a few options for the client. We said, okay, you're going to be using this building for 15 years. Or let's say you're going to be replacing the machine after 10 years. Okay, let's put 10 years in there. And as soon as you create those options, you know the area, you know everything. It basically tells you whether you need to purchase the machine, whether it's going to be more valuable, or the option is to rent. So just by doing these few exercises and using data, you can actually create a much informed design decisions. So it doesn't have to be very cost-driven. It doesn't have to be very design-driven, or it doesn't have to be very ambitious. It can just be some simple solutions that we do every day, but just use those information to actually create more sense out of it. That's the message that I would like to give. And as we say at Arup, we shape a better world. Thank you very much. If you need to contact us, that's our QR code.
Wow. Is this on? Yeah. Wow. Thank you so much, Ritesh. He was completely speaking my language, grasshopper, and yeah, from a fellow computational designer. It was a lovely presentation. He has really simplified what computation and algorithms can do to actually optimize our structures. And it's really in the need of the hour because you saw so many aspects can be touched upon by it. Our next presenter is Mr. Ashwin Shah from Zaha Hadid Architects. I'm sure you all are eagerly waiting for this presentation. May we please have Ashwin on stage.
Sound.
Hello, everyone. Thank you for the invite, Shraddha, for this presentation. It's a pleasure to talk to you about the Navi Mumbai International Airport today. I found that video on social media yesterday, and I thought it would be a good start after a heavy lunch. 14th March 2018, Zaha Hadid Architects won the design competition, beating 2 other international practices to design this prestigious building in Mumbai. On the same day, we signed the contract and started work on the project. For those who don't know, Zaha Hadid Architects was started by Dame Zaha Hadid in around 45 years ago, and she has really pushed the boundaries of design and architecture with her fluid language. She won the Pritzker Prize in 2004. Unfortunately, she's no more, and the firm is now run by Patrick Schumacher, who was her business partner at that time. And yeah, the firm is about 500 staff members from 50 different nationalities and speaking 45 languages. So it's a very diverse practice. and we have won a lot of awards across the globe, and one of the most followed firms on social media. Just going back to a bit to the start of the practice started with a lot of sketches, large paintings, and model making, relief models, a lot of optioneering to get to the design solution. And to look through some of the iconic projects that we have built, the Maxi in Rome, which is a museum with a fluid circulation through the common areas. This is the Hyder Ali Center in Baku, which is one of, again, a very iconic project with the galleries and auditorium on the inside. And this is Lisa Soho. It's a 200-meter tower in Beijing. It has the largest atrium when built, and with this twisting form. It's quite impressive when you're there. And of course, the Beijing Daxing Airport. This is the airport that got Zaha Hadid Architects on the aviation map, quite popular, with this large spans, about 70 meters spans between these columns. After that, we have built a few more. This is the Chongqing Satellite Terminal, which is under construction, and the Western Sydney Airport, which is opening soon. But today, we're here to talk about the Navi Mumbai International Airport. And the concept was based on this lotus flower with the fluid lines and the movement of dancers and the floating effect of these lotus flowers in water, which is like the roof that floats over these columns. This iconic column has now become the signature of the airport. The master plan is basically two parts. The western side, which has the 3 terminals forming the central terminal complex, and on the eastern side, you have another terminal and flanked by the 2 runways. The phase 1 and 2 is 20 million passengers, which opened, it was inaugurated 2 days back, and phase 3 extends it to 50 million passengers, phase 4 to 70, and with the other terminal on the other side, can take the total capacity to 90 million passengers. Just when we started the competition, the runways were already set that by the government authorities, and the distance was set at around 1,600 meters between runways. There was a placeholder master plan in place for that. And we looked at reference, like the Changi Airport in Singapore has a similar distance, and you can see a master plan which is quite identical. In comparison, the Beijing Daxing Airport is about 2,400 meters apart with the inter-runway distance. A little bit different spatial areas for the terminal. So when we looked at the master plan, we did a lot of studies, and we questioned what that should be, what would be the optimal master plan for Navi Mumbai. We looked at a mega terminal, we looked at connecting terminals, we looked at separate terminals, and there was an evolution that led to the final design. That changed, kept evolving after the competition with discussions with the client, and eventually it became an interconnected terminal, which basically let the client able to phase the project over time, but also eventually could become a hub airport. So the final master plan is a highly efficient, minimizes walking distances, and then maximizing the number of contact stands to the terminals, and then provides an efficient airside and landside. The terminal itself is based into 2 major levels. The level 2, which is the departures, and level 1 at arrivals. Level 3 has the lounge areas, and level 0 then has the baggage reclaim that provides double height space to the arrivals. The strategy allows for a step-free access right from the departure forecourt all the way to the gates, and then you have the ramps that go down. Look at the departure passenger experience. The terminal welcomes travelers with its flowing forms of the grand entrance, an exciting start to their journey. The sculptured mega columns inspired by the lotus flower guides the travelers through the terminal, bathed in natural light. The VIP lounge overlooks the terminal areas, and the retail areas are designed as steel frames that can be modified in the future, maintaining flexibility. The piers continue the expression of the ceiling pattern as you head to the departure gates. There are interlocked scissor ramps that reduce the need of lifts and escalators and are highly efficient to bring the passengers down to the level of the plane. Travelers then move through the fixed link bridge, giving a glimpse of their journey before they board the plane. On arrival, the travelers enter the terminal through the same fixed link bridges, but then they stay at the same level. The arrivals corridor are quite simple, but they do get a glimpse of the departure level ceiling before they kind of descend down to the double height baggage reclaim area. The baggage reclaim again continues the expressive ceiling design. Today, I'd like to talk a bit more about the facade and some key design features. The building can be subdivided into various components: the roof, the canopy, the earmuffs, the glazing, and the FLBs. And they can also be split into different facade systems. So the idea was to try and keep as many of these systems very simple and easy to build, and then focus the complexity to only a limited areas. One of the key was the drainage of the terminal with such a big roof. And in Mumbai, you have more than 1 meter of rain in a single day. So the strategy was to then slope the head house from the land side to the air side at a 5 degrees angle with a peripheral gutter. And these gutters are quite big, like 1 meter by 500 meters, 1 meter wide by 500 mm tall. So it can take all the rain off the roof. The canopies are also modeled in such a way that they have a 5% slope at any point on the surface. And then there's a peripheral gutter that takes the water down through the touch points. If you look at the FOCO canopy itself, it has 4 main parts to it: the roof, the soffit, the fascia, and the mega columns. The roof is a standing seam, which then was panelized based on the geometry to create tapered, flat, and curved surfaces. And these were all based on what was then available in the market. Right. We did a lot of analysis to that surface, making sure that the length of the panels was within manufacturing limits. And then we had some mock-ups to look at how this could be executed. We did have the experience of doing these standing seams. We had done it at the Aquatic Center in London. And we also looked at other references which had similar strategies. The standing seam, the roof itself was built up with the primary structure on which you had the purlins, and then you had the metal deck. We had the acoustic board and insulation on which the standing seam was installed. There was a lot of coordination required with the structural team. We had to make sure that the total depth of the roof was optimized. There's not much minimum steel used. And that the contour of our roof then follows also the structural principles, but then at the same time keep the design intent. And these touchdown points were the most challenging point of this, and it's also where all the water comes down, and you have the large gutters to these sides, And it was very important for us that we don't see these gutters on the approach to the terminal. So these gutters were then installed in the fascia, hidden inside that, and that also became like the signature line of the project. So here you can see this photo taken 2 days ago, that the fascia has come out quite well. The standing seam is yet to be installed, and that's the acoustic board, I think, there. And then the fascia itself is an aluminum panel that is then put on a secondary structure that connects to the primary steel. And here on the picture, you can see that secondary steel being installed. The ceiling, similar to the roof, is again a curved surface. That was also rationalized and split into parts, into flat panels, curved panels, tapered panels, curved and parallel panels. Of course, that again, the touchdown points had the most complexity to it. These were basically slats, aluminum slats that were then assembled to create a larger panel. These panels were then connected to the steel purlins, and then there was a secondary steel truss that connected the whole system back to the primary steel. The primary steel followed more the roof geometry and not the ceiling geometry, so we needed a secondary steel frames to then look at wherever there was a deviation from the roof shape to the primary steel, that became the infill. And then these mega columns then continued the ceiling aluminum panels because we wanted the continuity from the vertical to the horizontal. So it's the same panel that continues down. The glazing was a bespoke semi-unitized system which had standard unitized glass panels but then installed on a steel mullions. While most of the facade is the glazed facade is quite simple, there is one moment in the head house where the facade inclines 10 degrees to the air side. And that kind of brings in a bit of dynamism to the terminal building and breaks this long, linear airside glass facade. That angle then is also along a curve, and it was modeled as a conical surface. And then you had these blend transitions that went from a inclined surface to a vertical surface. The panels eventually are then just flat panels installed with the tolerances that you can see. Here you can see there's a shift in the glass panels, but it's quite small that you don't really notice in real. Then of course the feature mega columns, just to look at how this was built. So this is the design, and this is how it looks now in real. So the main structure of the building is a simple RCC frame structure, but then you have these big mega columns sitting on top, and that spans large column free spaces on which the roof is installed. And here you can see these columns under construction, and that creates these really big, vast open spaces in the departures area. They were quite big that we also managed to fit in the maintenance stairs to get to the roof for roof access. And here is an exploded axle of the column, which has then the skirting, protective skirting, column cladding, the column substructure, the ceiling, and then the primary roof structure. We wanted to make sure that these columns were repeatable, but then the roof got sloped to the air side, so that means all the heights were different. So to try and maintain that repeatability, we moved these columns in the z-axis. So that way we managed to keep the petals the same, but then there's a scoop that is unique for each column row. And the columns themselves were made of GFRG, and then they were all connected together. You can see on the right image in progress, and at the bottom you can see the steel frame that holds the panels. And then they were all glued, they were taped and then plastered so that you get this seamless finish to the column. The ceiling itself was inspired by Indian motifs. And there's a picture under construction and how it now looks almost completed. So again, repeatability. So they're all the unitized, have the same ceiling across. And so one module component consisted of 10 parts, and it's kind of symmetrical on the north-south axis. And then each part then had a flat edge and scallop in the center, about 600 millimeters in height. And these scallops were then rationalized to be, again, a cylindrical slat system so that it's easy to construct. Some of these units also had a skylight on top, and that brought in daylight into the terminal. And to achieve that, we took these slats and tapered them to create gaps in between that filtered daylight through. The roof is, of course, quite a huge build-up, so getting that daylight was a challenge. So we introduced these light wells that focus the light through this from the skylight down through the ceiling. And we did a daylight analysis to see with the light well and without the light well, and you can see a lot more light coming through. And each of these modules then had a ring around each part, and that was a metal frame, and that metal frame integrated the lighting system for the terminal. The arrivals forecourt columns are also quite unique and sculptural, and you can see them on site. They're quite, I think they're quite stunning. So they're all cast in situ concrete. And basically there's a metal I-beam in the middle, and then it's cast with concrete around that. And that was the mold to cast those columns. It's a single mold, or like split into half, that then they could do the whole thing in one piece, one go. And it's quite impressive what the contractors have managed. Yes. I think just want to talk to you a little bit of the journey that we had by sharing some of photos to end the presentation. It's just some photos in the competition stage. So this is our team. We had a lot of design options that we did till before we came to the final design. It was not an easy process. You could see like a zillion options that were being done. We had a lot of meetings with our consultants. We needed to get this design and engineering to come together. And that led to a lot of sleepless nights. We had an air mattress in the office behind someone's desks. And then we would take turns, sleep sometimes, or go without sleeping for multiple nights in a row. This is the night of the submission, the core team. And at 5:43, we managed to just finish in time so that we could go catch a flight to come for the Mumbai. We printed all the panels for the presentation and then brought it along with us. Some of the team stayed back and continued to work on the report so that once we arrived in Mumbai, they sent us that report and we could get it printed here in Andheri. We tried to get as much time as possible. Even like another half an hour, we could say we tried everything we could. And then assembling all the various documents for the submission. And that was the booklet we produced in 2 months for the competition. That's our director. He was very happy. And then it didn't end there. After the submission, we had the presentation. So then more people flew in to Mumbai, and then we started preparing the presentation. And then we had the presentation at the Santa Cruz Taj Hotel, and we were given the hall the night before, and they said, yeah, you can arrange it as you like. So then we went out again to the print shops and printed these large 6-meter tall banners and then install them ourselves overnight. And that really impressed the client. And then we had models that came in from China. And then all these prints that we had taken from London, we organized all of that. And that's our director preparing his PowerPoint presentation the night before. And some of us then had to just sleep in the venue hall while preparations were happening. And then Patrick then presenting to the client team the next day morning. It's a group photo of us. And then, I think this photo is nice because it gives a sense of scale of these banners. And it really gave a feeling that you are standing in the terminal, even at that point. And then a celebratory lunch afterwards. Well, it didn't really end there, because once we won, we are back here often. But then the breakfast was the only time where we really saw daylight and got to sit together for a moment of pause, because after that, from 9 to 9, we were in these meeting rooms continuously, just constantly discussing and having a lot of meetings, looking at all the aspects. Occasionally, we did manage to go out to Mumbai, taking some of them on to giving them the Mumbai experience, and going to Bademia, and just huddled in together. And just a note, that's Chintan Shukla. He is the design head from the client side, and he's really changed the face of airport design in India. So he's responsible for designing the Mumbai T2. He's responsible for the new Bangalore T2 terminal, and now also the Navi Mumbai airport. So incredible dedication. And that's him again, making sure everything is perfect on a site visit. Just the last couple of slides. To pull off such a project, it requires a huge team and a lot of people that put in a lot of effort to get through, and just want to thank all of the design team involved. I'm sure a lot more people are also involved, but that was our design team and the clients and the contractor. And that was our team. We had 72 people work on this project over a 2-year period, and I also want to thank all of them. And last but not the least, I want to take this opportunity to thank my parents who are sitting here in the audience. In an age of doctors and engineers, they have supported my ambition to be an architect, especially my mom, who sacrificed so much to give us everything that I wanted. Thank you very much.
Thank you. Thank you so much, Ashwin. This was a wonderful presentation again. I think all of us were eagerly waiting for this new project as well. One more computational designer, which I personally love. I'm hoping you all enjoyed the presentation as much as me. Next in line, we have Jennifer Schneider from Curare Group. Let's have her on stage, please.
Good afternoon, everyone. First, I want to thank the organizers of this conference for giving me the opportunity to speak about one of my favorite topics, structural interlayers. And I want to thank you for your attention this afternoon. I know it's been a long day. I do have some exciting videos. So with that, let's get into it. So I'm going to be talking about 5 different things today. I'm going to give an introduction, show some nice pictures of some examples of structural interlayer in glass, talk about what's new, a new product called Trosifol Extra Stiff Pro, which is the stiffest PVB interlayer available on the market today. I'm going to talk about structural interlayers don't just create beautiful buildings, but they also can be sustainable. And then authentication of interlayers. It's important to know that you're getting what you specify in your project. So here are some examples of how structural interlayers have transformed how we design buildings with glass. Structural interlayers, they're pushing the boundaries of glass. Here's some examples, primarily Oh, my pointer's not working. Primarily, oh, there it is, sorry. Primarily in the US, we've got the Edge in New York City. If you ever get an opportunity to come to New York City, I highly recommend going there. It's beautiful. We've got the Steve Jobs Theater in Cupertino, which is a great example of curved structural glass. The Vessel, also in New York City. This exciting thrill ride of the US Bank glass slide, where you go from the 70th floor to the 69th floor. I recommend that. And then the Hard Rock Hotel and Casino in Miami. So what is laminated glass? For those that don't know, it's basically taking glass and putting an interlayer in between. PVB is the oldest interlayer known. It's what's in everybody's car windshield. So you look at it every day, and it's there to protect you. There's basically two types of interlayers. There's the standard PVB, and then there's what we call structural interlayers. Ionoplast, Centriglass Extra, and SGX. Not to be confused with SGP. In the structural interlayer family, there's really two types of interlayers that you can choose. There's the extra stiff, Trosafol Extra Stiff Pro, which is the stiffest PVB interlayer that's available. I'm going to talk a little bit more about the performance of that. And then there's Centriglass, which is the highest performing structural interlayer on the market, hands down over anything. So PVB, Trosafol Extra Stiff Pro, the stiffest PVB, Centriglass, the stiffest interlayer available. So here you can see this is just showing the, there it is, I keep losing my pointer, sorry. This is showing the difference in modules between the different structural interlayers, and you can see Centriglass has the highest. You can see the red line here is the Extra Stiff Pro, and the pink, or salmon colored, is the other stiff PVB. So you can see it offers a little bit higher modulus than commonly known stiff PVBs on the market. And the blue is PVB. And I'm going to show an example of a balustrade using Trosafol Extra Stiff Pro. This is a standard balustrade using an imposed line load of 1.5 kilonewtons, design temperature 30 degrees, load duration 10 minutes, and a load duration of 1 minute. And you can see here, if you look at the maximum stress, if you look at the maximum deflection, you can see here the other stiff PVBs are 33.39, whereas the Extra Stiff Pro is 29.61, or about a 13% lower deflection. And then if you look at it for the load duration for 1 minute at 30 degrees C, you can see we've got a 22% improvement in deflection using Extra Stiff Pro. And I think this is a video. Oh no, this is just showing a line load at the top of the balustrade. And this is where you can see the difference in deflection, the Extra Stiff Pro in orange and the other stiff PVBs in blue. And that's at a test temperature of 30 degrees C with a load applied to the top edge. And this is a video. This is showing a comparison between standard stiff PVBs and Extra Stiff Pro. On the right is Extra Stiff Pro, and you can see the difference in deflection there. Okay, and here's some more. This is post-breakage strength. This is 4-point bend test on broken glass beams. And then also it provides improved creep resistance. So if you look at the Extra Stiff Pro, which is the orange, and you look at other stiff PVBs, it has better creep resistance than commonly found stiff PVBs. And you can see that by the deflection and the time. Also, edge stability. Edge stability is very important, particularly in open edge balustrades. And in the 5,000-hour salt spray test, you can see the difference between the two different materials. You can see here the other stiff PVBs, you start to get some edge cloudiness, whereas the Extra Stiff Pro, it's much less. And the appearance. So the one on the top is standard, typical stiff PVBs, and Extra Stiff Pro has a nice, more closer to a Sentry Glass kind of open edge appearance, more of a bluish color. And here's just an overall comparison between the products on the market today. And as I said, you know, Sentry Glass is your highest performing product with a Young's mileages of 413 and 187 and 78 at these various temperatures. And you can see the Extra Stiff Pro comes in less stiff than that, but stiffer than competitive stiff PVB products. Sustainability. So not only do structural interlayers create stiff structural glass, but they can also be sustainable. So Kuraray, we have a mission to be net zero carbon emissions by 2050. I'm sure all of your companies have some kind of sustainability goals. And if you look at life cycle analysis, and if you look at the amount of kilograms of CO2 per kilogram of product, Sentry Glass has the lowest CO2 per kilogram than any other interlayer on the market today, other than some of the new low carbon interlayers. But if you compare it to standard PVB, it's much lower. And again, this is showing, as I mentioned, we also have a product, I'm not going to go into the details of it, but we have just launched a Trosafol R3 product. This is the lowest CO2 per kilogram interlayer that you can buy. Sentry Glass comes in at about 3.92, and standard PVBs are 4.45. So Sentry Glass has a lower carbon footprint than PVB interlayers. And because Sentry Glass allows you to use less glass, it allows you to use less metal. We know glass and metal have a heavy carbon footprint. So if you take an example here, where we look at 8 millimeters of glass and PVB, which is what you would need to get to the deflection requirement, same deflection as Sentry Glass, you only need to use 6 millimeters of glass. And here, your total carbon footprint is 41.8 kilograms for CO2, whereas in the example of the PVB, because you have to use thicker glass, you are now at 55 kilograms for CO2. And so you can look here, standard laminated glass, thickness, weight, carbon footprint, you get a savings of about 24%. Next, I'm going to switch gears and talk a little bit about ensuring that you're getting the product that you asked for. So Sentry Glass, as I mentioned, has been in the market for over 25 years. It is the original structural interlayer that has the performance expectations to meet the demands of your project. And so it is the official brand. It's Sentry Glass. You may hear other companies offering products called SGP. They may not necessarily be, and probably are not, Sentry Glass. Sentry Glass is Sentry Glass. It's based on a unique chemistry that provides a unique set of properties. And we're doing things to help protect the brand and to help protect the building owners and the developers to ensure that they're getting what they expect to get. Also, Sentry Glass has, because it's been in the market for a long time and it's been tested to all of these standards, it has, if you want to be selling product into the Florida hurricane market, you need to be Miami-Dade approved, and we are. In Europe, you've got the DIBT approvals, and then in France, you have CCAL and CSTB, which this Sentry Glass interlayer is approved by all of those. I want to talk about the risk of using something that's not Sentry Glass, and here are some examples of some project failures. This one here is a facade, it's a glass fin, and you can see that there's some iridescence and defect. It's a multiple ply SGP interlayer, not Sentry Glass. And you can also see there's very high haze. And then here you can see where the fin has actually broken. Because this product, although it claims to have the same performance of Sentry Glass, it does not have the same performance, does not have the same durability. It's not based on the same chemistry. Here's another example here. This is an airport in China. And here you've actually seen where the inner layer has actually started to crack in between the laminated glass. Because of the poor mechanical properties of the inner layer, it's not able to withstand the stress of the glass, and the inner layer itself is actually cracking. I don't think anybody wants to have this in their project. And here's another example of a failure. This is more of kind of the same. This is haze, as well as micro cracks in the inner layer that have formed after the glass was installed. Now I'm going to show an example of post-breakage strength of a SGP product. This is actually a brand called Hongbangxing, HBX for short. You can see it's hit and it does not stay up. It breaks and it falls down. You would not want to have that in your balustrade. And here's another example. And it breaks and it falls down. Again, it doesn't have the same mechanical performance. So how do you protect yourself? We've just launched this new blockchain solution. It's a type of tool where it uses tokens to track the inner layer all the way from the laminator to the building owner. And it's a way that you can be sure that that laminator is really the one that's making the choice of what inner layer they're going to buy. And if you specify Sentry Glass, you want to be sure that they are putting Sentry Glass in there. So I'm just going to show a short video that kind of explains it.
Now, Sentry Glass interlayer can carry a digital fingerprint, a unique identifier that secures its history, quality, and journey. From our factory, your site, nothing is left to chance. At the core is Certiply, Kurare's blockchain-based tracking system, a decentralized tamper-proof solution that links data in chronological blocks. Every movement, every update, every hand it passes through is recorded and encrypted. Once created, the token becomes a living part of your project, moving across stakeholders in real time. It's not just traceable, it's visible, verifiable, and transferable at every stage. It gives you confidence in your material and proof for your clients. Discover how Certiply is shaping the future of laminated glass.
Yeah, so in conclusion, if you want to learn more about Certiply, please stop by our booth, and we can connect you with the right people to help you get that incorporated into your project. In conclusion, standard PVB is not a structural interlayer. Sentry Glass is the best performing structural interlayer on the market today. Trosafol Extra Stiff is the best performing PVB stiff interlayer on the market and has an edge over competitive products due to its stiffness. Kuraray is the sole manufacturer and original of the original Sentry Glass, so be aware of knockoffs and people telling you that their product is the same. Low carbon interlayer, I didn't talk about this one in more detail, but we do have this Trosafol R3 product, which has a low carbon glass, can significantly reduce your footprint by as much as 44%. And that's all I had today. Thank you very much for your attention and your time. Stop by our booth. I'd love to talk to you about structural interlayers.
Thank you so much, Jennifer. I think as architects, we are really wary of, suggesting clients some new products, but I think we got a really good information right now to suggest Sentry Glass to our clients from you. May we now next have Mr. Ravishankar Subramanian from Dow. He's a principal scientist over there for some few words.
So good afternoon, all of you. After a wonderful lunch, having technical presentations, making you all keep awake, interesting, and then also make you learn. It's a good challenge for the presenters. Let me try my best. Okay. So I am Ravishankar. I am a principal scientist working in the capacity in Dow for last close to 2 decades. So I'm going to talk about the various solutions what we are offering in Dow. Beyond my always talk about how the structural silicon, insulating glass, weatherproofing silicons are normally used. So I'm going to talk something different today. So we are a company of 36,000 people with $43 billion, present in 98 manufacturing sites, 31 countries. And in India, we have close to 1,500 people working for this company. The solutions what we really look at today is Dow can offer solutions across various segments, whether it could be a residential building or we talk about the commercial projects, what we saw from the morning. And also on the infrastructure, we have various solutions which can be offered for your sealing and bonding needs. And when we really look at what we have done over last 7 decades, so the company actually started making products in 1960s. So we are in the 7th decade today, whereas our products and solutions have been used for various applications. And one is on the leading high-performance buildings. And also, if you really look at the top 20 buildings which are made in the world today, more than 70% of them have used our product. It is not only just the product, it is also the services, the reliability, the confidence, then the safety and security what we offer make us a unique choice for them. And we have a larger responsibility to make it good. So we are the first one to make a carbon-neutral silicon sealant, which can be used for the structural IG and weather seal applications. So there is always going to be a challenge in terms of how we can get a better durable product. So the first building which was done using Dow started in 1971. So it is like closer to my birth year, so 54 years of a case history, which is equivalent to any of the civil structure what we are talking about today. So that's the durability the silicon can provide you. So this is a PPG building in Detroit, what you can see in the top. So this is the one what was done as a first project with a 4-sided structural glazing. Some of the architect had really thought that I want to change the world, the way the glass has been bonded to the facade. So the paradigm shift had started that time. And these are the few case histories where you can see the incredible solutions of Dow has been used, whether it is talking about the tallest tower of Burj Khalifa or the one which is getting built, which is the Kingdom Tower in Saudi. So where all we are present, so I'll just talk about some of the silicon solutions. Traditionally, we are present in the curtain wall area, whether it is bonding the glass to the frame using structural glazing or making a double glaze units where the edges are sealed with a silicon, giving a thermal and acoustic comfort, and then the watertight seal on any of the exterior joints, whether it is a glass, stone, or the non-glass materials, which needs a weather sealing solutions. So we are present in that, and nowadays people are moving even away from glass at certain areas where they want to use different types of materials, what you can see outside. Somebody wants to use a thin tile, somebody uses high-pressure laminate, somebody uses stone. They all need a sealer, they all need a sealing solution between them, so that's where the weather seal comes in. And BIPV is something we heard today is one of the areas where Dow heavily contributes on. And the good part with this is the silicon sealants are coming from the quartz sand. So they have an inherent stability to fire, so they don't propagate fire. So some of the fire-resistant solutions also you can see here. So whether it talks about inherent curtain wall glazing, or it talks about solar panel, or it talks about the windows and doors sealing, or even the non-glass facades in terms of infrastructure, and also your household needs where you need to fix a mirror or a sanitary and tile sealing applications in your kitchen and bathroom. So all of that is possible, and all we have solutions, but it also comes with our engineering expertise because there are a lot of loads which are going to act on the sealant. So this is the one I was talking about, my favorite slide, where 80% of the projects are done with Dow. So you can go to Council of Tall Building Urban Habitat website, but you won't see Dow there, but you can see the top 20 buildings which are listed here. So they strongly believed in not only our product, like as I mentioned, what as a company we offer. So we offer design services,
design calculations. We do lab support services by testing the project samples. We do site-based quality checks. Then we provide a warranty. We take a liability saying that the sealant will not fail. So that's the durability we have in India. We are here for the last 3 decades. The first building was done in 1992-93, SR House in Mahalakshmi, which is 32 years old, which is standing tall. So any climatic conditions, whether you talk about world or about India, these case histories are very proven. So I just reinforce on, I touched upon it in my previous slide. So what we are going to look at today is some of the case histories wherein we are really talking about something very new in terms of sustainability, what we can do, how do we reuse the silicon, how do we reuse the glass and aluminum using this bonding technology, and how it is going to be green and sustainable. So there are various ways of doing it. So these are all the different applications. So there is a QR code in the building signs. If you can scan this, it will take you to different applications, and from there you can click and understand the various solutions what we are offering here. So I talked about silicon. So as we were always known as Dow Corning before, in 2016, Corning sold their share to Dow. Then we became part of Dow. When Dow came in, Dow was a master in material science. So they had various other chemistries beyond silicon. That's where our integration started. So conventionally, we were known for this structural glazing. 983 is one of the most popular product in India for bonding. And now we have launched a repair kit, 993. So this is for the quick fix on a glass replacement at site applications, because when you do it with a single part sealant, it takes time to cure. So we have this 2-part. It also cures in 1 to 2 days, so that your entire cost in terms of having a scaffolding or a gondola can be reduced to a drastic extent. We also have a transparent structural silicon strip. So we are working with some of your famous partners in getting this technology into reality. So there are some commercial trials going on right now. So these are on the silicons which are new. And as I mentioned to you, when we came to Dow, Dow was making many raw materials. Dow was making EPDM raw materials, some of the hybrids. They were making acrylic coating. So we thought, why don't we use that opportunity to get products into the market which can meet the customer applications and also the construction requirements. So we came up with our membrane. So it's an EPDM membrane which can provide you excellent water and airtight seal in your facade. On the coping, end of the facade, corner joints, wherever you see there is a potential for a leakage, this can be used, bonded with the hybrid sealant. And one of the shortcomings of silicon was silicon could never be painted. It has an excellent water resistance characteristics. So when you have a paint with a water-based paint apply on it, this will not wet it. So we have come up with a technology wherein it is a combination of silicon and organic, a hybrid sealant, which gives you durability and also gives you paintability. The last one is again a very good flagship product, I would say. It's a temporary protection film. Today, when you are putting a facade in a building, there are a lot of other applications, other work happening, which is damaging your glass, aluminum. And the current protective films have a durability of 45 to 60 days. Otherwise, they transfer the adhesive to the substrate, and that becomes a permanent stain and very difficult to remove. So we came up with the innovative paint technology, which can be applied using a roller brush on the glass and aluminum. This doesn't bond. This just stays there, and it gives a durability of 6 times of any of the polyethylene packaging solutions what we have today. This can stay for 12 months. So very long durability. It has excellent alkaline resistance to concrete, and then it also has a good welding sputter resistance. So anything which you want to, when you are using this film during the construction phase, this can give you excellent protection and reduce the damage, thereby reducing your cost of repair. I'm going to be very high level talking about some of the new technologies. Here is a cold bending. So the cold bending has been one of the new concepts which has been picking up across the world, wherein this is a cheaper way of getting a bending on the glass. It could be done at site, and you can manage that by doing a edge lifting or by the central bending. So, but when you do that, you are going to put a lot of stress onto the sealant which is holding them, whether it is a double glass or it is when it is bonded to the frame. So those stresses need to be completely studied, analyzed, and we have a great expertise here. A lot of projects in the globe we have done in cold bending. So we have a finite element analysis team which understands when the glass is bent, how the stresses are going to permanently come onto the sealant, because the permanent stress is going to result into some creep behavior. So that needs to be understood, and we are able to offer you that solution. So you can see some of these articles which are already published in the GPD presentations. If you're interested, you can always go through them. Coming to the carbon neutral, we are the first one globally leading again on the sustainability, offering a carbon neutral silicon. So this requires a lot of dedication, commitment from an organization. When you make a product, ensure that your product, when it goes to the market, gets you the carbon neutral, because this is the biggest thing which we have to be responsible today. We are not going to be the last generation living in the planet. We have to leave the planet in such a way that the coming generations are going to be also living the way we are living today. Okay? So that way, when we make it, we found out which are the highly energy consuming process in our whole production. So the polydimethyl siloxane and the silicon metal from where we make that becomes an energy intensive process. We went through that complete audited way of making that raw material reduced to a very low carbon level. 100% clean energies are used to make that. Then this is converted into polymer, from polymer to the finishing plant. And then once the silicon sealant comes out of this, we have a carbon insert mechanism through Red+. So this is a highly rated mechanism to just sequestrate whatever is the remaining kg of CO2 released. So we are today the lowest carbon emitting sealant available in the market. And that can also be offset if you are interested to get a carbon neutral silicon. So we have a collaboration with Glass Wall System for last 2 years. They buy 100% of their structural glazing and weather sealant using a carbon neutral silicon. And coming on to a couple of examples of what is that we did differently. One is on a Citibank project in London, where we worked with the Permasilisa. And here what happened was they wanted to replace the glass from the existing building, but they want to reuse the same material in that. So there has been a good way of analysis. You can cut the silicon, but when it is coming to thousands of glasses, we came up with a hot knife technology to remove the glass from the frame and then rebond it using a fresh silicon, with leaving some layer of silicon. And this gave them an external opportunity to use the glass and then the frame, but with additional sealant. Why they did it is because this was a 25-year-old building. They wanted to know what is the durability of that. So for that, they removed and checked. They found the silicon was still working good. And that's where the 50-year durability of ours comes in. So, but still they wanted to change it because they wanted some aesthetic things to be built in for part of the facade. So they did that, but they could use the same material. At the end of it, how they did it is mentioned here. They put an additional frame from inside in addition to what they have done. And then they applied silicon extra. So this is one of the classic case histories where we are also acting responsibly in terms of how the material can be reused when it comes to the retrofit. So in the India, projects are aging. When it is becoming 20, 30 years, people would like to change the facade. When they change it, how we can do it responsibly, is an important thing. So this is another project wherein Enrico was the guy who managed this project. And this was, again, a beautiful example wherein they wanted to use the glass and aluminum again, but they had a limitation because the glass did not give them the desired performance. So what they did is they used our sealant solution as one of the flowable coating behind the glass of and they applied a 4 millimeter thickness, which gave them the desired performance, and that was then bonded to the existing structure. So it looks very simple when I am talking, but it goes through a lot of calculation, analysis, finite element engineering studies. All of that is being done to get to the right solution. Coming to what we do in India. So in India, we have a corporate office in Mumbai. We have a technology center in Navi Mumbai. And we have, close to 1,500 people are working here. We have 3 manufacturing sites in India, one in Taloja, Lotte, and Chennai. We have 3 centers of excellences. One is a Central Engineering Center, Dow India Technology Center, and then the Mumbai Global Accounting. So we also have a lot of global hubs present in India. So this is our Indian footprint that the pictures show that different buildings where we are operating with. We really care. The product can, however, be good. There are 3 things which are very, very important for us. When it comes to an application, any application, whether it is a bonding, sealing, or adhesives, the important thing is what you need to get is a right way of doing the application. So first is the design. You have to design the right amount of silicon to be used to take care of the loads. Second is the application. And third is the right product. If all these 3 things goes well, then the durability can be definitely ensured. So this is what we do here. We have state-of-the-art lab in Mumbai where we can do the testing for all your projects. We do close to 250 project testing here. Globally, we do close to 6,000 projects. And those testings are done from India lab for India. And then we also go to the site, do the quality check, then we provide a warranty. So these are the backup mechanisms which are important for anyone to be having a peaceful mind. And we also have an approved applicator program, Quality Bond program, through which we audit the facility and give them the certificate that they are our approved applicators. Just my last slide. So you saw many things happening. We are sustainable. We are leading on circularity. We are leading on refurbishment solutions. Now we are coming up with more solutions for you for your construction applications. We are launching 6 more products in end of October. So you can see we are coming into PU foams, very high strength adhesives, and also in some of the PU sealants for various needs. So thank you.
Thank you so much, Mr. Subramanian. That was a very informative session. I definitely have more questions on the cold welding of glass, which I'm going to ask him post in the networking session. Yes, but now may we please invite Mr. T.S. Aditya, Vice President, Strategy and Business Development, Q-Tone.
Good evening, everyone. I'm Aditya. I represent iClad, which is a division of Q-Tone. So our topic today is sustainable cladding solutions for high-rise buildings. Before we start, let us understand what exactly is a high-rise building. A building which is tall is typically called a high-rise building, but however, there is a specific definition. A building with an occupied floor level, which is 75 feet above the lowest access point of the fire brigade department is called a high-rise building. So if you historically look at the tallest high-rise buildings all across the world, most of them are from Asia and Middle East. So the tallest being Burj Khalifa, which is about 828 meters. The tallest 2 buildings in India are based out of Mumbai, which is Palace Royal and Lokhandwala Minerva, which is about 320 meters and 307 meters respectively. So before we get into the products that are used for facade, the intent of this presentation is to understand what are the most sustainable cladding materials, how do we select the right kind of cladding material for a facade, and what are the testing standards pertaining to them. If you look at the sustainable products that are there currently in the market, it could be terracotta cladding, timber cladding, stone cladding, sintered stone, and you also have bio-based composites. So what exactly are sustainable products which are eco-friendly, which are energy efficient, which gives you the right kind of thermal comfort inside, which are durable and weather resistant so that it can withstand any kind of weather conditions. We have a tropical climate where there are seasonal changes after every 3 months. And then at the end of the life cycle, the product should also have good recyclability. And of course, aesthetics is the last topic of discussion. But if something is not aesthetically pleasing, it is not the right product. And then it has a low carbon footprint. So when it comes to a cladding product, the 2 key criteria for any selection process is, one is UV and second is fire. How does the product perform against UV light and how does the product perform against fire? So any facade material typically are selected which are A1, A2 or B class materials, and there's a testing standard which we'll be discussing in the forthcoming slide. Similarly, there is a standard of EN 438 part 2 which states what is the defining criteria for a material to be shortlisted as an exterior grade product. Next, you need to have the right kind of installation system and the right kind of installation tools which will ensure that your product is installed without having any kind of additional stress developed in the system, and it makes a complete stress-free system. However good the product is and the system is, until unless you have a trained applicator and installer, you will not get the right outcome. So first, to understand what exactly is the impact of fire, we need to understand this graph between temperature and time. Any product undergoes a certain phase of this graph. For example, if you look at products which are A1, A1 category are those products which are completely non-combustible, which means that the product stops at the ignition phase itself. It will not go into the growing fire stage. So, for example, if you take something like a fiber cement board or concrete or rock wool, no component of the material catches fire, so it is completely non-combustible. Whereas in A2, for example, if you take glass beads are nothing but glass fibers fixed to each other with an adhesive. So the adhesive can thermally degrade, but the entire product structural integrity is not lost. So it goes from ignition to the growing fire stage, but does not grow beyond the growing fire stage. If you look at class B, these are flame retardant products, which means as soon as you remove the point of application of flame, the panel tends to retard flame by itself. So which means that the product will go from ignition to growing fire, but it will not reach the fully developed fire stage. So it will stop before the flashover potential. The moment any material crosses the flashover potential, the time it takes to completely ignite and then perish is very fast. So as you go from C to F, the time taken for the material to reach the flashover potential is extremely rapid. Any facade consultant or architects typically select products which are either A1, A2, or in the worst case B for facade. So when it comes to fire performance, A1, A2, and B are standards as per European norms. Now, some people talk about British standards, some people talk about ASTM standards. How do you compare these products is something which you'll have to look at. So A1, as per European norms, is called as non-combustible as per British standards BS 476. So similarly, whatever is A2 in European norms is classified as limited combustibility product as per British standards. Similarly, B is 0, C is 1 and 2, D is 3, and E is 4. So this table shows you how do you compare European norms with British standards. Similarly, you have ASTM norms where they talk about flame spread index. Flame spread index is nothing but amount of fire by length of fire. What do you understand by length of fire? Fire propagates horizontally and vertically. Horizontally because of material property, vertically because of natural phenomenon. Anything which is A1, A2, or B generally has a flame spread index of around 15, 10 to 15. So whether it is A1, A2, or B in European norms, it is still called as class A as per ASTM norms. So they do not distinguish between A1, A2, and B in ASTM norms. So this is with respect to the standard test process for any external cladding material. Our product is a sintered stone where we have tested as per this standard of EN 13501 part 1. This is the classification with respect to fire. It is A2 S1 D0. The product category is A2. The smoke index is 1 and droplet is 0. We have seen fire now. Now we have to understand UV. Majorly, most of the projects, the panels fade because of direct sunlight. There's a standard test as per EN 438 part 2, which says that every product has to be tested for 1500 hours. And after 1500 hours, you remove the panel and check the grayscale. Grayscale is nothing but degree of fading using a photospectrometer. Any product after 1500 hours of testing, if the contrast and appearance is 3 and 4 respectively, above 3 and 4, then it is categorized to be called an exterior grade product. If something does not pass this test, you cannot use it for exterior grade. So if anyone is asking for exterior grade product, you have to ensure that this EN 438 part 2 and part 6 is adhered. Our product is tested for 1500 hours, and then yes, if you compare the standard 3 and 4 for contrast and appearance, our product is standing at 4 and 4. So it is compatible for exterior grade performance. When it comes to natural materials, because of moisture, you have salt formation, which is called efflorescence. White patches keep forming. So there's a neutral salt spray test as per ISO 9227-2002. After 960 hours, it should not have any visible staining or white patch formation. So our product also has undergone this test and it has passed. Now in India, most of the cladding systems, I'm not talking about wet cladding at all, dry cladding systems, we either adopt a rain screen facade or a rear ventilated facade. When it comes to a rear ventilated facade system, there's a cavity between the wall and the panel. There's a 20 mm vent on top and bottom, and there's a 2 centimeter gap, minimum 2 centimeter gap between the panel and the wall. What happens is hot air enters into the cavity. Because of low density, it tends to rise up, and it gets flushed out from the top. So you're allowing heat to enter in, but you're pushing it out before affecting the wall and the interior temperature. So when a product adapts a rear ventilated facade system, it increases your energy efficiency by reducing your tonnage on your AC load. So you can save a lot of money in case if you adapt the system. This also has other advantages like reduction of moisture or vapor diffusion, substantially reduces your noise, your dB level, and the framework acts as bracing for your walls. So it ensures longer lifespan. So coming to the product that I represent, it's called sintered stone. Sintered stone is an engineered stone, which is made up from clay, feldspar, silica, bentonite, and titanium dioxide. This is a product which is produced naturally, but in a lab, where you are going to press it at almost with a machine capacity of 44,000 tons, and it is baked at 1200 degrees centigrade to get a 6 mm panel. So I can brief you more at the stall if someone is interested. So this product, compared to any kind of tile or a porcelain slab, it is much more stronger, more impact resistant, and its flexural capacity is almost 1.3 times of a normal tile. So it can withstand heavy wind loads and can take a lot of deflections because it has certain level of flexibility. So we also use titanium dioxide in the glaze. Any product which has titanium dioxide in the glaze, it helps in two ways. One thing is the surface becomes self-cleaning, point one. Second thing is it helps in air purification. So whatever SOx and NOx, which are formed from vehicle exhaust or refrigerator manufacturers, once they get exposed to the surface in presence of UV, they are converted into harmless polyatomic ions. Last but not the least, it also ensures that the surface is super hydrophilic, which means that dust does not remain on the surface, and it is a self-cleaning process. So if someone talks about fire rating, whether you can give 60 minutes, 120 minutes, we can give that kind of fire rating, provided we use fire stops at all the dead wall openings, so that we use a rain screen facade, compartmentalize various zones of the substructure, so that in case if there's a fire breakout because of combustible materials inside the building, then the fire stop expands, it's like a foam, and then compartmentalizes from the rest of the substructure components, and then because of lack of oxygen, the fire tends to retard by itself, and then you can ensure that the fire does not spread to the adjacent compartment. We have a semi-unitized fixing system where we ensure that there is no shear load onto the sealant. Second thing is, there is no direct contact between aluminum and our product. So this system can be explained better at our stall because we have a hand mock-up as well, which will show you the complete detailing. So our product is 100%, we use green fuel. We do wastewater management. We use 100% recycled material for packing. 50% of water is recycled and reused, and the waste material can also be used for landfills. As far as our product is concerned, I have already spoken about UV fire, and then we have a semi-unitized modular system where partially it can be fitted in the factory, so work becomes absolutely fast. We have our product tested for 4 kPa, which means that we can do even maybe more than 50 floors. Depending on the wind load you give us, we'll design the complete substructure and give a complete solution for the product. And we follow a rear ventilated facade system, and our product is completely stress-free. All the expansion joints are maintained. So in case of any kind of extreme climates, we ensure that the complete system takes care of the expansions. We provide the complete solution right from the scratch of preparation of the concept drawing, preparation of mock-up, preparation of shop drawing, ensuring that compliance is followed during installation by our channel partners, and then we hand over the site successfully to our end clients. So a quick brief about the company where I work. This company is Qton, which has a head office in Ahmedabad. We have an R&D center in Italy. We have been there in India from 2008. We have launched this sintered stone material in 2018, where we are exporting to more than 12 countries. However, in India, we have started with the complete system in 2024. Our factory is at Convenor, which is around 4 hours from Ahmedabad. We have also launched a separate doors and windows division in aluminum in 2023, which is called DMOR. So we have been known in the market for our tiles and porcelain slabs, but sintered stone is a new technology which we have adapted from the last 5 years, and we have been doing more than around 26 running projects currently. Our largest project till date is about 38 floors, which is ongoing. So if you have any more questions, I'll be very happy to address it at our booth. Looking forward to interact with each one of you personally. Thank you so much for your time.
Thank you so much, Aditya, for your informative session. I think we are now all going to be looking at stone as a material as well. Yes. So I think a lot of you have seen me as a host, but I am primarily an architect. I am the co-founder and partner at Studio Emergence Mumbai and now also London. So I just wanted to give a brief introduction about myself and my company. Maybe please play the AV. So Studio Emergence was started by me and Sija Sudhakaran about 10 years ago, and we started with a dream that parametric design would become the core of in India as a practice. And I see now with a lot of more panelists also with Ashwin and Ritesh from Arup also presenting very beautiful projects. So I think it is going to be one of the future. At Studio Emergence, our design ethos revolves around parametric systems that not only respond intelligently around context, climates, but also user needs. We integrate biomimicry, optimization, driven design to achieve balance between performance and buildability. Our portfolio spans across diverse typologies and scale, from a planetarium to a science park in Navi Mumbai, to a bungee jumping arena, to a resort in Rishikesh, high-rise residential buildings, commercial buildings, and even now you must have seen the new metro station which has come up in the Aqua Line, which is also our concept design. Our London office is led by my co-founder, Sija Sudhakaran, who anchors our expansion into the UK and the Middle East. Sija is actively representing the studio through design discourse at the London Festival of Architecture, Material Matters, and through ongoing industry collaborations. Collaborations actually lie at the core of our practice. That's actually how we started our practice. By partnering with architects, engineers, and consultants, we deliver structurally optimized, cost-effective solutions that address complex challenges through advanced computational design methodologies. But we always say at the studio, let the complexities end at the drawing table, because we can make faster, better, and more sustainable buildings this way. Thank you so much. Meinhardt, Senior Director, Architecture, Talati and Partners on stage.
Hi, good evening, everyone. It's a pleasure to be here today. Thank you, Zak, for calling me. I'm really glad my session is after the coffee break. Everyone is at least not dull after the lunch session, so I'm glad. I'll just give a brief introduction about myself. I'm a senior director at Talati and Partners. Talati and Partners is a firm, architectural firm, which was started in 1964 by Mr. Nausher Talati. We are a more than 50-year-old company now. At Talati and Partners, our philosophy is deeply rooted in the principle of form must follow function. We design every project from the inside out, allowing the exterior expression to emerge organically from the interior spatial circulation and purpose. This approach results in a functional and timeless appeal, designs that retain their quality and integrity for the long run. Today, I'll illustrate the philosophy by walking you through two distinct approaches we took for two similar building typologies and how each was uniquely woven into the urban fabric of the city. Mumbai, as you know, presents a unique context for any architect. A city where a profound architectural heritage exists alongside the immense pressures of soaring density. This is the reality we design within. A city that braves seasonal deluges while contending with rising air and noise pollution. It is precisely these paradoxes that shape our design responses. Today we will be talking about two building designs situated mere blocks apart in the Worli precinct. This side-by-side comparison is fascinating because it reveals two completely unique architectural responses to the same urban context, each fighting the city's challenges and engaging with the streetscape in its own unique style. To understand our first design response, we must look at the powerful architectural language that already defines much of Mumbai's identity, its renowned Art Deco heritage. As you can see, the Marine Drive is not just a picturesque promenade, it is home to one of the largest and most cohesive collections of Art Deco architecture in the world. This uniform row of buildings from the 1930s and 40s is so significant, it's recognized by UNESCO. And this language extends beyond the seafront, permeating neighborhoods like Fort, Churchgate, Dadar, shaping the city's character through cinemas, apartments, and even humble petrol stations. This creates a powerful context, a living heritage. So the question for us contemporary architects becomes, how does one build today in a city with such a strong yesterday? Our first project in Worli enters into a direct dialogue with this very question. This is our architectural response. As you can see, we did not seek to simply replicate Art Deco forms, but to reinterpret its core principles for a contemporary context. We have abstracted the iconic vertical lines, the layered setbacks, and the streamlined forms, translating them into the architectural language that speaks to today while respectfully nodding to the past. As you look at the facade, you can see our design dialogue with the city's heritage. Instead of ornate pilasters, we use clean recessed glass panels and vertical stone fins to create that signature upward thrust. The building's massing steps back to echo the layered silhouette of the deco skyline, creating terraces and depth. We have replaced floral motifs and sunbursts with a more restrained language. The balustrade details and the carefully profiled overhangs provide the shadow lines and texture that give the building its character. But this architectural dialogue isn't just skin deep. If we now look inside the building, you'll see how this form is a direct result of the interior circulation and planning. The stepped elevation creates a rhythmic silhouette that recalls the layered history of Mumbai's architecture, from the deco setbacks to the modern towers. This slide visually deconstructs our form follows function principle. The profile in elevation is a direct graph of the interior experience. Each setback corresponds to a shift in the internal program. Here we visually demonstrate our inside-out design process. These four diagrams are a direct translation of the plan you saw earlier into the building's vertical expression. Each step back you see etched into this elevation is not arbitrary. It is the direct result of an interior function. The parking levels below, the common office spaces in the center, and then culminating into the private office headquarters at the top, connected to its own terrace and lounge. The building's profile is quite literally a map of its interior life projected into the city skyline. Now let's take a step back to understand the fundamental structural logic that gave rise to these unique stepped forms of the individual verticals. What you see here is the shape that is defined by the structure. This stepped vertical massing is an honest expression of the building's columns. The form is structured to wrap around and articulate different column sizes and shapes which vary based on their load-bearing requirements. Coming to the performance of the building, This animated sun diagram reveals the environmental logic behind our vertical massing. These vertical elements, which are a takeaway from the Art Deco style, actively cut the direct incident heat and glare from the sun. This choreography of light and shadow ensures that the building self-regulates its solar heat gain throughout the day, significantly reducing its cooling load and energy consumption. And this is measured in the results you see by achieving high and evenly distributed ADFs, annual daylight factors. We have guaranteed that every unit is flooded with natural diffused light. This minimizes the need for artificial lighting while strategically avoiding the harsh glare and heat of the direct sun. Now, while the overall form responds to the urban skyline, a building truly lives at the human scale. In this slide, we break down how we humanize the facade across 3 distinct experiences. At the urban scale, the building is a singular sculptural object in the skyline. At the street scale, the rhythm of the bays, windows, and planters creates a comfortable, relatable proportion. And then, most importantly, at the pedestrian scale, we introduce a layer of fine-grained details. Here at the base, the architecture becomes intimate. The textured planters, the shadow lines of the cornices, the delicate metal jalis, these are all the elements you experience up close. They create a play of textures along with light and shadow to create a more compelling experience at the pedestrian level. And then as we zoom in to the pedestrian level, this is where our design comes to life. The architecture is no longer about massing or diagrams, but about the experience. You can see how the sunlight filtered through the delicate metal jalis transforms into a dynamic pattern of light and shadow. A similar play of light and shadow can be seen in the close-up shot of the crown. This ever-changing tapestry animates the street, creating a rhythm and a texture that is both modern and deeply rooted in the traditions of this city. It's a dialogue between solid and void, light and shadow, permanence and transience. Our material selection too is a direct application of our philosophy. The function of the facade skin is to be durable, low maintenance, and to age with dignity in Mumbai's challenging climate. The form that follows is this robust textured granite step. The natural variation performs a function too, breaking down the massing, adding a human scale and variation for visual interest that avoids monotony. The mock-ups were the final crucial step to provide the functionality of our design, allowing us to refine the details for weatherproofing, structural support, and long-term performance. And finally, as the sun sets, the building reveals a different character. Our lighting strategy was to be an extension of the architecture, not a spectacle. The light is used to sculpt the form, not flood it. By gently grazing the vertical stone fins and washing the step backs from below, we create a soft layered luminosity. This emphasizes the building's verticality and its textured massing, making it a calm and elegant presence in the nightscape of Worli. This first project demonstrated a dialogue with the city's architectural past. Now, we shift to a project that looks firmly to its future. Our second project is a modern biophilic tower. If the first building was about weaving into the existing urban fabric, this one is about weaving a new green fabric into the city sky. It is conceived as a vertical ecosystem with terraced landscape decks at every level that directly confront the city's lack of ground-level open space. The form of this biophilic tower was born from a process of architectural carving. We began with a pure vertical volume, the maximum envelope permitted on this site. Then we started a deliberate process of subtraction. We carved out voided recesses from the solid block, not arbitrarily, but strategically. Each one of these carved out voids was then transformed. They became the terraced landscape decks that defined the project. So where the first building was an exercise in layering and addition, this tower is an exercise in sculpting and subtraction. The final form that you see here is a direct record of this process, a solid mass transformed into a porous, green-filled vessel. And then with the terraces carved out, we faced our core architectural challenge, how to give this sculpted form its strength and order. The answer was to weave a rigorous vertical column and core grid through the sculpted mass. Think of the carved terraces as the negative space and the structural grid as the organizing skeleton. This grid does not fight the organic form, it enables it. It provides the disciplined, efficient framework that makes the poetic undulating silhouette structurally possible. The landscape terraces now slot precisely around these columns, their form literally crafted and supported by this integrated structural logic. And here you have it. This render brings to life the concept, showing the building in its entirety. You can see how the cumulative effect of all those carved terraces creates a deeply sculpted organic form. This isn't a tower with gardens added on. It is a tower that is fundamentally shaped by its gardens. The terraces cascade down the facade, breaking down the building's scale and transforming it into a living, breathing landform in the sky. Now, if you see this, we analyze the form of the biophilic tower using the same lens we applied to our first project. You see the plans and elevations, but now the diagram tells a completely different story. The red line no longer traces a series of layered rectilinear setbacks. Instead, it charts the dynamic undulating rhythm of the carved out terraces. Where the red line in the first project indicated addition of form through stepping, here it maps the subtraction of mass to create voids. This undulation is the building's signature, a direct graphic representation of its biophilic heart, where the architecture recedes to make space for nature at every level. In our first building, the red line traced a formal layered envelope. Here it dances. These undulations are not arbitrary, again. They are a direct functional response to the interior. The landscape terraces are strategically placed to provide different use case scenarios for its occupants, creating double height amenity spaces, breakout terraces for offices, outdoor garden areas for living rooms and bedrooms, etc. And you can see it in this image where our design philosophy now becomes a lived experience. Is the realization of the void we carved from the massing. You are now standing within one of those double height amenity spaces. The soaring volume, the seamless flow into the terrace, the pool that mirrors the sky, this is the direct result of the formal subtraction we made. The void is no longer an abstract concept, but a vibrant sensory space for the user, a direct antidote to the dense urban fabric below. And again, the concept turns into a home. This is the ultimate realization of our biophilic vision. A double-height living room that flows seamlessly into its own double-height outdoor deck. The architectural subtraction we began with is now experienced as a profound spatial expansion. The boundary between inside and outside doesn't just blur, it dissolves. The interior space gains the feeling of the outdoor space, and the terrace becomes a true organic extension of the living area. This is more than a feature, it's a redefinition of high-rise living. It directly fights the constraints of the dense city by giving residents a spatial generosity and a connection to nature that is typically impossible in this density. Again, analyzing the environmental performance that's embedded within the design. This animated sun study reveals how the terraced form creates self-shading facades. As the sun moves, each terrace protects the level below from the harsh direct glare and heat gain, significantly reducing the building's cooling load and enhancing occupant comfort. Recall the paradoxes of Mumbai we began with. This diagram shows our architectural response to those very problems. The form actively fights pollution, both auditory and atmospheric. It manages the intense solar exposure and creates its own comfortable microclimate. This is how we use design to create sanctuaries of well-being within the demanding urban fabric. And of course, true biophilic design requires intelligent support. The irrigation system is the unseen counterpart to the visible greenery. By using moisture sensors and targeted delivery, it creates a self-regulating environment for the plants while conserving a precious resource, water. This closed-loop system ensures our architectural gesture is ecologically responsible and manageable for decades to come. The ultimate reward of the spatial strategy, uninterrupted visual continuity. From within the building, the double-height decks create breathtaking view corridors that connect the residents to each other and to the city. You're not isolated in a box, with sightlines that flow through the architecture itself. And looking outward, the sculpted form frames unparalleled panoramas. The terraces are strategically oriented to capture the best of Mumbai, the endless expanse of the sea on one side, and the dynamic energy of the city skyline on the other. The building doesn't block the view, it actively curates it, turning the entire city into a living work of art for every resident. This is a short animation, our design process for this tower. It was as organic as the form itself. We began not with the overall shape, but by planning each level individually. Designing from the inside out, ensuring every floor was optimized for its specific use case and relationship to the terraces. We then brought the digital into the physical realm, each floor 3D printed separately, allowing us to hold the design in our hands. We assembled the tower literally floor by floor, constantly modifying and adapting the design at every stage of this physical process. This hands-on approach allowed us to test the spatial relationships, the flow between the terraces, and the overall sculptural form in a way that pure digital modeling cannot capture. We could immediately see where a terrace needed adjustment, where a void could be better connected, or how the mass could be improved. And to the right is the final version of this design. That sums up the two designs and the way we have created two different approaches to the city's paradoxes within the same precinct. Thank you.
Thank you so much, Meinhardt. It was a lovely presentation. I think this project reminded me of the Kanchenjunga apartments and the visual connectivity. It was lovely. Next, we have on stage Gautam Basin. And of course, most of you know him. Let's please have a round of applause for him.
Yeah, I'm the face between you and your weekends. And I think we'll start with a panel discussion. Let the chairs get organized. In the meanwhile, I'll invite my fellow panelists on stage. Is this live? Yeah. I'm firstly a very important figure in the world of fire safety. We have the pleasure of having Mr. Santosh Warik with us today, who's the CFO MIDC and also a director of Mumbai Fire Services. Could we have you on stage, please? I'll follow that with two architects, starting with Mr. Aluk de Cruz, from a very celebrated practice, Morphogenesis. He's a partner with the firm. Aluk, could we have you on stage, please? Follow that with Nandita Agnihotri, Senior Associate from Manviwala Kutub and Associates. Nandita, and obviously, we wouldn't have a building with a developer in place, and we have a person who's responsible for fire safety. Can we have Mr. Apurba Maitri on stage from Phoenix? He's responsible, he's the head for fire safety. And lastly, a fellow consultant, Vicky Vora, from V3 Facade Design Studio. Before we start the discussion, I would like to maybe lay a little bit of a context to let everyone know where this discussion is coming from. We talk about building for safety, and facades a very important part of that. But I think, unfortunately, what ends up happening is facade also ends up being the most visible element when a building is on fire. What we typically see is this, whether it's Saltae, TVCC in 2009 that was caught fire because of Chinese New Year fireworks, Lacrosse Docklands in Australia. I think we always talk about Grenfell being the prime example of how not to do facades and how not to choose materials. Address downtown, something that's closer to us and still very fresh in our memories. We have our own fair share of fire incidents. Kamla Mills is still one of the most unfortunate incidents, completely avoidable. Commercial complex with a coaching center in Surat that caught fire. People had to jump off a relatively short building, but still ended up being fatal. Last year, a gaming zone in Rajkot caught fire. FIFC, relatively limited, but then it was one of the premium buildings that caught fire not too far away from here. These are some of the recent fire incidents. I think in the last 2 years, we haven't seen that major tragedies. We haven't seen that major loss of life or property. But still, some of the lessons that need to be learned, some of the lessons that need to be carried forward are with us. In terms of in terms of fire incidents in Mumbai itself, we're looking at two statistics. One is from 2020 to 2024, you see the number of fire incidents are gradually increasing. So that is obviously a reflection of the number of buildings that are getting occupied, number of buildings that are getting functional every year. That's increasing. But at the same time, what are the reasons for fire? So apart from general culprits like gas leaks, cooking, smoking, etc., you see the large part of fire responsibility comes from use of electrical equipment, poor faulty wiring, short circuits, etc. Now, what do the codes say about this? What are the prescriptive ways to get the design right? What are the prescriptive ways to get the right materials in place, the right kind of systems in place? And how does the world do it? Every incident around the world, every country has lessons learned from it. They evolve the codes around it. They implement them. UK post-Grenfell had to turn around 180 degrees and start looking at materials, specifications. Emphasis on prevention was number one, which I think is the right way to approach it. Make rules stricter, but I think there's also a legal responsibility, not just on the person who's building it, who's offering it for sale or lease, but also on the designers. And it's not just pure monetary penalty. You could be jailed if you put in the wrong material. Your insurance could be null and void if you've chosen the wrong kind of systems. Singapore has been doing the right things from day one, because what's interesting there is the firefighters are also the code writers. The Singapore Civil Defense Forces are the ones who are writing the codes for them, which I think is one place where we are lacking as well. Same thing with UAE. Their civil defense forces write very strict code requirements. After address, after a couple of other fires, they have also gone 180 degrees in terms of how they approach these codes. When it comes to codes that we use in the world of facades, is a table to the right. There are typically two approaches. One is reaction to fire. That could mean the kind of materials we use. And then second is actual assembly tests. The physical element being installed and then being tested. So these are the kind of codes that we use. So what do the codes account for? Now, when we talk about fire, we're talking about flame, which is flammability, physical burning activity on the material. There is smoke emission, which eventually leads to 70% of life loss in most cases. Droplet formation, which is also very interesting aspect associated with facade, because anything that sort of falls in form of hot droplets can lead to a secondary fire somewhere else. Is the system or material self-extinguishing, and is the system robust enough to withstand fire? So as you can see, there are no green ticks across all. So often we end up choosing a mix of codes. Let's take this from here, let's take this from here, and then we try and stitch together a fire-compliant facade. This is the Indian code landscape. So we typically lean back on British codes, on American codes, on Euro codes, on NFPAs. This is what our landscape looks like. We are due for an update in NBC, and we hopefully should see a more robust version coming up. National Building Code 2016, the concurrent version, Part 4, Fire and Life Safety, Part 6, Glass and Glazing is typically what we use when it comes to facade. A code came about 2 years ago, 2023, July of 2023, IS 18190, which talks about perimeter barrier system. That is just one aspect. But we still do not have a robust code for testing of materials. We're still relying on overseas codes. And then obviously, because NBC is a national subject, buildings are a state subject, there is a little bit of overriding that happens there as well. So we are leaning a lot on guidance received from CFOs, chief fire officers, their experience in dealing with fires in buildings, and exactly how do we react and how do we integrate that into the design. So I will now move over to the panel. I'll start with the first question, which essentially is an open-ended question and opens more about understanding of fire events. And it would be open to all of you. You can start in any sequence. So essentially, when a fire breaks out in a residential building, how do the residents, I'm saying residential building as an instance because I think that's what most of us occupy. How do residents, building management, security systems, and the fire department usually respond? And this is not really a question open to interpretation, but I think all of us have a version of an answer to that. So we'll start with Mr. Santosh, if you could start with.
Hello, good evening to all. As far as fire department is concerned, once we received call on fire brigade control room, means normally your smoke detection system will give alarm, and if you have a plan drill available with the residential building, if it is a high-rise building, then definitely your security personnel will raise the alarm, our communication will start. But responding to that particular call is a real question mark, because whenever we go for carrying out the mock drills or evacuation drill in the residential societies, on Sundays, normally the owner occupier will not come for the drills. Normally their house helps, their drivers will come for the drills and they will attend. So that is the practical thing. So as far as the National Building Code Part 4 is concerned, there is a separate guidelines given for how to do the training and how to plan your drill for every type of a building, maybe residential, business or industrial, whatever it may be. And what can go wrong and how many staircases are available, how many exits are available from your floor to the nearest exits. So if there is a fire in kitchen in a residential building, then you have to come out of that particular room, so you are comparatively safe. Then if you come out of that particular flat and your door is closed, again you are in common path of travel, so that is a safer area. And once you enter into the protected staircase, that is with fire door, so you are comparatively very safe, because there will be less chances of heat and smoke will penetrate into the staircase and you will get affected. And ultimately you will come down through this staircase to the ultimate safety, that is ground level. So normal, what we recommend, if you are not trained to deal with that particular fire, then you should show your back to the fire and try to get away as early as possible. If you are trained and you know how to use the fire extinguisher and you are confident enough, then you should venture. If the extinguisher is available in common passage, then you can approach with that fire extinguisher or hose reel hose that is provided in every lobby. So that you can use of that, or your security, trained security can do that. So that is the normal sequence what we expect from the occupant. But it is a cultural issue that chalta hai attitude is so strong in Indians that jo bhi hoga wo baaju wale ko hoga, mere flat mein kuch nahi hoga. So that attitude we have to change. And the best way is the education through schools, through architectural colleges, civil engineering colleges, electrical engineers. We should have such kind of a what to do in case of a fire, that should be taught. Then only that change, cultural change will happen. Thank you.
Thank you. Over to the architects.
So I'll agree with Santosh, and he's on the firefighting side. We are normally on the occupant side.
And I would say in most cases, we all know, we've all sat in offices, we've all sat at home. You'll hear the alarm go and you'll just assume that, that there's a mistake, it's a false. I mean, I can guarantee you, right now, if the alarm starts going off here, most of us will stay seated, we'll continue doing our session and we'll assume somebody will turn it off, But I've recently, I had a colleague of mine in office who had a fire above them. So nothing happened to them apart from the fact that when the fire engine did come and, they sprayed water everywhere, they had water through their house and everything, But I visited the flat above that, went through that fire. And it's amazing. We all imagine that, so you'll step in. You imagine if there was a chair there or a sofa, you'll see like the outline of it, the springs maybe, stuff like that. You'd assume that you go into the kitchen, you'll see the fridge, etc. You'll see the frame of the fridge. There was actually nothing in that house. It had all just evaporated. So that is the strength of fire in that closed environment, and we don't really know, and we don't assume it's that, but that's the strength. Yeah.
Nandita?
Sir. Thank you. So hi. Yes, of course, you both have framed it very rightly. I would like to say here, when it comes to about resident, there are two aspects to it. Then everyone has to be, of course, aware. And as sir has mentioned, that most of the time we try to make people aware, but they are, not available or not attending the same. So that is also adding a lot when it comes to the actual hazardous time. And I would say the signages, the maps and the plans and whatever the routes are should be really accessible, approachable to the occupants. And as well on the other fronts, when the firefighting team is coming to fight it out, for them also whatever necessary is required should be tackled rightly. There shouldn't be a compromise when it comes to a design as an architect I'm talking about.
Talk to the person who's building now. Let's get Khushbu, your views on this.
Yeah, so I represent building management or builder. So my perspective, Santosh sir has explained everything, what can go wrong and what we should do. But I would say taking all the responsibility for life safety aspect of building, that the best case scenario would be depending on two situations. If the socio-economic background of the occupant is at satisfactory level, what is the expectancy, and the building management's efficiency, if it is really playing a role, then the evacuation will not be challenging. On the other hand, the worst case scenario can be any. There may be panic if the systems or life safety systems are not in place, people are not trained, then God knows what would happen. So the approach here, people need to know how to react. The maintenance or management team play the role of training them in terms of evacuation or mock drill and effective communication. Time to time, and in case of emergency, also plays a very crucial role for effective evacuation. Thank you.
Yeah, hi. When we're talking about a residential building, the reaction to fire, we cannot expect more of professional approach towards fighting that fire. The first and foremost response, what we understand from the occupants, shall be out of fear and panic. Maybe a few of them might knock the neighbors' doors and either for seeking help or alerting or alarming them about the situation. A few responsible people who are aware of the situation, they might start dialing emergency numbers, like for ambulance, for fire department. But like sir rightly said, if you're not aware about the cause of the fire, if you're not aware about the potential of the fire incident, stay away. Do not try to become a hero over there. Try to escape from the situation, help others if you're able to, and ensure that the at least, if possible, in a way that we should have fire wardens, wing-wise, floor-wise, family-wise. They are being taught, trained to combat such situations, but in case fire incident occurs, they know exactly from which staircase they need to evacuate themselves and help others to save themselves.
Yeah. Perfect. That's a great segue to my next question.
There.
Good. Yeah, and this will be a focus question to the two of you. I'll start with Apurva. In your experience, do end users generally understand how to use the fire safety provisions in the building? I mean, we provide hose reels, we provide fire exits, we provide fire towers, pressurized areas, etc. Are people really aware when they buy an apartment or they lease a office space? Is there like any kind of guidance provided to them? Fire drills, perhaps? We'll start with you first.
Yeah, so as a builder, I would say it all depends upon the intent, how we are ensuring the basic safety system is provided, then it is maintained or keep in ship shape. And the second part is making the end user or residents aware that in case of fire, how they take part in the evacuation and how they facilitate the evacuation as a whole building. And in that, a well-managed building society management has all the responsibility to, form committee, form a sort of emergency team, fire wardens who will play their lead role. They might be a couple of security guards or maintenance team. So all in all, the team, if they are ready, residents, if they are conversant in case of a fire, what to do, definitely it will be success.
Santosh, sir, I'll also extend this question to you because I know you'll have a lot to say on this.
So as far as office buildings are concerned, it's really difficult because there are examples that one floor plate is occupied by 4 different offices. They have their own access control. Then there are few scenarios, the entire floor is occupied by a single user. Then there is a compromise of common passages. The reception will come in the common passage. The security guard will put his table in the common passages, which will obstruct the evacuation. So these lots of things happens once the occupancy is given. When the plans come to the fire department, that time it is a bare shell. There is no internal layout available. Only unit is shown. Okay, this much square feet or square meter unit will be there. But as per the owner occupier, once it is leased out or purchased by the owner, he puts his internal layouts and the fire load goes inside the different, means maybe server room, hub room, then your wooden paneling, everything comes up, glass paneling, everything will come up inside. And it will very difficult for the fire department to check each and every unit, whether the sprinklers are really catering the need, whether their detectors are very placed in each and every cabin or not. So that much means inspection and testing to carry out by the authorities, it's very difficult. So we have the licensed agencies in picture. So it is their responsibility to ensure that as per the internal layout of the system should be extended to each and every unit. And their manual should be given to them. So how they should react to that. And it is the owner occupier. As per the Fire Act, it is the responsibility ultimately to the owner and occupier because these are the leases. So they are not directly responsible, but it comes on the owner occupier to provide all that input to the occupier, that leases, and they should follow that. They should give instructions to their employees in case of emergencies, if you have 3 staircases, and there should be proper train or wardens should be appointed for each and every office, so they can take care of their employees in case of such emergencies. So if that way, if it is planned properly, then definitely we will be in a position to save life and property.
Thank you. But I think the point we are trying to almost conclude is that the buck stops with the person occupying the space. There has to be some level of seriousness in understanding that if it's a fire evacuation route, do not block it, do not use it as a storage. Make sure your sprinklers are fully charged, your smoke detectors actually function. So I think end of the day, the responsibility jointly lies within all of us. I'll probably now move to people responsible for the drawing board. And I think this is one of my favorite topics. It's almost a game of Chinese whispers that we play. When we talk about early design stages, I don't think we have access to authorities directly to sort of understand their asks and their needs. And there's always this discussion through a media called the licensing architect. And that often influences the visible elements on the building, whether it's operable windows or refuge areas, etc. How well do we understand? I mean, personally, I'll be very honest, I don't think I understand half of it when it comes through, but how well do we understand the requirements that come to us, and how confident are we that they're translating to the right solution that will provide a safer building to occupy? And probably any of the architects, and Aluk, you can start.
Yeah. Yeah, so I think you put it across quite well, Gautam, in your slides that you'd shown. So theoretically, we do have the National Building Code, but it is a prescriptive code, you know, the state does overrule. We do have an IS code as well. And I would say that the NBC, the IS code are pretty clear when it comes to a lot of the systems and how they need to be planned. But the actual architecture and how the architecture responds to fighting fire, both at a flow plate internally, you know, like we're looking at planning inward out, as against externally how the fire tender approaches and all of that, a lot of that is really not very clear, you know. Now, a lot of that, so we actually do refer to them as the fire gods. You know, because we basically say that it depends on, you know, what breakfast they had in the morning that they decide. But yeah, so there is a lot of ambiguity, those codes, unfortunately. And I do understand that a lot of that also comes through the kind of systems that they use. So the kind of, it's dependent on the technology that they have. So every different city tends to have different technology and to have different types of firefighting equipment. And therefore, that keeps changing. I believe, you know, the last point that you had mentioned, actually trying to cut the licensing consultant out. And we've actually found that they're actually quite approachable, you know, and it really makes a lot more sense to go and actually sit down with them, show them your plans, and discuss right there, because we found in the past that we've understood, you know, what they were trying to get at, and what their particular point was, but normally a licensing consultant would a lot of times just tend to put blanket points across, and a certain thing that worked for a certain project that doesn't necessarily work on another one. And so that's actually been our approach ideally.
So here I would say, yes, of course, when we are the planners, we start with planning anything. We put our experience to it, of what we understand about it, keeping ourselves in the place of the occupant, of the end user. We always try to thrive that we create spaces which are well taken about the security aspects as well. So we do use our knowledge to it, our experience to it, but there are places where, of course, we will be needing their inputs, for which, as he rightly said, we have been going by that media. Then, you know, we go via licensing architect, and eventually after moving on to certain stage, we come back and they say, no, now this is not approvable. You have to change it. Then that again, you know, creates a lot of this for us. So it's always better that we approach them directly and we try to get in everything at the plan level only. Like while we're starting any project, at that point of time, if we gather all the information and we try to put it together, it is always very beneficial to create a product which is not only functional in a way, it's not only for the space users, but it is always taken care in a holistic manner. Yeah.
Thank you. I think great points coming from people who start with the planning. Vicky, for you, I'll add a nightmare of a sentence, 1.5 meter by 1.5, side hung operable from outside. Please add your thoughts to that.
We are not good at space planning. We leave it to architects to plan the spaces for us. But yes, this 1.5 meter by 1.5 meter opening becomes a nightmare really to accommodate the intent, because architects would have spent a lot of time, lot of iterations have been gone through, lot of renders have been prepared, client would have asked for, and after that a particular scheme has been frozen. And then when we get such clauses, but then there are ways to mitigate and also inculcate those openables and make it a part of facade to look at, not to become an eyesore, but then it should gel up with the intent. That can be done. But in addition to that, we'll have to provide some more openables which are then designated for your fresh air ventilation. But nowadays we are lucky enough that over the period of time, all the stakeholders, the developer, the architects, they are also aware of all the components which add up to the passive fire protection, which we would say, which we take care of facades, which is the smoke sill, your automatic smoke vents. So that's understood very well amongst the fraternity. So answering the question, yes, with regards to facades, with regards to the compliances and provisions which need to be made, stakeholders are now gradually getting acquainted with, and they are now educated about it.
Yeah, great. I think it's moving in the right direction, but there's still a lot of Chinese whispers that need to be cut back a little bit, so we get more clearer answers. And I mean, I was smiling ear to ear talking with Santosh sir outside, and I was like, very approachable man, very clear in his ideas, extremely sure about what he wants, but it often gets lost in translation, and that becomes a problem. And we're half unsure whether this is what they wanted. It's almost like a picture you're painting inside a dark room. I'll go back to the architects for a second again. And this is more like a two-part question. We come very late into the picture. Potentially licensing architect comes early into the picture, but you may not have a direct link to somebody like Santosh sir at that point. What kind of due diligence is typically undertaken at an architectural drawing board when it comes to choosing the right materials, choosing the right system? And do you generally get an access to a fire specialist, somebody who could actually evaluate your designs to see how fire safe they are?
So in most of the cases in a normal practice, I would be honest, it's not always there at the stage when we are really doing it, and we should be incorporating it. In some projects, of course, we do have consultants, like we do have CFO consultant who we do go back and then, but the amount of involvement which I feel honestly should be there a little more to have a better design, have a better safe and secure environment, should be more catered to. That's what I feel at this moment.
I would have just added to that, I think on the facade side, there's been a lot of work that's been done. So a lot of the materiality over there, it's relatively easy. We are not really dealing with too many products nowadays that are, have problems. Like Vicky was mentioning, a lot of it does come down to the detailing though. So, the smoke seals, as well as the kind of active systems that you build in. So, smoke ventilation, all of that. On the interiors, I would say that is possibly the challenging side, because a lot of times you don't really have too much of control over that, apart from the common areas in a lot of spaces. And that's also a part where I would say the market and the kind of products available also tend to have just about every, kind.
Right. I think it's a fair response, and I really wish that there is access to people made available to architects who are especially making some of the key decisions in very early days where they don't have a full table of experts. So that'll always be desirable. I'll now maybe switch slightly technical, the question goes to the fire expert from the developer side and a facade consultants who sometimes double up as fire experts based on experience from previous project. The architecture intent has evolved now. You have a render, you have elevations, you have a set of drawings. How do you integrate the fire safety provisions or asks, you already have notes, you have a CFO approval note, which you have to translate to a build solution or a buildable solution. How do you integrate that to Façade's technical design and specifications? And then I sort of gave you a landscape of codes. What is the process there? Like, how do you pick and choose how to make a Façade fire safe? Now that you have a design ready, now you need to translate that into a technical solution. Vicky, you want to go first?
Sure. The moment we get the 3D renders or the concept from the architect, the clock starts ticking that what materials are we going to shortlist. So the way we start narrowing down the palette of the materials with respect to the intent, the first and the primemost aspect will be aesthetics, finishes available, and then third most aspect nowadays, even the developers, even the architects are also asking for is the material fire retardant? Does it have properly certified BS 476 EN 13501? Is the system NFPA 287? Also the fire stop smoke seal. Conventionally, we were using the rock wool and the intumescent sealant, but now we have again upgraded ourselves to the perimeter barrier as per ASTM 2307, ENBS 1364. So these codes are now getting into action on the design table in the material selection. Clients initially, if they are having some budget constraint, but they're not willing to now go with non-FR, non-fire retardant ACP. Rather, they themselves say, since I do not have a budget, let me just put a paint to it, but not dry clad it. There is furthermore advancement which is coming is towards cavity barriers on the dry cladding area as well. So these things put together are helping to make the facades more fire retardant, and of course the areas like refuge are being treated with at least EW 120 with 20 minutes of insulation, if not EI 120 minutes. So yes, we are getting closer towards accuracy to combat fire to the best possible ways.
Thank you. Apurva, a developer's feedback to that process. Now you have a technical solution which is in the process, you have a design that is finalized. As a fire representative, fire safety representative from a developer's end, how do you get into an interface with that to implementation on a building?
Yeah, sure. So it's actually a hand-in-hand activity. If architect intent is to be protected, then at the same time, the performance-based design of functional fire safety also has to be taken care of. And in that, as a fire specialist, we can help really choosing the right material, then reviewing the design, and the third part, which is the toughest of all of these, is execution verification. The contractor has to be wise enough, and we, while reviewing BOQ and material specification, need to know what sort of material he is introducing, whether that material is actually supporting me for building structures or, let's say, perimeter fire stop solutions, integrity, insulation, and the movement capability. If these are ensured in a single certification as a tested fire safety solution, then we are absolutely okay with that. And that actually is a key difference maker between a codal compliance versus performance-based design. And lastly, I would say that this passive system always has to go hand in hand with active system. The MEP fraternity also has to understand the coordination part. Once the passive is in place, then coordinated MEP system also should act, because both cannot be standing in isolation. So I need to really ensure that my building fire safety alarm system and automatic sprinkler system also has to safeguard my passive system. Otherwise, 100% achievement in terms of passive protection would be really a challenging or sometime myth. That's all.
I think there were notes to be taken in this question. We've actually covered architectural design, followed by the technical approach from a technical consultant, and then we sort of heard the right things that need to be done. So really well done on the answers on this question. But I think my next question is sort of answered already, so I'll probably move on to my favorite question. And I'm really capitalizing on Santos's presence here. We really don't get access to a CFO every day. And I know this list is long, but I would like you to maybe pick up your 2 pain points or gaps that you noticed in understanding. Now I'm reversing the question. We've received what we have understood, and now we've implemented it. You come and inspect the building. Where do you think the gaps are? Where do you think that the whole thing was misinterpreted or misunderstood?
So during our plan approval process and at the time of final fire approval, what I have observed is if it is a multinational company, then you will find 100% compliance as per the international, maybe NFPA or FM approvals, they will do the execution. So because the guidelines are given by their insurance company, so they will follow 100% as per that insurance company. Same is the case with any brand hotels or hospitals. You will find hardly there is any compromise related to compliances. They are much over and above the National Building Code requirements. They will go as per their own country's original standards or as per the NFPA standards. So that is one part. Secondly, first generation, some IT parks or business buildings are coming up. They will try to cut the corners with everything, not only about the fire safety or passive things or active ones, but the fire rating, because as per the codal requirement, you have to have fire rating of minimum 1 hour for glass facade on external side. And there is a provision that if you provide sprinklers up to 300, 450 mm from the glass facade, then you have to, you can use the toughened glass also. So considering this provision, it is, we are a developing country, we are not a developed country. So that things, somebody will certify it is because we don't have any testing mechanism available. And traceability is a major issue. So considering that, we have to take certificate from structural engineer that everything is as per the code. Whatever table 1 is given in part 4 of National Building Code, it is complying with that. And with that certification, we have to go ahead. But means whatever the best practices are there, they are followed by all good developers, builders, and means if they are coming up with good business buildings and hotel buildings that I have witnessed. But there are means just putting a metal sheet and with some concrete and showing it, painting it with the fire retardant paint and showing that it is a fire retardant sealants. And in 2 hours of visit of entire building, it is next to impossible to open up that and see. So in case of real fire, definitely it is going to compromise and leapfrog effect will happen and heat and smoke will travel to the upper floors. So that is going to happen. Ultimately, sustainability is more important. And through awareness, only we will be in a position to achieve that. So even in ducts, fire ducts, electrical ducts, because when we go, our final fire approval is the first document for obtaining OC. So that time they will say, we don't know the owner, means occupiers, they will require number of services to be levied from this. So we cannot seal the ducts right now. We will seal once it is, services are laid down. And it's very difficult for us to visit after every 3 months and ensure that all ducts are sealed at every level. So these are the practical difficulties what we face while giving final fire approvals. And we totally trust upon the developers and whosoever agency is doing that particular work. That is, these are the issues.
I'll pick that one statement you made that we are a developing country. I think there's a difference between it. That's the only difference between a developing and a developed country, where we're not cutting corners and we're not painting over surfaces to get a temporary approval, but still leaving a problem baked into the building. I'm really extremely keen to keep picking your brain, and I'll maybe raise one more question, which is more of a follow-up question to that. Like, there is obviously a process in place where you communicate the asks, they get translated into a built outcome. You come and inspect it. How do you? I'll probably put it up on the screen as well. Again, I'm sort of asking for only 2 changes. There are probably 200, but maybe limited to 2 changes. You have all the building stakeholders here. There are developers, there are designers. What 2 changes would you suggest to us? That could make fire incidents easier to handle and help reduce loss of life and property.
So we have in India sufficient codes and standard in place. We now, due to the various platform, the information is flowing through everybody's mobile. So what is happening in Singapore, what is happening in Dubai, and what is happening in Europe and US is everything is available on net. So best practices is all already there. The same developers, they are doing business in Middle East and Singapore. So there we are following 100% international standards. But once it comes to India, here that chalta attitude hai. One that piece of paper from the final fire approval and OC from the local authority or municipal corporation, if that is getting, and you can do anything inside. So unfortunately, we have to remove that particular thing. Means life safety, we have to give the paramount importance. So we communicate all requirements to the building. At the initial stage, whatever the requirements given, you have to appoint a qualified and technically sound agency to execute it. Maharashtra Fire Act has appointed almost 800 plus license agencies to execute that particular work for integrators, what we call, for doing hydrant sprinkler detection, manual call points, and passive fire systems. So if you appoint that particular agency, they will do their job, and they are, by act, they are liable for that. If they do any mischief and the complaints are raised, there is a provision that we can put them behind bar also. So if, as a developer, they appoint a proper person to do the work, definitely you can make a safe envelope for any type of occupancies.
Great, thank you. And I think I'll probably, given that the majority of this stage is involved in making some key design decisions, obviously execution, there are aspects, approval, there are aspects, and hopefully we never see a day where there's a fire in a building where sir has to bring his men and put them on harm's way. And this is an open question to all. Anyone can start with this. You think there is a better way to approach fire safety during the design process, something that we could change in the way we're doing things right now?
I just say, Gautam, that one term we used it 3 or 4 times, is best practice. No? And I think that there are these 3 or 4 terms that people use, during their days. And I think, like he mentioned, it's a shift. We all have to make that shift, and there is a lot of shift in the air as well. And this is something we've noticed in our practice. If we push a particular client, you push a particular client to either get the right person on board, push a client to maybe not cut corners on, even if it's, drawing up a plan and how he could maybe get a little bit more leasable as against what's the right way to do it. We have noticed that with a little bit of a push, people are, coming across. And I think it's that little bit that everybody has to do. You have to, push that chalta hai or that, that jugaad into the background for a second and just think what's best, and it will pay out in the long run, and that's what I think, it's that little bit everybody has to do.
So just adding to what he already mentioned, which I was, even we all feel that way, that is really important. I also feel the awareness is a very big factor, for which we should try to, work around something where people, of course, it shouldn't be as per their wish. They want to be aware of it. It has to be enforced as a law, that it could be a part of education, in school, colleges, wherever. It has to be widely spread in a way that it becomes a part of our learning to become, the way we are treating ourselves as an individual to grow. It is also a very important aspect for a person to be, aware of the things. And that's what I feel it should be enforced and make people aware of. That could also be a very big factor in change.
Purba?
So my 2 points would be here. One thing is that the collaborative approach while design or right from design to completion, their fire life safety consultant has to be brought in the very first place. That would actually rule out all the lag as well as lacuna. Lag in terms of time and supply chain mechanism, and lacuna in terms of non-compliance part in the performance-based design. Second thing is that end users' feedback is always important to get. The system or design once implemented, if it is creating hindrances or not making so much of efficient usage, then that part has to be really taken as a feedback from the user, and it has to be taken in next time design, maybe it is a prototype or implementation per se. Thank you.
Gautam, just most of the points have been covered by the panelists over here. So I'd like to highlight 2 points which we have faced in our projects. The first is about the architectural intent. Of course, the facade has to look beautiful. The facade is going to give the identity to the building. You can look at the building and say, wow, it's a nice residential building or a commercial building. But then some practices like having zero spandrel, which definitely makes the facade look more beautiful, but that could be the most unsafe practice in terms of fire, like sir mentioned the term leapfrog effect. So the moment we think about leapfrog, zero spandrel should be out of question. So we had to convince that particular architect over a couple of discussions along with the client, and finally the architect agreed, and we were able to convert the design. That's one. Second is the importance of human life in whatever part of the country we go is going to be the same. So then I slightly fail to understand why do we have different fire norms for different cities. Suppose I'm working for a project in Mumbai or I'm working for a project in Pune. Both the CFO compliances do not match, not tally. So if we can have a uniform fire norms, maybe we can categorize it residential, commercial, hospitality, hotels or hospitals, healthcare units. But standard terms throughout the country will make the designs more simplified, and maybe that mindset gets into place.
Amazing. I think some new perspective there. And interestingly, you said about zero spandrel. I also had the same conversation with somebody that said zero spandrel means zero safety. So that's where I'd like to end. Santosh sir, you can close with your answer, and then you can drop the mic.
As far as means common majority, see, ultimately building is a state subject. National Building Code is a national document issued by the Bureau of Indian Standards under the Ministry of Consumer Affairs. But ultimately, being a state subject, the state has the authority to do any, and fire is also state subject. So fire and building, both requirements are specified through building bylaws or through the Fire Act of every state. I would not place the Mumbai as a good example, because unfortunately Mumbai is a place wherein we are giving approval up to 70-meter residential building with single staircase, as we don't have space. Nowhere in the world such types of buildings are available. Above say 24 meters, you have to have alternate staircase for evacuation. But unfortunately, considering island city, we have to go vertical, and redevelopments to encourage that. That is a totally different scenario. But having said that, you have to have the common logic for everything. Unfortunately, the way NFPA 101 has got a manual, why this provision is there, what is the logic behind that? Unfortunately, National Building Code do not have that. So we have already recommended such manual should be made available for each and every part of National Building Code, which will help all the stakeholders, maybe fire officers, electrical contractors, civil engineers, structural, architect, everybody to understand why this provision is made, what is the logic behind that. So definitely this will help us. At present, depending upon, Mumbai has got 90-meter ladders, so they can do the firefighting from external side. Pune has got 70 meters, so they are limiting themselves from that angle. If I consider Maharashtra as a whole, rest of Maharashtra, I don't have any ladder beyond 30 meters also. So it becomes very difficult if I started leveraging that I have external capacities. And for your information, as far as India is concerned, as per 13th Finance Commission report, the gap of fire services in terms of number of fire stations, number of trained manpower and fire appliances is more than 80% across the nation. So considering that backdrop and the response mechanism in Mumbai or any city is concerned, as national norm says, within 5 to 7 minutes, the response mechanism should be available to any incidents. But considering traffic scenario, it is not less than 15 to 20 minutes in city like Mumbai, Pune. So considering all that aspect, we have to make the building internally safe with proper compartmentation, fire rating, and providing passive fire protection system and detection system and making the building more safer. Fire tower is a really good mechanism wherein you have the safe evacuation egress available for all occupants. So considering all that, definitely implemented in toto, because 100% implementation will not be possible, but reasonable safety should be provided for each and every building. And if all stakeholders, they come on table while they are planning the building from various aspects to make the building efficient at the initial stage, definitely it will make the difference. And the building will be more sustainable for any type of occupants. Thank you.
I think some thank yous are in order. I'd like to thank you personally, sir, for your services and for all that you do. You're the unsung heroes in our lives. Thank you to the panel for putting some very pertinent points. And I think personally, thank you to all of you who have stayed back, are leaving a little bit richer, and a moment of silence for people who left after Ashwin's presentation. So thank you. Have a good weekend, everyone. We close with that session.
Thank you, everyone.